Let me also emphasize that you are welcome to stop me and ask questions at any time. I'm very big on interaction back and forth, and also it's possible that I might overlook a question or overlook a particular concept in the book or something that I'm not explaining clearly. Please feel free to stop me. I do not mind that at all. So, just kind of want to make that clear from the beginning, just to make sure that everybody is comfortable, with understanding and kind of how we're going along. But like I said, it's the Introduction to Statistical Learning book, obviously a very important text when it comes to the world of data science. And I want to make sure that one of the things that I'm really big on is I'm really big on being intellectually honest, right? I don't want to steal any of the author's work. So I want to thank the authors of the book. And I hope to be building upon what they've already published, not copying, but building upon what they're doing. So I hope to be, paying them the proper respect with that. And, hopefully you'll see some new things as we go along, because I'm going to be, kind of adding my own thoughts and whatnot. Okay, so to kick off, I want to make sure that I address some of the chats. We already have an active chat. We haven't even started. We have an active chat, so that's wonderful. And again, feel free to stop me at any time. So let me make sure I look at some of the chats, and I can pop them up on the screen here. Actually, first chat is from Patrick. So Patrick is going to be acting as our moderator today. He's going to be helping me in the chat, just in case I miss anything. So thank you for that, Patrick. Llama Land says, hello, been waiting all day for your live. Oh, thank you so much. I appreciate that. Yeah, I mean, for me, it's morning. For me, it's 8 a.m. in the morning, but I do realize that for some people, it is later in their day. So thank you so much for staying up with me. Giuseppe says, saw your post yesterday on IG, and I'm currently reading the book. So excited to learn more about it. Yeah, right now is back to school time in some parts of the world, and a lot of parts of the world. So I'm getting this comment a lot where people are saying, oh, I just bought the book, or my class is in the second week of the book, or something along those lines. So yeah, so I'm glad it's lining up for you there, Giuseppe, and maybe I can just kind of give a different take on what you're going to learn in other ways. And like I said, I'm going to be adding my own twists and turns. I'm really excited to be showing some of those very shortly. It's going to be in some of my early slides, okay? 8G-Man says, looking forward to this. Thank you, 8G-Man. I'm looking forward to it too. Tariq says, will you post this as a video as well? Yes, absolutely, Tariq. Like I said, it's going to be on my YouTube. The replay will be on my YouTube. And then I'll post an alert on Instagram when that replay is available. It should be right after this session ends. And also keep in mind that the last time I did a class, we went for 2 hours. I expect that we're going to do something similar. So, if you have to step away, that's okay. Come on back. Maybe you missed the first hour. We'll probably be here beyond an hour. So come on back, check in. You can pop in late, no problem. Patrick, thank you so much for the assist there. Appreciate that. Joseph, hello, Dennis. Hey, Joseph, how are you? Good to see you again. Issa says, I hope next week we can have an overview of what topics will be discussed. I am still on chapter 2 right now. We're going to do that today. I'm going to start off with a philosophy and my goals for the class, and we'll go from there, okay? Tariq says, awesome. I'm currently traveling and can't join today. I greatly appreciate this type of content. Yeah, I can appreciate that not everybody will be available every time. So it will be, the replays will be available. Feel free to come back and look at them anytime you need. Hello, sir. I thought of starting the Python Data Science Handbook by Jake Vanderplas, but you are suggesting ISLP. Which one should I start? Issa says ISLP is a good start. It is beginner friendly. Ooh, I'm not sure if I'd agree that it's beginner friendly. To me, it's a book that is very hard to learn outside of the classroom. I mean, personally, I think I'm taking a big risk trying to teach the book. I mean, who am I to tell you how the book is? But what I'm trying to do is I'm trying to show you the real world side of it. And like I said, I'm going to be adding my own twists and turns. So, just hang around a little bit, Issa. I think your question will be answered, as we go along. Okay. AJ Patro says, is math a prerequisite to ISL? So AJ, I'm going to tell you no. And the authors will also tell you no, and I'm going to show that to you as we go along, okay? So great question, and, I see a lot of familiar faces in here, so I know you guys have attended my streams before. So most of you know how I feel about math and data science. I think the requirements are overstated. And, you know, I really don't agree with a lot of the data science influencers or other, you know, every once in a while I'll catch little glimpses of other accounts. And I really don't agree with people who overemphasize the math. You know, personally, I think it's an intimidation tactic, gatekeeping, whatever you want to call it, you know, where people overstate it. But, you know, I've been in the business for a long time in the real world, and I can tell you that you're mostly using libraries. So I like my staff, the data scientists who work for me, to have a good understanding of math, like a general understanding of what's happening, like, you know, kind of underneath the code. But if you're writing native math and having to look up formulas and things, there's something wrong in your process. You've gone off track in your process if that's the case. And also, you know, there's a lot of risk in writing your own math, right? I mean, having a math formula in front of you and implementing it properly in code are two completely different things, right? And sometimes those errors aren't obvious. Sometimes they're errors that you won't discover for years, and that's a massive problem, right? They can be very small errors. So I think you're going to be fine, AJ. You know, if not you, AJ, but anybody in the chat or anybody listening who feels intimidated by the math and data science, I get it. It can be intimidating, but don't be. I'm going to make it as easy as possible on you. I'm going to give you kind of my own take on some of the math, okay? Kartik says, I even started ISLP by myself. You're brave. You're brave, Kartik, so good for you. Good for you. That's a bold statement, so good for you, my friend. Siddiqui says, I am very excited about these classes. I am too. You know, this is fun. You know, like I've mentioned before, I will never, ever do pre-recorded instructional data science content. If you guys ever see me doing that, you can definitely say Dennis has lost his mind, because to me it's boring to put together. I can't imagine anything that I want to do less than sit here and put together pre-recorded data science content. And two, I think it's boring for you guys. You know, I personally don't sit through that content. I think it's boring. So why would I want to produce something that's boring for me and boring for you? So I do these live. You know, I stream as often as possible. I'm going to be streaming quite a bit, you know, for the next few months here. So hopefully you'll join me and keep on coming back. But yeah, you know, I'm looking forward to these two just because this is fun and, you know, lets me spend some time with all of you. Okay. Llama Land says, this book is more math oriented than the hands-on machine learning one. Not necessarily, my friend. Not necessarily. And I'm going to show you that. I'm going to show that to you. Okay. So I'm not sure if I agree with you. I think the authors do a great job of explaining it without requiring it, because, you know, ultimately this book is still very code-based. And when it's code-based like that, they're still relying on libraries. So yeah. So, so I disagree with it being more math oriented. There's math in the book, but it's not something that's, you know, like required for you to do in the book. Like if you look at their exercises, right? None of their exercises in the whole book, their labs and all that, none of them require you to write your own math, right? So that's kind of the measure that I use. Video Game says, hi Dennis. Hi Video Games, nice to see you. Thanks for joining us. Neiman Stravan says, this sounds exciting. Oh, well thank you. I'm excited too, so thanks for saying that. Llama Land says, I'm mostly afraid of the SVM math. It is heavily emphasized on duality and Lagrange things. Yeah, okay, but how many times are you going to be using that in your career? I mean, you know, you got to think about the practical side of it. I could think of 5 other things that you are much more likely to use than, you know, SVMs, right? So don't worry, we're going to be just fine. We're going to, you know, get through this step by step. You know, I don't think we get to SVMs for a couple of chapters. I can't remember what chapter number it is, so it'll be a couple of weeks before we get there. And quite frankly, you know, I'm just preparing the material as I go along. I've only prepared this week's material. I'll prepare next week starting like Thursday or whatever. Because, you know, we're just going to take it step by step. And like I said, I'll be showing you some of the real world stuff I'll be emphasizing the real world stuff. Okay. All right. So that was a good introduction as far as the chat goes. So you guys ready to get started? I'm ready here. So I'm going to switch over to my classroom view. We're still going to have the chat. So like I said, we still have the chat. You guys can still see me, and you're still going to see my desktop. My instructional desktop. Like I mentioned earlier, if you need to stop me for a question, please feel free to do that. I also believe in the Socratic method, so feel free to let me know. I'm going to be asking you questions, right? I'm going to be throwing out questions to the chat. So keep your speakers on, keep your headphones on. Feel free to participate as much as you'd like, okay? And there's no wrong answers, right? So nobody needs to feel like they're going to give a wrong answer, right? We're all learning. Amit says, hi, would you cover it application-wise and industry-wise? Maybe. I think the authors have something to say about that, right? So maybe, so I'll be pointing out some of those things. Okay, all right, guys, so let's get started. So I'm calling this the ISL book guided discussion because, again, my intent is to honor the authors, not copy their work. So my guide to you will be around the things that I find are important, or maybe I'll be expressing things in a different way than what the authors do, because I've seen it in the industry done in a slightly different ways, or just expressed in different ways. So that's really the goal here, right? To provide a guided discussion while still honoring the book and, honoring, really just the high level of instruction that's available in the book, okay? So today we're going to cover 3 sections. This is the first section. In this section, I'm going to give you a little bit of an introduction and my own philosophy. We're going to have a kickoff to explain how I see us working together, and then also a class agenda. All right. So the first part of my philosophy is that I take data science as a very serious profession. I equate doing data science like a lawyer or a doctor. It's an academic profession, but it's also a learned profession. You're going to learn things in. Sorry, let me get rid of this chat on my screen. You're going to learn things in the classroom, but you're also going to learn things on the job, right? If you're a lawyer learns a lot in school, but they don't learn how to always stand in front of a judge and be like a litigation attorney, right? That's like a whole other set of training they do after they graduate. So my intent here is to help you show you some of those combinations of the academic side and the real world side. And then you'll also understand that there is no shortcuts, no hacks to how we go about actually doing data science, right? We are not here to crack the data scientist interview or all those other things that you hear about. We are here to do, professional level work in data science. And then finally, a data scientist must maintain flexibility in thought, in their approach to problems, in how they see the world, how they see different models and the different business issues that are in front of them. So I'm going to try to put an emphasis on that for all of you here. Okay? All right, before I go to the next screen, quick question, guys. How does my audio sound? I just realized that I have my fan on above me, and I don't know if the microphone is picking up on the fan or not. What do you guys think? Is the audio coming through okay? Give me some feedback in the chat, please. Let me know how my audio is sounding, because otherwise I'm going to have to shut off the fan. Is everything sounding okay, guys? Okay, so Patrick says audio is great, no problem. Okay, thank you for that. All right, so next screen. As I said, I teach with the Socratic method, so I'm going to be asking you questions. So please, feel free to participate and let me know if you have any thoughts, or I'll be asking questions, getting feedback from you guys. So it helps the class go a little smoother that way. Also, you will not be ready for a job after this series, but I'm going to help you build a pretty good foundation. The ISL book, just to give you kind of the scope of things, the ISL book is typically just one course in a full master's study, right? So there's a lot more to learn, things that you want to kind of get deeper knowledge on from the ISL book. But I just kind of want to set that expectation for all of you that you should still be doing work on your own. You should be doing work beyond this book. Because again, our goal isn't just to land a job. Our goal is to dedicate ourselves to the profession of data science. That's kind of why I do these classes, because I want to build that professional mindset in data science. All right. All right. So thank you so much for the feedback in the chat. I'm seeing that the audio is good, so I'll keep it. Okay. So going to the next screen. All right, guys. So here's where it gets a little bit, more exciting, because this is kind of, where I'm adding my own secret sauce to the approach, right? So Introduction to Statistical Learning, ISL, has long been recognized as a book that gives you a really good foundation for professional level data science, right? I mean, this is not a quick tutorial or anything else. It's a very, dedicated book. It started off as ISL for R, which was known as ISLR. And then I think in the past 3-4 years, they've developed a Python version, which is known as ISLP, right? And we've already seen some questions in the chat about that, about, should I take this one? Should I take that one? Personally, I learned on the first or second edition of the ISLR book. So I actually took this course in R. And one of the things I've also recommended, if you look at my my roadmap for students, I recommend that everyone start with the R version. And even if your favorite language is Python, as it should be, take the R version and convert the code to Python. If you do that, that's a very valuable exercise for your learning. Okay, so something for you to consider there, guys. Start with the R version, understand the concepts, and then do the labs, but in your own native Python code. Super valuable exercise. So we have R, we have Python. My addition, my addition, or rather my intent again, is that I want to build upon their work. I want to build upon their work and, honor the ISL authors, because it's intellectually dishonest to copy somebody else's work, right? So my addition is that I'm going to do this entire course using Gen AI. So this isn't going to be ISLR or ISLP. I'm naming this ISLA. This dovetails into some of the previous videos and some of the previous content that I've developed about what the future of data science is, because I truly believe that this is the future of data science, where we are going to be code editors, not code writers. So that is something that I'm calling the blank screen effect. So nobody in data science, and even in code development and software engineering, should start with a blank screen anymore. There's a lot of industries that shouldn't start with a blank screen anymore, right? If you're a lawyer, an accountant, a real estate agent, a software engineer, and you're starting with a blank screen, you're done, right? You're done. You shouldn't be doing that anymore. And we as data scientists shouldn't be doing that anymore. So we are going to write. We are calling this the ISLA course, and we are going to have these goals, right? We're going to be data scientists that are heavily aided by AI tools for development. We're going to learn the concepts from each chapter, but then we're going to take that understanding to become prompt engineers and prompt an AI tool. And then our goal will be to edit and refine the code to reach a deliverable state, but we're not going to be writing any code natively, or as little code as possible natively. Okay? So that's really kind of the twist that I'm adding to this, because I don't want to sit here and write code on a blank Visual Studio screen, because that's simply not the way that you're going to be doing it in the workforce. I think in as little as 2 to 3 years, maybe even faster than that, maybe 1 to 2 years, right? So that's really, it would be worthless for me to just kind of teach you the book that way. We're going to look at it strictly from an AI perspective. So we're going to sit here, we're going to learn the concepts, we're going to use ChatGPT, and we're going to work accordingly. Okay? So I hope that that you find that exciting, because I really, I truly believe that this is the way of the future, right? A lot of when you hear about people being threatened by their jobs or having their jobs threatened, this is why, because you'd be starting with a blank screen and you'd be writing things that Gen AI can do for you very quickly. So our goal here is to adapt with the times and start learning data science as a scientist that uses Gen AI tools to assist their work. All right? So how do you guys feel about that? Everybody still with me? Send me some feedback in the comments, but I'm going to keep on going here. So here's what I think about the agenda. So I'm going to be going chapter by chapter, and I'm going to give you guided instruction for the highlights of the ISLA book. But you should still feel free to do work on your own. And I'm going to be giving you little ideas for things that you could be doing on your own. That's how we're going to close every class, okay? I'm not going to cover every single section, but I'm going to give you the highlights. And then we're also going to do 1 to 2 exercises as a lab together. And then you can build upon those if you'd like. And then I'm also going to be working off the ISLR version 1 PDF. You are welcome to work from other versions, but that's the one that I like. That's the one I learned on. It's the one, I'm going to be using the PDF on the screen, but it's the one that I have the hard copy for. So whenever you see me holding a hard copy, this is the R version. I've had this book forever. It's so dirty. I hate even showing it because I've had it forever. But yeah, so that's the version I'm going to be using. So feel free to follow along with the same version, but it's up to you, how you want to go about them. There's a couple versions available on the website. Okay, good. I'm seeing some good feedback in the chat. People are on board with it. Explore the beauty. Good to see you again, my friend. Says this makes sense. Good. Patrick says ready to build some Gen AI skills along with my DS skills. That's the goal, Patrick, right? Because this is going to be the future, right? If you're sitting there with a blank screen, that doesn't make any sense. So yeah, very much looking forward to learn this mindset, since how many courses think about that. Llama, I like to think I'm the first person bringing. I think I'm certainly the first person bringing this book in that way, right? The ISLA approach, right? I don't think anybody else is doing that. I know there's other people doing, obviously Gen AI with data science, but we're going to learn together here. But I do think that we are breaking new ground in that regard. But again, this is the future. This is the future of data science. This is what you guys need to be learning if you want to, kind of advance forward. So Melly Dare says you can find the book on Z Library. You can find the book directly from the authors. Because I researched this prior to starting, because I don't want to violate any copyright laws. I'm very big on respecting people's intellectual property. The authors themselves make it available. You can go to, thank you, Patrick. Patrick has put that in the chat. statlearning.com. They freely make it available. Anybody can download it. I don't think it's always been that way. When I first got this book, I think you had to provide your email or something like that. But now they just give it completely free. So Amit says, I'm here to revisit the ISLR book. It has been 6+ years since I haven't revised it. Yeah, that's a great idea, Amit. And maybe you'll pick up new ideas when you're looking at it from a Gen AI perspective, right? Because again, we're not going to be writing code. We're not going to be sitting here copying the code from the book. We're going to be using Gen AI tools. Joseph says, I like the idea of integrating Gen AI and DS as it will be the future. Yeah, great feedback, Joseph. Thank you for that. Glad to see you guys are on board with it. Again, I really think that this is the way all development is going. So I'm going to show you how I would go about it. All right. So let me see what else I have on the class agenda. So as I said, you are encouraged to get that PDF and get it prior to each stream session. My intent is to provide these classes every Sunday from now on. I make the announcements on Instagram, and I'll also I post some stuff in the community section of YouTube, and I'm not sure how many people will read that. But yeah, you're welcome to follow me on Instagram. Feel free to subscribe here on YouTube so you get those alerts. And the live streams will be hosted here on YouTube, as I mentioned earlier. All right, so these are the topics that I intend to cover. Or rather, this is what's covered in the book. General concepts is what I'm calling chapters 1 and 2. And then chapter 3 focuses on linear regression. And then you can see the different sections that are covered in each chapter. And after today, it's my intent to do one chapter every week. So some sessions will be shorter than others. But this is the schedule that I intend to keep following along with these chapters. So somebody mentioned SVM. Yeah, so SVM, we're not even going to get till chapter 9, which will be the second to last week. So that's 7 weeks from now. So if you're intimidated with the SVM math, that's okay. We're not going to be there for a while, okay? And yeah, okay, so before I go to the next screen, Melly Durr says, what is Gen AI, please? Okay, so Gen AI, we are referring to generative artificial intelligence tools. My focus will be on ChatGPT. You are welcome to use another tool. But basically, we're going to be asking AI to write the code for us. So that's what we're talking about when we're referring to Gen AI. So the ISLA that I'm proposing, the A stands for artificial intelligence, okay? Maybe it should be ISLAI. You give me some feedback on that, guys. I kind of like the ISLA, but you guys let me know if it should be ISLAI. Giovanni says this is going to be great as I am to start iMaths in data science. Well, great, Giovanni. Good to see you here. Isa says Gen AI is generative AI like ChatGPT. Thank you so much for the assist in the chat, guys. I don't always see the assists ahead of time, but thank you so much for jumping in there, guys, and helping each other out. That's wonderful. I love seeing that. AJ says, so it will be AI code and our job will be refactoring and debugging. Absolutely, AJ. That's a great way of putting it. So it's not just going to be about refactoring, though. I call it, you're going to have to be a data science architect or a software engineering architect, right? Because you're going to have to kind of see all the different pieces that you need in your code. So as a data scientist, you might say, okay, well, I need some code to do my training. I need some code to do my cross-validation. I need some code to do my runtime predictions. Let me make those separate classes. So I need 3 separate classes, and they need to talk to each other this way, and they're going to talk back and forth using this data approach. So you are still going to be adding all that design, that architecture level design, and then asking ChatGPT to write that. Right? We're not going to see a lot of that today, but in the future, we are going to see that where you are going to be more like, okay, it's not just ChatGPT, give me code. You still have to guide it and say, well, I need this object, and then I need this object to look like this because it needs to talk to this other object. And then I need the code to consume those objects, right? So you're not far off the mark, but it's definitely going to be more than just refactoring and debugging. You're going to have more of a design mindset to say, oh, okay, yeah, this is like my business stakeholders approach me with this problem, but this is how I see it in my mind. I need these objects, I need this data, I need to pull it from this source. So that's what you're going to be doing more of, okay, AJ? If I lost you in a couple of those terms, that's okay. It's going to make more sense as we go along in these coming weeks. Kartik says, is there any community or on any platform you guys are on? Kartik, not yet, but I am going to be launching a Discord soon. I have a Discord ready to go now. I just wasn't sure if people were interested in it. But yeah, I'm going to be sending out something on that soon. Okay, so bear with me on that. Ashish votes for ISLAI. Rahul votes for ISL-AI. Okay, I'm kind of liking both of those. Isa upvotes ISL-AI. I like ISLAI. So Explore the Beauty is the only one that's with me on ISLA. I kind of like ISLA, but there's clearly ISLAI sounds better, directs it to the uses and intended for this series. Okay. Or Joseph puts the I in lowercase. I'm wondering if that's intentional. I think it is, Joseph. But yeah. Sravan says, sorry to ask, but how can we reach out for any questions or doubt? Right here, Sravan, you're in the right place. So feel free to put them in the chat. I will try to address the chat. As you can see here, I do try to pause and address the chat. Or if something is not clear, feel free to put something in the chat. If I miss a question, I'm gonna do my best to scroll up, or maybe Patrick can remind me if I missed a question. But you're in the right place to do that. And like I said, I might start a Discord to help all of us kind of stay in contact throughout the week. But we'll see. Okay. All right. So let me go to the last screen in the intro here. So I want to emphasize something with you that, if you were to take classes from an Olympic athlete who throws the javelin, right, as an example, they're going to show you like the highlights, like the main like factors in how to do things, right? They're going to tell you like, oh, you need to hold your arm this way, you need to run this way, and then you throw it at this point. They're going to give you like the high level pointers, right? But you might have questions like, well, why does my wrist have to be this way? Like, how do I know where to put my wrist, on the actual thing? And that athlete is going to look at you and they're going to say, I don't know, I've just always done it that way. I've been doing it for the last 15 years. I don't even think about it anymore, right? So I'm telling you that I feel that way also, where there's going to be things that I've been a data scientist and a software engineer for a long time. So there may be times when I'm going to say something that is just normal to me, but maybe you guys don't understand it, or somebody who is new to the industry wouldn't understand it. So feel free to stop me and let me know when you need more detail. But there might be times when I'll tell you, I don't know, I just always done it that way. I just the way we do things, right? So if that happens, I'm kind of just setting that expectation with you guys, because it may very well happen. But just keep in mind that I may just gloss over things, not because I'm trying to be fast or anything, just because I haven't thought about it in so long. So bear with me on that, okay? All right, so let's get into section 2. So in section 2, and by the way, this is the second of 3 sections we're going to cover today, right? So in section 2, I have basically condensed chapters 1 and 2, and then maybe we can talk about some self-study that you can do based on chapters 1 and 2. And it sounds like some of you have already read chapters 1 and 2. So that's good, okay? All right, so again, I'm going to be trying to break things down for you in a simple way, in a real world way. So one of my biggest takeaways from chapter 1 is that what exactly does it mean, introduction to statistical learning? Like, it doesn't really like ring a bell in terms of like general topics or professions, right? So the authors establish that introduction to statistical learning is essentially data science. I think that they were maybe locked into the title because of the previous works that they had done. I think, what was their first work? I think it was Elements of Statistical Learning or something like that, ESLP. But this is basically a data science book. So I want to establish it to you from the beginning that when you hear ISL or the ISL book, you should be thinking data science, because this is essentially a data science course and it's a data science book. Personally, I took this course as part of a applied statistics master study, because that's what my master studies were in. I did it a long time ago, so data science degrees weren't even available then. And maybe you live in a state or a country where none of the universities that you're considering have a data science course. So applied statistics might be the closest you can get, and this book or this type of course would be part of that. But let's establish from the beginning that statistical learning is a synonym to data science, okay? The next thing that they emphasize, or that we think about when we think about data science, is we think about the different types of outputs. And the authors emphasize that there are quantitative outputs, there are qualitative outputs, and there are clustering outputs, right? Those are basically like the 3 things that data science can do. Okay, guys, so this is me using the Socratic method. In the chat, feel free to pick one of these and give me your 10-second elevator pitch on what's one of these outputs. What is a quantitative output? What is a qualitative? What is clustering? You don't have to do all 3. Just pick one. Hopefully you guys will pick different ones. What do you guys think? Somebody give me an example of these outputs. So I'm going to give the chat a couple of seconds here. But drop me in the chat. What do you guys think? What are we talking about when we mean quantitative or qualitative or clustering? Give me your 10-second elevator pitch. Don't be shy. Put it in the chat, guys. All right, Joseph says a quantitative output is one that yields a numerical value. All right, anybody else? I'm not going to give my answer right away, right? Because I don't want to bias you guys. Quantitative output is measurable. Okay, cool. Quantitative output is something we can count. All right. What about qualitative? Anybody want to take on qualitative or clustering? Quantitative output is like an output of a regression problem. Clustering is trying to find out a correlation among available data. Okay, Seed None, welcome to the chat. Thank you for volunteering for clustering. Qualitative says insight about data, maybe. Ooh, Ashish, but isn't everything we're doing insight about data? Give me a little bit more. I think you're on the right track, but give me a little bit more. But insight about data is everything. Is all data science, right? The three are all under supervised machine learning tasks from an ML perspective. Okay. Now remember, guys, this is all in chapter 1, right? So they haven't even proposed any models at this point. They're just talking in chapter 1, right? They're just kind of laying it out for you. So don't be tied to, oh, this is regression, or this has to be this, right? They're just talking in generalities here. So don't necessarily tie it to a model yet, right? Patrick says a qualitative output is a rejection of a hypothesis. Okay. Isa says regression is quantitative. Muhammad says clustering. Muhammad, welcome to the chat. I don't think I've seen you before, but welcome. Clustering, grouping according to similarities. All right. Melly Dare says qualitative is like colors, etc. We can't count it. Ooh. Melly, coming in strong with the unique description. Nice. You know what? I'm not hating that description, Melly. Good job. It's a unique description, but I'm not hating it. I think I'm with you. Okay, Kartik says qualitative is classification. Trap Bushali, Trap, welcome. I don't think I've seen you in the chat, so thank you so much for joining us. Qualitative is sentiment analysis. Okay. Give me a little bit more on that. You're not wrong. I like that you tied it to an example, like a programming example, but give me a little bit more. Why would you use it for sentiment analysis? 8G-Man says quantitative would be something like the average of a sample. Qualitative is the average of a sample A is bigger or smaller than sample B. Clustering would probably be seeing trends within a data set. Okay. Amit says clustering is something where things can be grouped on the basis of some common qualitative parameters. All right. What else we got? Quantitative outputs is like prediction of value, like house price. Okay. Qualitative is an output that helps use descriptors, words, pictures that help understand the nature of the data or observation. Yeah. Okay, Joseph, I like the way you put that. Oh, by the way, guys, no using ChatGPT. I forgot to mention that, because Joseph, you wrote a beautifully written answer, so it's almost too suspicious. But I'm going to give you credit for that. But no using ChatGPT, guys. All right, that's not quite the purpose of the exercise. Clustering is kind of sorting things like fruits. Okay. Quantitative is a numerical way to represent the output. I like the way you put that, AJ. No name. Welcome to the chat. I haven't seen you here before, so welcome. Quantitative is about finding insights or numeric forms about data, about relationships between two or more features of the world. Data about between two or more features of the world. Qualitative is about intrinsic contextual information. No name. I'm generally on board with your answer, but help me understand why it has to be two or more features of the world. Give me a little more information on that. What do you mean by that? Joseph says, promise it wasn't ChatGPT. Took a while to phrase it. Well, it was very well phrased, Joseph. So I appreciate that you took the time to do that. Good job, my friend. Qualitative has a spectrum. Okay. Okay. All right. These are all great answers, guys. Great answers. Some really, quality answers here in the chat. So my intent is not to signal out any one person because I don't want anybody to feel, bad about their answer. But you guys are definitely on the right track. So quantitative is definitely, I think most people got quantitative correctly, where it's some sort of a measurable output. Somebody mentioned house prices. That's definitely a quantitative output. There's tons of quantitative outputs. But basically, quantitative outputs is when you can put a numerical value on it. Qualitative output, somebody in the chat accurately described it as being like a classification problem, and that is 100% correct. You are typically saying, I can take in numerical inputs, but I want to give it a classification for some sort of a description. Or, somebody else also said about how it helps you to put it into plain English words. And that is a very good way to put it. Because classifications, those qualitative outputs, can be anything you want. You can name them whatever you want. You can have as many as you want, right? So that's what you want to take away from qualitative outputs. That it's basically different categories that you can have. And you can have 2 categories, 4 categories, whatever you want. It doesn't matter. Okay? And then for clustering, I want to find, somebody did it perfectly. Yeah, here we go. So Amit, I think you gave a great answer on this. Clustering is something where things can be grouped on the basis of some common quantitative, qualitative parameters. That's a great answer. That's a really good way of looking at clustering. Basically, you can say, I have these different items, and I'm going to group them by the different attributes that they have. Those are going to make my clusters based on the values of the attributes. And those attributes can be qualitative or quantitative. And I'm going to put them in these clusters. And then that way, and the reason you would want to do that is because then that becomes your model, right? For future predictions, you can say, when something has these attributes, go ahead and put it in this cluster, right? To get a little fancier with it, you can also figure out the clusters on a plane, and then you can figure out how related clusters are to each other, or how different items are related to that individual cluster, right? So that's why you would want to do that. So I think you guys did great in that. So a couple of things that I do want to point out, though, is that you shouldn't be thinking about them as supervised or unsupervised at this stage just yet, especially when it comes to clustering, because there are clustering approaches where it doesn't have to be supervised data. You can use clustering for unsupervised data. If you don't know what supervised and unsupervised is, don't worry. We're going to cover it very shortly. But remember, guys, this is just page 1, chapter 1, right? So it's too early to start kind of thinking ahead in terms of, it has to be supervised, it has to be unsupervised, it has to be this type of model, it has to be this type of data, it has to be a regression problem. Let's just accept this for what it is, right? We just have to understand what the different outputs are that are possible from models, right? And also, I think the authors lay this out because it's very difficult to come up with other problems or some business problem that you're going to face that don't fit one of these 3 items, right? There's usually some way that you can tie back all your future work, all your future models to one of these 3, okay? All right, Patrick is giving a shout out to Joseph for his description. So yeah, I love the fact that you guys are encouraging and helping each other in the chat. Keep that going, guys. All right, so let's go on to the next slide. Another thing that I really liked in chapter 1 is that the authors lay out these 4 premises. Or premises is my word. I don't think they call it that. But they kind of lay out these 4 different thoughts for you to work with. The first one is that the approaches in the book are the most widely applicable across industries, and I completely agree. So somebody earlier, when we were doing our intros, asked about that, can you relate it to the work environment, to industries? Well, the authors are already telling you, hey, this is what you need in most industries. We have intentionally picked these models because we think that these are the most applicable for you when you are in the real world. So that's why I didn't answer that question directly previously, because I knew I was coming to this. And the authors are basically telling you, hey, we chose these on purpose. We've seen these in industry and we think these are the most applicable. So keep that in mind as you go through the book. And just, kind of, you're in good hands in terms of saying, hey, these are the ones that you should be studying because you're going to be able to find applicability in the future. All right. Second item that they also emphasize is that no single approach is going to work in every single model, every single problem you come across. You're going to have trade-offs where one model would be good and maybe not so good. And the words you see in brackets there, and experiments conducted, is my addition, because the authors don't really say that, but this is what they're implying here, where you should never say, well, let me take that back. There's that old saying that when you have a hammer, everything looks like a nail, right? So you're going to be tempted to say, oh, I learned regression models today, so the next problem you come across, you're going to try to apply regression to it, right? But that's not the right approach. That's not a scientific approach, because the scientific approach is to conduct experiments and to try different models, right? You have these in the real world, you're going to have these champion model searches where you have a problem and then you try different approaches. Let me try a regression against it. Let me try gradient boosting against it. Let me try a neural network against it, right? So that's what the authors are trying to get across here, that you shouldn't get married or feel like only one model is going to work. You should be approaching it with an open mind and trying different models and conducting those experiments. And again, experiments is my addition. They don't say that, but that's really what they're describing. I mean, that's what we do. That's what I do with my teams. When I lead teams, we conduct experiments. That's the science part of data science, right? So that's the second part that I think we should pull away from chapter 1. The third thing, I'm going to read this verbatim. I don't like reading slides, but I think this one is worth reading. We assume that the reader is comfortable with basic mathematical concepts, but we do not assume a graduate degree in mathematical sciences. And they go on to explain a little bit in that section, in that paragraph. And this comes back to the previous discussion we had. Somebody asked about the math, and they were intimidated by the math. The authors themselves are telling you that you do not need a lot of math. And I agree with this. I have seen this in industry. I have led many teams throughout the years. I've hired dozens of data scientists and run hundreds, if not thousands of team meetings. And we've never once sat there and discussed math formulas back and forth. That's just not how data science is done in the real world. I'm going to show you a couple formulas to get you, off the ground, kind of understand the inner workings. But you don't need, this deep understanding of math, okay? And again, it's not just me saying it; it's the authors. The authors are saying this. I copied this directly from the book, and I did that because I know that a lot of you have approached me in the past about the math, and oh, maybe I'm not so good at it, or maybe I shouldn't take this course because of. Don't be intimidated, okay? You're going to be just fine. You need to have an understanding, but it's nowhere near as deep as some of these other books or other things you see on social media or whatever emphasize. To be frankly honest with you, when I see the videos or the postings where people overemphasize the math, that person has told me that they have zero real world experience. They're basically faking it. They have never had a data science job in their lives, because that's just not how it's done when you're out there in the real world. Okay? And then the last thing that the authors give in these 4 premises is that the book focuses on real-world problems. And they give you a lot of real-world data sets to work from. I'm not sure if we're going to be using the same data sets that they emphasize, but they do say that, hey, we've tried to make this as realistic as possible, and they've done a pretty good job of it. So, take those 4 premises as you'd like, but I think they're really important. That's why I pulled them out to highlight here, because I got a lot out of these premises, and I agree with them. I like their approach. So that's I think those are important for you to read. So make sure you catch those in your edition of the book. Okay, you guys with me? I think we're making good progress here. So give me some feedback in the chat. Let me know that you guys are doing well. But I'm going to move on to chapter 2 while I'm waiting for that feedback. And you know what? Here's another opportunity for you guys to participate. So chapter 2, they start off. Well, I don't think they start off. This is just what I pulled out. They start off. They wrote about predictions and inferences. Okay, so there are two things in data science also. And really some of these are kind of like statistics oriented. Predictions and inferences. Who wants to kind of give a challenge or take a shot at giving me definitions for each of these? You guys did great earlier, right? So feel free to do it again. You know, really short descriptions, and I'll even give you guys a hint. Because in my interviews, I give a question. One of my interview questions is, what is inferential statistics? And can you give me an example of inferential statistics? That is one of the questions I ask in my interviews. So I think this is really important. That's really why I pulled this out. So great. AG Man says, let's keep moving forward. Wonderful. Thank you for that feedback. All right, guys. So I'll give you guys a minute here to feel free to add your feedback. But tell me, what is a prediction, or what are predictions and what are inferences? In some cases, some people might say that they're the same. Are they? I don't know. But I'll give you guys a minute here. Tell me what are predictions and what are inferences. So give you guys a little bit to think about it. So Kartik says prediction is when is based on one variable or more. We try to predict another variable. Okay. Okay, Kartik. So now give me inferences. I'm going to take a little sip of water here. I came prepared, guys. Last time we were here for 2 hours. We might do the same. We might do longer. But I'm prepared. I got my water. I had a big breakfast. I'm prepared to be here as long as this takes. All right, so Kartik has volunteered his answer. Nobody else wants to participate? Melly Dare says prediction is to give the result without being sure about it. Okay. But Melly, isn't all of data science like that? Data science is really a kind of making educated guesses, right? Remember, guys, and we've talked about this before, data science does not give you the answer. It gives you the most probable answer, right? Never forget that. I want you guys to burn that into your brains. Very important to remember that. So, Melly, I'm on board with your answer. I think you're on the right track. But we're always unsure about our results in data science, right? So let me know if you want to expand on your answer, okay? Okay, Patrick says inferential statistics refers to calculating statistics from the data, like means, standard. Predictions are new data points that are statistically consistent with our data. Okay. Okay. So Melly adds inferences is to give the results based on what we see. All right. I can be a little bit on board with that, Melly. Feel free to expand on that if you want. 8G-Man says inference is what you conclude from your analysis, or prediction is what you expect to happen in a foreign data set based on inferences you made from other data sets. All right. All right, AG-Man. I think you've provided the best answer so far. I'm on board with that answer. Prediction is making a guess based on unseen data. Okay. I would refer inferential statistics to measurements of correlation or causation between two or more variables. Oh, no name. Good answer. Good answer. We're going to come back to your answer, my friend. I like the answer. Sravan says predictions talk about future and inference may be talking about why. Ooh, Sravan, I like it. I like it. I like it a lot. Wow, Isa, you guys are doing great. You're refining the answer with every message, because Isa writes, inference is based on the relationship of the variables. Love it. Love it. Great answer, Isa. Okay, guys. So as a group, as collective answers, I think we've gotten there, right? I love different elements of these different answers, right? Okay, so Kartik, we're going to go back to his answer. Prediction is based on one variable or more, and we try to predict another variable. Yeah, that's exactly it, right? We're taking what we know, and we're trying to make predictions on the future, on what can happen on unseen data, right? Somebody else wrote about unseen data. So that's a pretty good example of predictions, right? In other words, you could also say, if X happens, what is gonna be the result of result Y, right? We know that X happened. What is result Y? You're making that prediction, right? And then inferences, No Name, Sravan, and Isa, I think collectively provided a great answer. And, Isa basically sums it up, where inference is about the relationship between X and Y. In other words, what is the impact or I guess that's the best word for it. The impact. If we know that X has changed, what is the impact on Y? Right? Just because X changed by a value of 1 doesn't mean that Y will change with a value of 1. There could be like an exponential relationship there, right? Where X changes by 1, but Y changes by 2. So that's where the difference lies. Where prediction says X happened, what is Y going to be? Inference is X is this, but now it changed. X increased by 1 or decreased or whatever you want to do. What's going to be the effect on Y? So that's what you kind of want to do when you want to think about these, where what's going to happen in the future, and then what's going to happen because something else already happened. I also want to highlight 8G-Man's answer, because that was a really good answer about what you expect to happen based on the inferences you made from the other data set, because inferences can also be used for predictions, right? So I think you guys are doing great in those answers, but I want you to keep that in mind, that there can be two types of conclusions that you're coming to, okay? Let me look at some of the other chats. Yeah, Muhammad, that's a pretty good answer. Predictions are the results of new instance based on past experiences, yeah. Inference is providing evidence to your hypothesis on the basis of parameters. Yeah, that's a good one. Joseph, yep, I'm on board with your answer. Seed none, did you just describe classification versus regression? No, I did not. So seed none, like I mentioned earlier, right? We're still in chapter 2. Okay, this is I think page 10 of the entire book. So don't jump too far ahead on me. Don't think about models. Don't think about business problems or anything else. Just take in the data, right? Because all we're doing is establishing the foundation for what's possible within statistical learning, within data science, right? That's all we're doing right now. So I love that you're participating, but let's try, all of us, to not get ahead of ourselves. Because it's easy to kind of get drawn in by the modeling and everything else. We're just talking here. We're just talking. Establishing a foundation, right? So inference is correlation of two variables. It can be, yeah. You can use inference for a correlation, sure, because it will tell you a little bit about the relationship between the two. It will also tell you if there's a relationship at all, right? The inferences don't have to exist. Sometimes they do. Sometimes they don't. But yeah, Kartik, that's if you want to think about it in those terms, yeah, I'm on board with that. All right, let's go on to the next section. So this is one of the charts that the authors put together, and it's a chart where they ask you to think about interpretability versus flexibility, and they're giving you an idea of some of the different models that you could be using along the way, and as far as how they grade on these two scales. Sometimes these will be important, other times they won't. Interpretability is a big topic when you get to the business world. Some models require a very high some problems that you have that you're going to come across in the business world require a lot of interpretability, others don't. So that's going to affect your model selection. So as an example for that, the example I always give to my teams is that if you're working for like a bank, like let's say you're working for like a credit card company, and you use a model to help you determine whether you give somebody a credit card or not, right? Like a credit scoring model. In the US, it's illegal for you to deny somebody without giving them an explanation of why. You can't deny somebody and not tell them why. Maybe that applies in your country, maybe it doesn't. But that's a place where you need a model with high interpretability. You can't just say no. You have to say no, and this is why. So now your selection of models has decreased a little bit, right? Because now you are required to use a model that has interpretability. Are all problems like that? No. Some problems you don't care why. You just want the better answer, right? So you keep this in mind. That's why this chart jumped out at me, because that's one of those real world things where you're only on chapter 2, so you're thinking to yourself, well, why do I need to know about interpretability, right? Well, that's why, because in the real world, that's going to be a big topic, whether something needs to be interpretable or not. All right, guys. So next chart. There, again, we're talking basics here. Supervised learning and unsupervised learning. Somebody brought this up earlier. But yeah, so now is the time to think about this. Give me some definitions for supervised learning and unsupervised learning. And again, this is a question that I ask in interviews. In fact, it's usually my first question. I love kicking off interviews with this question. My question is, what is unsupervised learning and what is supervised learning? And give me a real world example of each. So you guys are welcome to answer either one of these or give me an answer to the interview question. But you're going to come across this in interviews, guaranteed, right? So go ahead, chat. I'll give you guys a minute here. Let me know what is supervised learning and what is unsupervised learning. Give you guys a second here. I'm going to take a short little camera break so I can adjust a couple things on my end. All right. Okay, so Kartik, I love your speed. You're always fast with the answers. Love it. Supervised learning is when you have a label, and unsupervised learning when you don't have a label in your data. Okay. Any other answers? And Kartik, if you want to go for the interview question, let me know. Give me a real world example of each one of those. Melly Durr says supervised is having the answer and the questions, and we want to teach the robot how to find the answers. Yeah. I like it, Melly. Anybody else? Supervised learning, Isa says, supervised learning, the model knows where the output will be, while unsupervised has none. Okay, I'm on board with that. Supervised learning requires labeled data, while unsupervised doesn't. An example of supervised learning will be having data on which every sample has an etiquette attached. Unsupervised will miss the etiquette. Okay, Seed None, I'm on board with that answer. She says we have the input as well as the true output while training the data for supervised learning. I like it. Supervised learning is training model based on labeled data, which is telling the machine to learn the problem with answers. Yeah, I'm on board with that, Llama. Supervised learning is when we wish to predict y from x and you know what y is. Unsupervised learning is when we wish to model underlying structure of x. Patrick, I'm on board with that. Thank you. Unsupervised, I think Sravan is providing an example here. Find patterns segmenting customers on purchasing behavior. Yeah, perfect example. I would definitely accept that example in an interview. So good example there, Sravan. Dragomir says supervised means that we already give the answers to the model and it learns based on those. Yep. Supervised is we have just the questions and the robot has to find the results by itself. Yep. I like that, Melly. She says supervised learning example, predict height for a given age. Yep. Yep. In fact, I think that's in their book or in somebody else's book. Explore the Beauty says supervised learning is concerned with training a model of label data and using it to make predictions based on unseen data. Yeah. Okay, good. Lots of really good answer here. Yeah, Muhammad, I'm on board with that answer. Joseph, also on board. Okay, so you guys seem to have a pretty good view on supervised versus unsupervised. Siddiqui Diaby, welcome to the chat. I don't think I've seen you before, but welcome. Supervised learning is when there is pattern in the data and the machine learns from that. Okay. Joseph says unsupervised learning is like exploring a new city without a map. The model looks for patterns or groups in data on its own without knowing the right answer before. Yeah. That's a good answer. All right, so you guys are coming up with some great answers for unsupervised and supervised, so thank you so much for that. So let me ask you this as a follow-up. Can unsupervised learning become supervised learning? Can do these kind of cross over? Can you have unsupervised learning that becomes supervised learning? Because you guys have a pretty good idea of what each one is. I think everybody basically gave a good answer. But what about crossing over? What do you guys think about that? Let me know. Give you a couple seconds to think about that. Can unsupervised learning become supervised learning? And if so, how? Or if not, why? Okay, Seed Nun says yes. Okay. How? Okay, yeah, perfect. So Servan hit it exactly on the head. Yes, because we can label data. And that's exactly right. That's exactly the answer. You can turn an unsupervised problem into a supervised problem. You could take the time to label your unsupervised data. And I bring that up because that is dealing more with your stakeholders, right? How you manage your stakeholders. Stakeholders are going to be critical for you to be working with because ultimately they're the ones that you're serving with your algorithms. Like you're trying to solve their problems, right? So sometimes you won't be able to find a valid unsupervised approach to a problem and you're going to need supervised data. You're going to need labeled data. So these are the interactions and quite frankly, the negotiations that you're going to have with your stakeholders in the future to say, hey, we're a data science team, but we don't know your data. You guys know your data, so can you label 5,000 records for us to help us in this effort? And that's like a whole other process, right? Stakeholder management is like a whole other thing you have to master as a data scientist. And I have some resources that I'm going to be releasing to help you guys with that. But that's why I asked that question, because you should know that you can get to labeled data. But it's not always easy. It's not always a straightforward path, okay? So that's why I wanted to bring that up so you guys can kind of, keep that in the back of your mind. But you can turn unsupervised data to an unsupervised problem into a supervised problem, but it's usually going to require the help from the business, all right? Okay, guys, so I love the feedback. You guys are giving me some really good stuff. So let's keep going. Love the progress we're making, guys. Okay. Scalar outputs and categorical outputs. What are these? Hint, hint. We talked about these earlier. What do you guys think? Scalar outputs and categorical outputs. What are they? And on the previous question, Kartik says, not perfectly because there will be wrong label in data during unsupervised. Absolutely, you're correct. But again, that comes back to the whole, the item that I said earlier. That's going to require a negotiation on your stakeholders. Because labeling data is not fun. It's not fun for you, it's not fun for them, right? So you're going to have this back and forth with the stakeholder management. And you're right, Kartik. There could be errors, right? The labeling has to be quality labeling still, right? And there's ways to do that, right? I recommend you have to have a minimum of 3 people. The 3 people work independent from each other, and on the back end, you're doing like a polling on the answers, so on and so forth. But talking a stakeholder into doing that is like a whole other discussion, right? But Kartik, I just wanted to highlight your message because you're on the right track. Just because it's labeled doesn't mean it's right. So I love that thought there. So thank you so much for that. Okay. Yeah. So I'm seeing Patrick and Joseph. They're hitting it right on the head. And this is exactly why I picked this particular portion out of the book, guys, because I think that the authors here could have done just a little bit of a better job tying those back. But I'm presenting it here just to show you guys to not be intimidated, because you're learning all these terms, but the terms they're correlated, right? They're correlated in a funny way. So yeah, both Patrick and Joseph have great answers up on the screen in the chat. Scalar is your qualitative outputs, right? Categorical is your quantitative. Wait, nice. I'm sorry, I got that backwards. Sorry, I got that backward. Scalar is qualitative. Categorical is quantitative, right? That's it. So yeah, actually no, I think I had it right the first time. Yeah, quantitative is scalar, category is qualitative. Sorry, folks. I have a lot happening on my screens. I need to do like a behind the scenes so you guys can see what my screens are like. So I'm sorry that I'm a little loopy. But yes, you guys are coming up with the right answer. But again, the whole purpose here is just to show you guys that, don't get intimidated. There's a lot of new stuff coming at you, a lot of new terms, but a lot of the stuff is correlated. So when you hear about scalar and categorical, just think the qualitative and quantitative. In essence, we've already covered this, right? So that's why I pulled this out, because just kind of, take it easy, right? Don't be hard on yourself. Don't beat yourself up. It's a new topic, but they're all correlated, all right? So I hope that makes sense on why I wanted to bring that out. Okay, so now, I think this is the end of chapter 2, yeah. So to close out chapter 2, the authors get a little bit closer to inching forward to modeling, right? Because this is really, because remember, everything we've talked about before is just setting the stage, right? And in chapter 2, they close it out by talking about like your model accuracy. And again, I'm copying directly from the book because I think this is an important quote. No one method dominates all others over all possible data sets. So this is where I want you to start thinking about the experimentation mindset that you need to have as a data scientist. Because you should be trying different models on any problem that you come across. You might look at a problem and say, okay, that's supervised, or that's a supervised problem, that's an unsupervised problem. But that's really as far as you want to go in terms of your assessment. After that, you should be saying, well, I'm open to whatever model can solve this, so I'm going to try 5 models, 7 models, 10 models, whatever the case may be. But keep in mind, again, this is from the authors, no one method dominates all others over all possible data sets. Very important. You should be carrying that forward through everything you do in your entire career. All right. And by the way, guys, if you see me looking up here, it's because I have my classroom monitor up above. I bought this whole monitor stand and everything, so I've got multiple monitors here. But that's where I'm looking if you see me looking up over here. And then they also include their first measurement for model accuracy, and that's the mean square error, or the MSE. It's commonly used for regression problems, and it's measuring the difference between predicted and actual responses. What does your training data say that the responses should be versus what does your model say the answer should be? What is the mean difference between those, or between the errors that those two models make, right? So this is kind of how, again, they close the chapter 2 with these, because they're inching closer and closer to saying, hey, let's get into our first modeling. So I kind of want to, just kind of set the stage there, because I think it's a really nice segue, because now we're going to be talking about linear regression, okay? All right, so you guys with me? Anything on this last screen? Because our next screen we're going to be talking about modeling. So everybody good here? I think we should be good. But give me some feedback. Are you guys doing well? We've been going for over an hour, guys, so thank you so much for sticking in there with me. I see a couple names that have been with me since the very start of this stream, so thanks so much, guys. All right, any other questions before we leave chapters 1 and 2? This is a great time for it, guys. All right, Patrick says going strong. Good, glad to hear it, Patrick. Melly says yes, loving it. Okay, so Isa, you're asking a good question. I'm gonna come back to this, okay? If I forget it, let me know, but I'm gonna come back to this. You're asking an important question. All right, good. So I'm getting good feedback from you guys. All right, guys. So let's keep going. Give me just a second here to switch out one of my screens. All right, so chapter 3. So chapter 3 is our first modeling effort, and they start off with linear regression. And I think that's great. I think linear regression is a very good model to learn the basics of data science. So we're going to go through the chapter notes. I'm going to give you a framework that you would use going forward. We're going to do some labs, and then I'm going to recommend some self-study that you guys can pick up, okay? So, all right, guys, this is our first bit of math. Nobody panic. It's just some math. All right, so in the chat, what formula am I showing here? Now, you can think about it in a math perspective or just like a general perspective. It's not necessarily a data science question, but what is the formula that I'm showing here? Give you guys a minute here to think about it. What's the formula? What's the name for this? All right, cool. Patrick, Muhammad, I'm already seeing great answers. Joseph, yep. You guys got it. It's a line, right? It's a formula for a line. That's all it is. That's all regression is, right? And Muhammad, yeah, it's rise versus run, as Muhammad talks about the slope, right? It's rise times run. That's all we're doing. And really, that's kind of like what I want you guys to just take away, that you shouldn't be thinking about this as complex approaches. It's just lines, right? Angel Torero, welcome to the chat. I don't think I've seen you before, so welcome. But yeah, it's just a slope. It's a slope, as Ashish points out, with no intercept. So I just want you guys, everybody, just to calm down. All we're doing is just filling out this formula as our first data science effort, right? Y equals m times x. That's it. I think it was Patrick that mentioned mentioned the origin, right? Which this does go through the origin. Not everyone will, so we'll introduce that in the next slide. But yeah, but all we're doing is doing a line, right? So I want to make sure everybody kind of just relaxes. It's not complex math here, guys. Fernanda Vallejos. Fernanda, welcome. I don't think I've seen you in the chat. Thank you for joining us. Equation of a line, I think, is a translation. I think that's Portuguese. But yeah, that's exactly right. Okay. Amit talks about a Python, I guess a repository. Amit, I'm not a big fan of GitHub. If I release this stuff, I might release it on Discord. And I'll just put the files up there. But as far as GitHub goes, remember, we're not writing code, right? We're writing prompts. So I'd much rather just post the prompt file than anything else, right? So maybe you missed that part, but yeah, maybe some people join late, and that's okay. We're not going to be doing blank code screens here, guys. Okay? we're going to be utilizing Gen AI in a very heavy way to help us write our code, because that's really my own twist of what I'm adding to this process. This isn't ISLR, ISLP. This is ISL AI, because we're going to be using AI to help us with that. Okay. But really glad to see all the people that are joining us. I'm seeing a lot of new names, so thank you so much for joining us. Thank you. Even if you're joining late, thank you so much for that. We're almost going for an hour and a half here, so like I said earlier, maybe you need to step away. That's okay. Come on back. We might still be going. We might still be going 2 hours from now. Who knows, right? But thank you so much for joining us, guys. All right, next slide. This is an illustration of what we're doing, right? This is all we're doing, guys. And again, I'm putting these out there so that you guys can understand that it's not really intimidating. Data science really can be this simple. So what do we have here? We have our two axes. This is straight from the book, guys, right? Section 3. They usually label the charts. They don't have it, but this is like, I pulled this on page 62. So we have our line, right? Y equals mx. As Patrick pointed out, in the previous example, that was going through the origin. This one is not going through the origin. So this point here is known as the intercept, right? Where is it intercepting the y-axis? When we're looking at a chart like this, we have our independent and dependent variables. Our independent variable is going to always be the x-axis. Our dependent variable is always going to be the y-axis. In this scenario, it's TV. The TV spend on advertising happens to be the independent variable, and the dependent variable is the sales, right? So in other words, if I have this level of TV spending, what are the sales that I can expect based on that use of the independent variable? So this is known as a scatter plot. So this scatter plot with all the little red dots tells us what they've done in the past. The line is the proposed model to say this model captures these lines or these data points the best. And the lines in between the 2 points, these black lines, that's essentially the error that has happened, right? Or some people would refer to it as the variance between what you would expect versus what actually happened. So coming back to the earlier question about RSC tells you what happened in terms of errors of your actual model or your training data. Whereas MSE, the mean square error, is more about what happened between your predicted values and your actual values. So that's why MSE and RSE are very closely related, but it's where you're pulling those errors from, those variances from, that differs in the two models. So I'm getting a little bit ahead of myself, but I just want you to kind of think about this chart where this is all we're doing. We have our independent variable, what we can modify. We can modify our TV spend, right? And then we know that it's going to have an effect on sales. And then this blue line tells us what we can expect. At a spend of 250, we can expect this level of sales, because that's what the model tells us, right? And when I say model, that's what the line formula tells us. That's what I'm really saying, right? So keep this all in mind as we move forward. But it's not really complex, guys. It's just little components that we're putting together, okay? So Mosin, thanks for joining us. I don't think I saw you in the chat earlier, so thank you for joining us. So M is scalar. Sure, it can be. Yeah. And we're going to get into that right on the next screen. But yeah, M is usually scalar, and I'm going to show you why. Okay. So the authors put together these questions for linear regression, right? And in these 6 bullet points, I'm like paraphrasing what they wrote. It's pretty close to what they wrote. You're going to find a pretty good relationship, but it's kind of like my interpretation of their questions. And I think it's a good set of questions to ask, definitely for linear regression, but really for a lot of models that you're going to have out there, right? So, is there a relationship at all between X and Y? Should be your first question. The next question is, how strong is that relationship? After that is, how much is the effect of X? How do you find what X is to begin with? Right? How do you know that TV spend has that effect on sales? Are there other factors besides X, like a Z factor, right? Because there could be more than one factor, right? And then, is there an interaction effect between X and Z that impact Y, right? Because when you start talking about additional factors that you're taking into your model, well, now those factors have an interaction factor with each other that you have to take into account, right? But these are 6 really good questions that I think the authors are proposing. And I take that one step further, and I basically kind of give you some notes here, because this is why I think it kind of relates to each other, or how it relates to data science, or why I say that you should be taking these 6 items and carrying them forward. Is there a relationship between X and Y? Well, that relates to model selection, right? Because if there is a relationship X and Y, you're probably talking that it could be like a supervised problem. So now you can really only look at supervised models, right? How strong is that relationship? Well, you're really talking about errors there, right? The stronger the relationship, the lower the errors. So that's really what you're talking about there. How much is the effect of X? Is the weighting, right? Because how much do you want to weigh that value of X? How much of a weight do you want to attribute to that TV spend? Maybe it's high, maybe it's low, who knows? When you're talking about how do you find what X is to begin with, or how do you find if there's other factors like Z, well, that's your feature search, right? When you're talking about, feature searches or feature engineering or data transforms, all that stuff, that's what you're talking about, right? What other things could be affecting my model? And then lastly, is there an interaction between X and Z? Well, that's model experimentation, right? Now you're going to say, okay, well, let me try these multiple models. Let me try different hyperparameters. I'm going to do some tuning on those hyperparameters. I'm going to do a grid search. I'm going to do some transforms. I'm going to, bring in other data, right? Like data, some data wrangling. Like, this is all how it ties together, right? So that's why I'm providing, the bold is obviously my notes on it, right? But again, I just want you guys to kind of take a step back and realize that everything in data science is correlated, right? Because I'm assuming you've seen some of these other items, right? Where you have articles or other tutorials or whatever that have come across about model selection or your errors or this or feature engineering or whatever, right? This is all the same thing. There are other terms, other ways for you to think about it, okay? Shravan says, when discussing model selection, are we referring to supervised or unsupervised learning? Shravan, that's a great question. I would say this is the second question. The first question is being able to recognize whether you're looking at a supervised problem or an unsupervised problem. And that's it. Just make a distinction between the two, nothing else. And like I said earlier, that's where your decision should stop. Because you might be able to say, oh, yeah, that looks like a linear regression problem. But that can turn into a form of bias because guess what? Now you're only trying linear regression models. There could be other models that work better, right? So so model selection, to address your question exactly, model selection would be step 2. And model selection is a process of experimentation, not of your own bias of oh, well, yeah, this looks like it's regression, so let me only try regression, right? That's super dangerous, right? That's like a researcher bias. So love the question, Sravan, but it's step 2. Step 1 is recognizing what kind of problem you have. And step 2 is, okay, now I'm going to experiment and try to find that model. Okay? Great question. Love the question. All right, guys, so let me go on to the next slide here, because I think the next slide is a good one here. So we're going to refine our previous formula. And this is the reason, and by the way, you'll note that I'm doing this slightly different than the authors, because the authors use like a beta value and things like that, which obviously is not incorrect, but y equals mx plus b is how they will teach it to you if you take a dedicated regression methods course. And if you're in a study program, you're probably going to have a dedicated regression methods course. But y equals mx plus b is a very common way to express a linear regression formula. So, as I said earlier, y is your dependent variable. What's going to change, right? Or what is dependent on that model. X is your independent variable, the thing that you can modify, that you have control over to change. M is what's referred to as your coefficient. And B is what your intercept is, right? Because not all lines pass through the origin, so you are likely to have an intercept value when x is 0. So that's what B represents. Okay? So y equals mx plus b should be something that you burn into your brain, because a lot of what you do, especially early on in your data science studies and in your career, all can be traced back to y equals mx plus b. Another reason why I bring this up is because every once in a while you kind of catch this in a chat or some sort of discussion online where somebody like me, like one of the older guys, will come back to you and say, well, everything in data science comes back to linear regression. Everything can be explained with linear regression. That's what they'll say in the chat, and then everybody else jumps on, oh, you don't know what you're talking about, old man, or okay, boomer, and all that other stuff, right? But they are correct. Everything does come back to linear regression. And the reason I say that is because it all essentially comes back to this formula. What are you trying to guess? Or what are you trying to predict? What are you using to predict? And what is the value? What is the weight that you want to assign to that variable? I guarantee you that everything you do in the future is going to be related to what I just said. What are you predicting? What is the factor that you're considering? And how much weight do you want to add to that factor? That is data science in its most simple terms. I mean, think about, we're getting way ahead of ourselves, right? But just to kind of prove this point, think about a neural network, right? What is a neural network? A neural network is a collection of nodes that sit there and do a formula, and they either activate or they don't, right? They sit there they take in some inputs with an activation function, and they fire or they don't, right? They activate or they don't. Same thing, right? They're taking in the items. The activation function says, okay, these are the factors, these are the weights. I'm going to decide yes, no to activate or not. But again, it all comes back to what are the factors you're giving me? How much weight am I assigning to those factors? And I'm either doing something or I'm not. So again, I want you to kind of burn this into your brain. Y equals mx plus b, super important for you to learn. Okay? Next slide. I also just kind of want to make sure I emphasize this to you that I use y equals mx plus b, but I want you to recognize that you could have multiple factors. It's not always a one-to-one relationship with the factors. You can have multiple factors that influence the value of y, that influence your dependent variable. You can have multiple independent variables. Sometimes it's one, sometimes it's more than one. It just depends. Okay? To highlight again what we looked at, kind of just bring it all together, right? Sales is what we're trying to predict. We know that our TV spend is a big part of that. We know that m is some sort of weight, some sort of value we want to associate with that. But just to keep ourselves honest, it's called the coefficient. And then b is the intercept that you want to assign to that value. Okay? And then here, I'm just explaining it in a different ways, right? Sales is dependent, TB is independent, m is the coefficient or the weight, and then b is the intercept. But it's the same graph that we started off this whole discussion with. So not a lot of complex math, it's just a good model. And again, what are you trying to predict? What is the feature you're going to use to predict it? And how much weight do you want to add to that feature? Every data science problem you'll do in the future is exactly like that. All right, any questions before I go on to the next one? We're getting close to doing coding, so let me know if there's any questions. I'll give you guys a little minute here. You guys with me? Thanks for the assist in the chat there, Patrick. All right, give you guys another minute here if you have any questions. But we're getting close to using our coding here, guys. All right, good. Everybody's doing well. All right, so let's keep moving forward. This is from section, you can see here, 3.12 in the book. And I wanted to make sure I include this so that when you go and study later, you can tie this back to what you're seeing in the book. Because in the book, they talk about this in terms of the hypothesis, well, the null hypothesis and the alternative hypothesis. So here, look at this line here. There is no relation between x and y. That sounds suspiciously like one of the 6 questions we asked, right? Because it's possible there's no relationship. There's no model to be had. Right? So that's the first, that makes up your null hypothesis. And then your alternative hypothesis is that there is a relationship between x and y. And now you're trying to find essentially the strength of that relationship, the weighting of that relationship, right? So I just wanted to bring this to your attention, 3.12, 3.13, because everything we've talked about, this is how it ties back to the book. All right? All right, so for the other question of how strong is that relationship, we're looking at your errors. And here we're looking at your residual standard error, which is again, pulling straight from the book here, average amount that the response will deviate from the true regression line. And the unit of measurement is the dependent variable. So in this case, the unit of measurement, staying with our example, is the amount of sales, right? That your model could be off by a certain dollar value of sales. And remember that here with RSE, we're talking about what it deviates from the true regression line. So in other words, you can almost think about like what is the deviation within your training data. Another item to look at is the R-squared value. And this, again, pulling straight from the book, measures a proportion of variability in y that can be explained using x. Or you can also say it's the proportionate representation to show the fit between training data and prediction data. I believe this second bullet point is my own explanation. I don't think that's from the authors. But that's how I explain it. That it tells you how many of what is the proportion of your predicted values that can be explained by your training values. Right? That's a really important proportion to understand. So let's do some more participation here, guys. Okay? Residual standard error. And also the other one we talked about, the mean squared error. shows the differences essentially between your predicted values and your actual values, your model values. Right? So, what makes up a quote unquote good RSE value? Do you want that value to be high or do you want that value to be low? Same question for the R squared. It measures a proportionate amount of explanation between your training and your prediction data, right? So what is a quote unquote good R squared value? Is it high or is it low? And is there anything special about the R squared value? So I'll give you guys a second to think about that. What do you guys think? All right, so Patrick has already volunteered an answer. RSE should be low, R squared should be high. Okay, chat, what do you think? Do you agree with Patrick? Okay, Joseph basically gives the same answer. Low for RSE, R squared should be high, okay. Okay, so Patrick says R squared should be close to 1. So Patrick, you're hitting on that second part that I asked about, right? So guys, anytime you hear proportionate, you should always be thinking about values between 0 and 1. Right? So that's the first thing that should jump out at you when you see this R squared definition. Proportionate is a value of 0 to 1. So Patrick has obviously already hit on that. And he's talking about how R squared should be close to 1. And that's exactly right. R squared should be high, and it should be as close to 1 as possible. So you got it right. You got it right there, Patrick. Yeah, so basically everybody is getting the right answer. Rahul, thank you. Welcome to the chat. I don't think I saw you earlier, so thank you. So yeah, I mean, all of you are hitting on the right answer. You want RSE to be low, and you want your R squared to be high. Because in those scenarios, RSE means you're making fewer errors, right? And R squared means that your training model is very close, excuse me, your predicted value is very close to your training values. Which means that the coefficients in the model that you chose to create your predicted values are very close to what's reflected in your training data. Right? So that's exactly why you'd want those. So everybody basically hit on the right answer. So Patrick says, can R squared be greater than 1? No, it's proportionate. Right? So it can't be greater than 1. Okay? Yeah. So I think in the next section we're going to be going to code. Yeah. All right, guys. So there's plenty more ways to measure the effectiveness of your model. I'm just proposing these to get us started off the ground. Because again, this class is not going to get you ready for a job, but it is going to give you the foundation to go and research more and find out other measures that you could be using for your model. Okay? But R squared and RSE and MSE are going to give us a really good start to be able to say, okay, yeah, let's go ahead and research more, do a little bit more study. Okay? Okay. So here's the framework that I want to do, or that I want you guys to follow, right? What is a dependent variable we are trying to solve for? That's the first question you should be asking in any model. What is it that you're trying to predict? Second, do you have a linear regression problem on your hands? Because not everything is correlated in a linear way, right? Not everything is a linear regression problem, so you have to figure that out. And then the third thing, which is kind of like the modeling effort, is what are the factors that you should consider and what is the weight you assign to that factor. Remember what I told you earlier about how you should, this part in bold is what you should be, burning into your brain. Because everything you do in data science is essentially that. So that's the framework that you want to kind of maintain, okay? All right. I'm seeing some questions in the chat here. Isa says, was wondering if we will get access to the slides. Yeah, maybe. I might do that on Discord. I haven't really decided that. Yeah, we'll see. But it'll always be on YouTube, Isa. So you can always refer back to it on YouTube also. Joseph says, I don't think R2 can be greater than 1 as it represents a fraction. Not sure. Yeah, that's right, Joseph. It can't be higher than 1. You want it as close to 1 as possible, but it can't be higher than 1. It's a proportionate value. It's values between 0 and 1, and that's it. The authors present the formulas for R squared and RSS if you're curious, but if you look at the formulas, it'll show you why it's not possible to be greater than 1. Okay? All right, so we look at the framework. So looking here, this is how we're going to work. What is the result that we're optimizing for? In other words, what is the value that we want to optimize for? What does the code look like? And like I said, we're going to be at least level 2 data scientists using an LLM, right? Ideally, we're going to be acting more like architects. And then 3 is that we're going to be code editors, not code writers. So we're going to do virtually 0 code on our own, okay? And this is what we're going to do for the lab. We're going to do a professional level development environment. We're going to create our own data sets. We're going to use some synthetic data for this. And I'm using that more as kind of like a warm-up for using ChatGPT, right? You can certainly have your own data. But, just as a warm-up, we're going to create our own synthetic data sets. We're going to have code to solve for 1 independent variable, code for 2 independent variables, and then we're going to provide metrics for all the models. Okay? All right, so now we're getting ready to leave the slides. Do you guys have a preference on which version of Jupyter Notebooks to use? Drop it in the chat. That way we can set it up. But we're about to start doing some code, so drop the version of Jupyter Notebooks that you're recommending that we use for the problems, okay? I'll give you guys a minute to think about that. But let me know your preferred version of notebooks that we're going to use in the next section, because we're going to jump into code now, so let me know. Woo, we've been going for 2 hours, guys. Good job. I know a couple of you have been with me since the beginning, so thanks so much. Good job, guys. Okay, so Patrick is recommending Jupyter Notebooks within VS Code. What else, guys? Who else wants to give their preferred version of Jupyter Notebooks? Okay, so Isa says Jupyter Notebook comes with Anaconda. Okay, so whatever is the latest stable in Anaconda. Okay, anybody else? We're going to code next, guys. So we need a notebook. Let me know what you guys want to use. Anybody else want to give their favorite Jupyter Notebook? Okay, Melly also votes for the one that comes with Anaconda. Anybody else? Last call? Last call before we go into code. Patrick says Google Colab. Amit says, sorry, I have been in and out watching while traveling. Hey, no problem, Amit. Really appreciate you staying with us. And you can always view the replay later, or you can join us on the following Sunday. We're going to be doing this for the next 8 Sundays. Or 7 Sundays. Today's the first one of 8. All right, no more Jupyter Notebooks. She says anything is fine. Amrapali. So Amrapali, are you voting for VS Code and notebooks? Or well, first of all, welcome, Amrapali. I don't think I saw you before, but let me know which notebook you're voting for. Another vote for Conda, another vote for Google Colab. All right. All right, it looks like those are going to be all the answers I get. All right, guys. If you gave me an answer for your favorite notebook to use, wrong. You don't use notebooks. It's a trick question. My first bullet point is we're going to establish a professional development environment. Professional development in the real world is not done in notebooks. I know. That's a controversial hot take. I get it. Professional development is not done in notebooks. I will die on this hill. When you get out into the real world, you want to use some sort of IDE using some sort of terminal or some sort of other executing function. But the real world does not rely on notebooks. There's the old saying, and the old saying is still true, you can't deploy a notebook. Okay? So we are not going to use Google Colab or Anaconda or anything else. We are going to be using VS Code and then executing that code via a terminal. That is how you do professional development in Python in the real world. When you get out there, you're going to be working, you're going to be working with a lot more complex code. You're going to be working in distributed environments, a lot of different things, right? Where notebooks just don't cut it anymore. You might still use them to kind of like, as a scratch pad, and, just test some ideas on your own. But professional data science is being done in an IDE that's then executed within your own terminal, within some sort of other Python environment. Okay? Isa says, as a uni student, learning how it works in the real world is definitely insightful. Well, that's exactly what I'm trying to provide here to you, Isa. Because again, I see so much stuff out there, so many approaches to data science that, that are being, taught on other influencer stuff or tutorials. And again, when I see that, they tell me that they've never been in the real world, because this is how we do it in the real world. Okay? All right, so let's get going. So first thing I want to bring up, we're going to leave our deck here for a little bit. So first thing is I have Visual Studio Code set up with a blank environment, and I have my files ready to go here. I don't have any files, right? I'm just starting from a blank directory, and then we are going to execute our code here in this terminal window, right? And I'm using Mac, so this is using OS 10. But OS 10 mimics a lot of the Linux flavors that you're going to come across in the real world. So you want to learn something like Mac OS or Linux or whatever, because this is what you're going to be up against when people don't work. We had a discussion earlier about cloud certifications, right? When you don't have a cloud environment, or you're working in a server environment, this is what you're given, right? They tell you, okay, here's a command line prompt, go work with it, right? So really important for you guys to kind of get used to working like this. Visual Studio Code for your code, and then executing some sort of terminal. In this scenario, I'm executing locally within my own Python environments, but you would find this exact same interface if I was using one of my servers. So I keep a couple servers on DigitalOcean to help me kind of like do my own projects and my own ideas and stuff like that. But the interface is the same, right? I'm pointing out that I'm running locally, but you would see the same thing if we were to run this on my DigitalOcean servers or something else, right? The point is, you got to feel comfortable in Linux. You got to feel comfortable not working in GUIs, right? We're not going to see very many GUIs right now. This is just the way it is. This is professional development environment, okay? All right. So again, we're thinking in terms of architects, right? We are not just data scientists level 1. We're thinking of architects. So the first thing we're doing is we're going to need a file. We're going to need a file to create our synthetic data sets, right? Because we said we're going to need data. So let's create a new file, and we're going to call this datagen.py. And again, we're not trying to start with a blank screen, right? This is a blank screen. I don't want to work from a blank screen. I want ChatGPT to work from a blank screen, right? So now we bring up our friend ChatGPT, right? And so this is a limitation you guys might run up against. OpenAI has recently limited the amount of queries you can make of their ChatGPT 4.0 model. So I do have a paid subscription to OpenAI. I think it's $20 a month. So I understand not everybody here might have that, but I'm doing this because presuming that you're working for a company in a professional environment, you'll probably also have some sort of subscription to a tool. So I understand that as we go through this, maybe you're going to run up against the limit. That's okay. What they do is they let you go down to, I think it's either 4.0 mini or they bring you down to 3.5. So you can still continue, and maybe the answers aren't going to be as great as they would be in the 4.0 model, but it's still good enough, right? Or you can use something else. I've also done similar exercises with Claude from Anthropic. Claude is also very good at generating code. In fact, I think sometimes it produces cleaner code than ChatGPT does. But they also have restrictions on how many you can make per every 4 hours or something like that. So I don't want you guys to get caught up in the tools, but I do admit that I'm going to be showing you some stuff that maybe you're going to run up. You're going to run up against the usage limit. So keep that in mind. Okay, so first I want to establish some context. So we're going to ask for a synthetic data set. And we're going to say, does this last part look familiar to anybody? This portion here? Isn't that y equals mx plus b? Right? That's all we're doing, right? We're asking it for y equals mx plus b. And let's see what they come up with. Okay. Oh, let me get this out of the way. So now we're using our editing skills, and we're looking at what they provided here, right? So now we can modify this, and we want to make sure that it has a low RSC, right? So we need to refine our prompt here. Let's see if it creates that. Okay. What do you guys think? This code looks fairly reasonable to me. Oh, look, it even created it for us and has a download. There, it looks like they're using this noise variable to help minimize the low RSC, which is good because that means that we can play with that when we want a high RSC value, right? Because remember, we're going to want something that's a good fit model and also a bad fit model, right? So this would produce data that fits our model pretty well. What do you guys think? I think this code is reasonable to use. So I'm going to copy that code, and I'm going to bring it over to our data gen. Yeah, so I'm going to modify a couple things, right? Because for some reason it added a path, which I don't want. And just to make things easy, we'll call it low RSC and high RSC. And it also put in a range of X values, which I guess is okay, but I think 10 is too low. Let's go to like to 200. And the noise level is for a low RSC. So just to get an idea of what scale it's using, I want to see what high noise level should be. Okay, so they're using a noise level of 5.0. So now we know that if we use a 0.1, that should give us a low noise level, and a 5.0 should give us a high noise level. Everybody with me so far? What do you guys think? Does this code look reasonable to everybody? I think it looks fairly reasonable. So we can actually start to put this together in a way that fits our needs, right? And here we can say that we're going to modify this for a high RSC. Oh. So here we can go ahead and change this to 5.0. And this is high RSC. What do you guys think? Feel free to stop me or give me any feedback. But again, we know we're trying to do as little coding as possible. We're just doing editing right now. Let me know what you think in the chat. All right, this looks okay to me. We have a low RSC, we have a high RSC, we change the noise level. Melly is asking for a zoom in. Is that something that could help everybody? Is the code too small? Okay, it's tough to see the code. How about that? Is that better, guys? Let me know. I'm going to go one more zoom level in. Give me some feedback in the chat. Let me know if that's better. All right, Patrick says one more level. Okay. All right, is that good, guys? All right, so it looks like we're back to good here. Okay, so we're playing with the noise level. A low noise level gives us a good RSC. High noise level gives us a bad RSC. and then we're saving it to two local files, right? All right, so I think I'm good with this code. So we're gonna go here. Let me know if you need the terminal bigger too. Okay. So it looks like our code ran just fine. So if we go back to Visual Studio Code, we now see our two files. We have our low RSC and high RSC, right? So that's what our high looks like, and then that's what our low looks like. All right, good. So now we have data to work with, right? So now we're going to start with our modeling. So now we're going to do linear regression, one variable, or one factor, we should call it. Okay. Again, blank screen, but that's ChatGPT's problem, not our problem. Okay. So we're going to go back to our ChatGPT. And we're going to ask ChatGPT basically what code it knows, right? So it's telling you that it knows scikit-learn. And it's producing some relatively reasonable code. And it's plotting the results, which is okay if you're using a notebook, but not great for our code. And really, you know, again, guys, we're professional data scientists, right? We don't need plots, at least not all the time, right? So let's ask ChatGPT to modify the code. Let's use scikit-learn. MSC, RSC, coefficient, intercept, and R squared values. Let's pick up the R squared. Okay. What do you guys think? It even gave us a way to read the data set, which is wonderful, right? What do you guys think? This code look reasonable? Give me some feedback in the chat. What do you guys think? Actually, you know what? Let me bring it over to VS Code. That way it'll be a little bit bigger on everybody's screen. I just realized that. The part you can't see at the bottom is where it's just printing out the model items. What do you guys think? So Melly says, yes, it does for me. Okay, thank you, Melly. Appreciate that feedback. Anybody else? Patrick says it looks good to me. All right, you know, it looks good to me too. Let's try it. So again, we're just doing code editing, right? So now we are going to use our low RSC CSV file. All right, so let's think about this, right? We are data scientists, which means we're also critical thinkers, right? we're going to use our file low RSC as our input. What are we expecting down here, guys? Right? I mean, this is us forming a hypothesis, a theory, right? To help us understand whether our code is running right. So let's take some guesses, or some educated guesses, on what these results should be. What do you guys think? What are we expecting? Let me know in the chat. Give you guys a little minute here. But what are you guys expecting to see from these print statements once we run this code? Okay, so Patrick says RSC should be 0.1 as we set the scale to. Well, we set the noise to that, not necessarily the scale, though, Patrick. So I think you're on the right track, but not quite there, right? It's not gonna be exactly 0.1, right? But you're on the right track. She says we should expect 10 and 7. Yeah, that's definitely the right track, because if we go back to our initial code, or initial prompts, excuse me, that's what we requested, right? We did y equals mx m7, I think. Yeah, right? We said y equals 10x plus 7. So that's exactly right. If we're on the right track, and that's to say if ChatGPT wrote the right code, right? Then yes, we should expect that our coefficient is going to be 10, because that's the weight we're adding to x. And 7 is our intercept, right? That's our b, and b is the intercept. So you know what? To remind ourselves of that, let's go ahead and copy that and put that as part of our our comments, right? Because we said y equals 10x plus 7. That's the formula we used, right? That's the model we used. So yeah, Ashish, you're definitely on the right track. And yes, Ashish also says that those should be approximate values. Absolutely, right? They're not going to be exact, because remember, we're still modeling. There's still going to be a random element to it, right? But we know we're on the right track if we're hitting these numbers. What about R squared? Did anybody provide R squared? What should we expect for R squared? Anybody want to take a guess at that one? Melly Durr says, I don't know. Hey, that's okay, Melly. We're all here to learn, right? So it's totally okay if you don't know. You know, maybe after these classes, you'll pick up some of these things, and maybe you'll take some of this code, do some experimentation on your own, right? And that'll help you learn. So it's okay if you don't know all the answers. We're going to get you there. But yeah, so what do you guys think for R squared? Anybody have a guess on what R squared should be? Give you guys a couple more seconds in the chat. Yeah, that's right, Patrick. So R squared, it's not going to be exactly 1, but it's going to be closer to 1. Yep. Yeah, Patrick corrected himself. Yeah, near 1. Yeah, it's going to be very close to 1, right? We should expect a very high R squared value. Isa says R squared close to 1. That's exactly right. We should be expecting a very close value to 1. Because remember, we asked for a low RSE, which means that the errors between the predicted and the actual are very small, right? In other words, that line and the dots are very close together, which means that your model, the model that should come of that, should be very close to the training data. So that means on a proportionate basis, a lot of your predictions are going to be explained by your training data, which means that you should be high, you should be close to 1. So yeah, Amram Pali, that's exactly right. Amram Pali says R squared should be good towards 1 as it is low RSC. That's exactly right. Okay, so again, we're using this almost as like a check, because what if ChatGPT's code is wrong, right? We should be, kind of checking ourselves along the way, because ChatGPT does make mistakes, guys, right? So that's why I'm going through this exercise, so that we can kind of, run ahead and say, okay, yeah, that looks like a good result, or whoa, that's a terrible result. Where did ChatGPT go wrong? Because we didn't write this code. ChatGPT wrote this code, right? All right, so let's do it. Let's run this code. I think we're ready for it. Ooh, I didn't save it. So let me save this code. And then we're going to go to our terminal. Because we are professional developers, we do not use notebooks. Linear regression 1 factor dot pi. All right, let's see what happens. All right, coefficient of 9.999, intercept of 7.0, mean squared error of 0.009, residual standard error of 0.09, r squared 0.999. Let me know if you need that terminal bigger. But what do you guys think? Are we on the right track? Yes or no? Give me a yes or no in the chat, guys. I want to see as much participation as possible. Don't be shy. No wrong answers. But are we on the right track? Do these results look like we have viable code here? Joseph, you're asking a great question. Where can we learn how to work with an IDE and the command line prompt? Joseph, it's practice, my friend. It's just practice. That's really the only way I can tell you. Maybe, you know what, guys? Maybe I should write that resource, but I don't know any good resources that can teach you, like, from a level of 0 to do this. This is one of those things, like I said, I've just been doing it for so long, but I've been a professional software engineer from the beginning, basically. And I've been a data scientist for like the last 15 years. So this is just the way I've always done it. Like, this is the way professional code is done. I wish I could tell you, oh, I learned from this book or from this tutorial. It's just the way I've always done it. I've worked in a lot of environments. I've had clients all over the world. I've been fortunate to work on a million different projects. And this is how it's done in the real world. So really, that's just like the only way I can tell you that you have to just kind of get out there and do it. Being on Mac helps because Mac has great terminals, and the Mac operating system, very closely mimics Linux. I think it started as one of the Linux variants, and then Apple has built upon it, obviously. But that's really kind of like the best way I can tell you. You just kind of have to do it. Okay, so Explore the Beauty says r squared should be close to 1, and we are, right? We're at 0.999. That's pretty close. Melly Durr says, I think so, as far as it looks good. Joseph Hernandez says it looks good. Issa says looks good and satisfactory. Amrapali says looks reasonable. Okay. Ashish, I answered this question on an earlier slide. Maybe you were just away from the screen, but go ahead and refer back to the replay on that, or maybe somebody in the chat will help you. Okay, so Amrapali says it looks reasonable. Okay, all right, guys. So yeah, and I agree. It looks reasonable to me. We got very close to our coefficient. We know that our formula was y equals 10x plus 7. We got very close. Basically, we got to the intercept, right? We know the intercept was 7. Mean square error is as low to 0 as possible. Residual standard error is 0.97, which is good. R squared is 0.999. So yeah, these all look like very reasonable results. So this tells us that our code that ChatGPT produced for us is reasonable, right? Like we have functional code. So we can have faith in this code to go on and do more modeling with it, right? All right, so next thing we want to do is let's try our high RSE. So guys, what are we expecting here? Same question as before. What are you expecting here? What coefficients, intercepts, mean squared? What do you guys think? Remember, this time we're using our synthetic data set that has a high RSE. What do you guys think? What are we expecting? You don't have to do all of them. Just tell me what the R squared value we're expecting is. What do you guys think? Is it going to be 0.999 again? Yeah, Issa says, not comfortable working with terminals. We don't do it on Uni, mostly GUIs. Yeah, Issa, I get it. You know, I hear you. It's a pain point. You know, and maybe I'll do that. Maybe I'll come up with a resource to help you guys with it. Because, yeah, it's just the way it's done in the real world, you know? And it comes back to that same discussion that we had earlier, right? Where people are talking about, oh, well, should I go for Amazon, Azure, Google certifications? Well, be careful, right? Because if you're saying, hey, I'm Azure certified, that might be telling a hiring manager, oh, this is somebody who always needs an interface to work with servers. They need an interface to work with databases, right? I mean, it's been a while since I looked at Azure, but Azure is very GUI based for their management, right? You want to be able to walk into an interview that says, yeah, I can work with Azure, I can work with Terminal, these are the different flavors of Linux that I know. You kind of want to have that flexibility in your resume, guys, okay? Okay, so Issa says R squared is close to 0. Amrampali says definitely low R squared. Joseph says low, maybe less than 0.7. Joseph says just low. Okay, guys, so I don't want to sound like I'm splitting hairs here, but there is a difference between saying it's going to be close to 0 versus definitely low R squared. And I think I tend to agree a little bit more with Amrampali, where we don't know it's going to be 0. The only thing we really know is that it's definitely not going to be close to 1, and it's going to be low. So I'm leaning more towards Amrampali's answer and Joseph's answer about low, maybe less than 0.7. Joseph, I would say it's even lower than that. I mean, I would say like 0.2. You know, so again, that's kind of more Amrampali's answer, where, you know, it's definitely going to be low. I mean, I would, you know, if we were betting and we had an over-under, I would put the under at 0.2. 0.7, it's definitely going to be less than that, right? But you guys are on the right track, though. We know this is going to be a bad fit model, right? We know that we introduced a lot of noise into the data. So this is not going to be a great model, right? So yeah, let's go ahead and run it. So same code, we just use a different file. So I can execute the same line. Yeah. All right, so let's see what this gives us. All right. Oh, that doesn't look right. Did I not save it? Wait, what just happened here? Yeah. I did that. We're pulling from the high RSC. Okay, let's run it again just to make sure. All right, so this time we got coefficients that are still reasonable, right? So we know that the modeling went okay. But this time we got a really high MSE and also a very high RSE. But the R squared is also high. Why is that? Anybody want to take guesses on why that is? Actually, I think I know why. I can see why we have that. Anybody else want to take a guess? Give you guys another second here in the chat. All right, what do you guys think? Patrick says, is it because we are using a linear model to model linear data? Yeah, in a way, yes. I think you're providing a good explanation. Amrampali says, is it pointing to the correct file? It is, Amrampali. So there's two possibilities here. Is that one, the file itself could be created incorrectly, right? Maybe we could look at our creation code again. But here's what's getting to me, guys. Look at the intercepts and look at the coefficient. The model still did a fairly okay job at figuring out what the coefficients and the intercepts were. So in other words, when ChatGPT created the synthetic data, it still created pretty good X values, but the Y values were still off. And that's why we're still getting very high mean squared errors and residual standard errors, right? Because, I mean, we got excellent values in the previous one when we knew we were using the low RSC file. But here, it still did a pretty good job of finding the model, but the mean squared error and the RSC are still low. Ashish, it has changed. It has changed from the previous file. Ignore this run here because this run is a repeat, right? But this is the previous run. This here is the run with the low RSC file. So it has changed significantly, right? That's a significant change in the MSCs and RSCs. So I think this is an interesting case here because ChatGPT did a good job of changing the Y values, but not the X values. Yeah, but I think that's why, Ashish, because the X values are still valid. It's the Y values that I think ChatGPT changed, or the code that it gave us for the synthetic generation that changed it. So here's what we can do, guys. We can go back to ChatGPT. And let's get a new generation for data. IRC and low R squared. Okay, that's interesting. It's using a really high noise level at this point. If you guys look at that, it went from using a noise level of 0.1 to using a noise level of 10, and we didn't do that in our previous code. We went from 0.1 to 5. So maybe that's part of the challenge. So maybe we should be doing it. Maybe we should be putting it much higher here. So that's one option for our change. What do you guys think? Patrick says maybe we can shift the location of our noise to add a systematic shift. Yeah, maybe. Let me show you something else, because here's what's also getting to me. I did a test to get ready for this course. And this is the code that ChatGPT had given me previously, where it's using the random normal distribution from NumPy and the standard deviations in order to modify the value of the code, or the value of the value of the RSE and the R squared. So I have a feeling that it's also related to that. So here's what we're going to do. I have it for another, I have it for 2 variable linear regression, because I want to make sure that I show you a model that has multiple values for for factors, right? So it's not just y equals mx plus b, it's y equals mx plus mz plus b, right? So let's go ahead and use this one here, because this is going to give us for 2 variables. So let me bring this up to my root directory. Yep. So now it's going to be dataset gen for 2 variables. And let's relook at this code. And I like that. We're going to have different coefficients now. But you can see here how we have an x and we have a z value, and then we're still going to a y. All right, you guys with me so far? But let's go ahead and execute this code and use the files that it gives us. And I'm going to go ahead and move these CSVs to the archive, just so that we don't get confused. All right, dataset gen2 var. Dataset gen2 var. Oh. Oh, I forgot a T. All right. All right, guys. So now we have this new data set with an X, Z, and a Y. And that's should give us a good RSE, and it should give us a bad RSE. So now we're going to ask ChatGPT for how to do this with how to do linear regression with multiple values, right? So it's going to be this here. Oh, it thinks that we're still working with synthetic data set, so that's not good. Oh, okay, it's going to give us that too. Okay, great. All right, so let me copy this over. And I think I need to create the file on VS Code. I don't think we did that yet. Linear regression 1 factor, yep. So now we need to create a second one. Linear regression 2 factor dot py. All right, let's drop this in. And we are going to be using the good RSE data set. All right, guys, start putting in your predictions. What are we expecting? What are we expecting for these down here? Oh, did I not copy that correctly? That is a weird result. It forgot to do the include for NumPy. Oh, wait a minute, did I use the wrong code? What happened there? Wait, hold on a second, guys. I'm tripping over my own shoelaces, as we say. Linear regression two-factor. Linear regression two-factor dot py. And it's showing a problem in line 23. Yeah, that's weird. So it looks like ChatGPT made a mistake. It didn't give us the NumPy import. Everybody see that? Let me pause here and make sure everybody sees what we're doing there. Anybody else see the problem that we ran into there? You guys still with me? Hey, Issa, good seeing you. Safe travels. All right, guys, so that's a serious problem, huh? And this is exactly why we still need to have a pretty good level of understanding of code, right? Because ChatGPT will make mistakes, and this is a clear mistake on ChatGPT's part. It gave us code that didn't have the right includes at the top, or excuse me, the right imports at the top, right? So this is the stuff that we still need to be aware of, even though we're relying on ChatGPT to write code for us. So now let's go back. Our code is saved. We're not getting any more warnings, right? VS Code is not yellow. Let's see what this gives us. Okay, this looks reasonable. Coefficients of 3.8, 6.3. Is that reasonable for what we gave it? 3.8 and 6.3? Yeah. So 3.8, 6.3, you know, not the greatest fit, but a reasonable enough fit for 4x and 6z. And intercept of 15, intercept of 14.955. Okay, so pretty reasonable. What do you guys think? Yeah, you're right, Joseph. That's exactly right. It missed an import. So guys, really gives I'm glad this error came up, because it does set the tone for the importance of still, you know, having coding skills and being able to edit when ChatGPT makes mistakes, because the mistakes will happen. And keep in mind also, this is the 4.0 model. This is their latest model. So I'm really surprised that it's making such basic mistakes like that. All right, but good. I'm glad that we were able to tackle both a one-factor and a two-factor problem, because you can see here that in this case, this line is the key one, right? This line is telling you that there's two coefficients that need to be worked through for this model. And then of course there's an intercept, right? There's not always an intercept, but in this case it's telling us. So we got to the expected values. We got really good values for the MSE, RSE, and a good value for the R squared, right? So this is good. All right, so let's go back to our deck. We have hit all of the items that we wanted to hit during our lab walkthrough, right? Let's go to the next slide, because here is where I want to leave you guys with some self-study. First thing I want you to consider is, what does the code look like for additional factors? Maybe your model has 3 factors, 5 factors, 10 factors. What does that code look like? What about categorical results? We've only talked about scalar results, but we also mentioned categorical results. What does that code look like? We use synthetic data. Can you do this with real world data? That would be an interesting challenge too, right? And then, if you really want to take it another step further, if you're really feeling ambitious, what does it look like with another framework like Keras? Because right now we're using scikit-learn and we're using a lot of, NumPy code and kind of piecing things together. But there's other ways to do this, right? Like Keras can do linear regression. So what does it look like when you're using Keras? Because generally speaking, you wouldn't do it in the same way that I'm showing it to you here. You probably would use a framework. I'm more of a Keras guy than I am a PyTorch guy, but I'm pretty sure PyTorch can also do linear regression. So how would you do it in PyTorch, right? So these are the things that I want you to think about as far as next steps. So if you wanted to do some programming on your own, this is where I would extend it to. And keep in mind that when I say programming, I'm talking about ChatGPT. So yes, we kind of got snake bit a little bit right now by ChatGPT, but that's okay. That's going to happen. That's going to happen in the real world. It's going to happen to you whether you use ChatGPT or not. Or maybe you inherited somebody else's code and they made a mistake, right? So, you're still going to have to, have an editing mindset to be able to catch things like this, right? So that's where I want to leave you with the self-study. And, that's where we're going to pick up next week. We're going to move on to chapter 4 next week. So if you want to get ready for that. But I want to thank you guys for sticking with me. I know a couple of you guys were there from beginning to end. So thank you so much for that. I want to, give you another couple minutes here if you have any questions, because we've covered a lot of ground. But again, I think we've done a lot of really good work here. I think I've shown you how I want to manage these sessions going forward, because we're going to write very little code. We're going to write very little native code, right? And that's going to have its upsides, and it's also going to have its downsides. We saw one of the downsides today. But we got to roll with the punches, and we got to, fix the code, right? That's our job as data scientists, right? So I think you guys did really good. Got a lot of really great answers. I really want to thank you for all the participations. All the participation on all the questions. Really impressed by that. But this is where I want to leave you guys for self-study, and hopefully see you again here next week. Ashish says, "Thanks, Dennis, for the patience. Love the content." Oh, thank you so much, Ashish. Again, I'm just sharing what I love, what my experience has been. So if it helps somebody, then that makes me happy. So thank you so much for that feedback. All right, last call for any questions or any closing notes, guys. But thank you so much. This has been really fun, really interesting. So I hope you keep on coming back future Sundays. Again, this is how this is the framework that I want us to establish to work together. And yeah. Patrick says thank you. Thank you, Patrick. Appreciate everybody give a shout out to Patrick for helping me mod. Thank you so much for this, guys. Angel, thank you. Sravan, thank you. All right, everybody. So stay cool out there. It's probably hot in your part of the world. That's a pretty safe bet to say that. But yeah, take care of yourselves. Take care of your families. And I'll see you next time. Hey guys, how are you? Good morning. Happy Sunday. Hope you're doing well. I can't believe that the countdown timer ran out on me before I joined in. Sorry about that. I didn't turn on my camera quickly enough. But I hope you're doing well. Thank you so much for joining me in this continuing series on the Introduction to Statistical Learning book. This book here, again, this is the book where professional data science begins. So what I'm doing is I have an 8-week series where we're going to cover each one of the chapters every Sunday. This happens to be week number 2, which means that we did chapters 1 through 3 last week, and we're going to do chapter 4 today. And I think the book really lays out data science in a very good way, so that you're going to establish a really good foundation for moving on in your data science studies. So thank you so much for joining me. I'm seeing different people on Instagram. I'm seeing different people on YouTube. Really going to get a great turnout today. So let me start by looking into some of the chats. I already see chats already going on all platforms, which is fantastic. And by the way, today I'm also experimenting by pushing out on Kik. I just opened a Kik account yesterday, so I thought maybe I'd push out there. So if you also have a Kik account, feel free to follow me there. But I think that most of you will be following along on YouTube because YouTube provides you with the wider format, which is a little bit more convenient for some of the stuff we do, especially when we get into the classroom view. But yeah, just want to go ahead and get started and, make sure I greet everyone because everyone here is already ready to go. But let me hop into my chat here. Patrick, good morning. Hey, all, hoping you're having a great Sunday. Thank you so much, Patrick. Patrick, by the way, is going to be our moderator in YouTube, and he's also one of my moderators in Discord. Really helps me out. So, give a shout out to Patrick when you get a chance. But thank you for being here, Patrick. Rohan, good to see you again. I know you've been attending a lot this week, so thank you so much for being here. Hope you're well. Syed Salmanziz says, good morning, Mr. Dennis. Good morning to you too. Hope you're well. Rohan says, can you increase the font size during the coding part? Yeah, sure. I think I got to a pretty good font size last time. If not, let me know. But yeah, we can definitely do that. I'll do that for both the code and the terminal. Hamad Javed, welcome Hamad. Hello everyone, I hope you're doing well. Well, thank you Hamad, hope you're well too. Himsteak says, good morning all, good to see you. Rex Riker, our man in New York City, says, hi everyone. Well, hello, Rex. Good to see you, my friend. Rex is also an active participant on our Discord. If you haven't joined our Discord, we have over 50 people now, which is incredible, on the Discord. So if you'd like to join the Discord, you're welcome to do that. The link is in my Instagram highlights. Explore the beauty of nature. Oh, good to see you, my friend. I think you attended all of last week's class. I think you were one of the people that stayed for the whole thing. So glad to see you. Hope you're well. Okay. So I think we are ready to get started. What I want to do is, and by the way, if you haven't introduced yourself, please go ahead and let me know where you're checking in from. And then also, I do like to run my classes with a lot of feedback. So I will be asking questions, throwing questions out to the chat, and please participate as you feel comfortable. It kind of helps everyone learn from each other. There's no bad answers, and no, I'm not going to call on you for an answer. Just participate as you feel comfortable, but it really helps the overall learning if people, kind of help and jump in and help each other. Rahul Jain, hello all, lovely to meet you all again. Nice to see you, my friend. Atharva, I don't know what you're referring to. If you want to provide some clarification there, I don't usually help people with homework questions. That sounds like a homework question. Siva Namaste from India. Nice to see you again, Siva. I know you've been on plenty of streams before, so nice to see you, my friend. Hey, you may call me Tim is back. Hello, Tim. I think you took a little break there, but you're back. Good to see you again, my friend. Hi, Dennis from India, Dehradun. I hope I'm pronouncing right. Okay, Palki, good to see you again, Palki. Patrick, I love your reply. That's funny. Yes, I guess people in the chat think that they should be writing prompts so that Dennis AI can write it for them. That's hilarious. I love that reply, Patrick. And Andy Edife? Andy Edife says, good morning, my name is Anderson. I am a master's student in economics from Nigeria. Welcome. Welcome. I appreciate you joining. We get a lot of viewers from the African continent, so good to see you. Yeah, Rex, indeed. That was funny. I love that reply by Patrick. Ashish, hello, Dennis. Hello, Dennis. Good to see you. Good to see you too, Ashish. Welcome back. Rahul, smart reply, Patrick. Yeah. Patrick gets his name on the board today. He made a good one today. Sai Divya, hello, Dennis from Dallas. Oh, very cool. What part of Dallas? I was based in Dallas for 2 years, like right before the pandemic. I was based in Dallas. Still have many friends there actually. Love the community there. Lots of tech companies in Dallas, at least in the areas where I was. Lots of really good Indian restaurants in Dallas too. So yeah, hope you're well there, Sai. Sanai Muthu says, hey Dennis, I'm also in India. Happy to see you again. Oh, happy to see you too, Sanai. Welcome back. SA Work says, dear sir, I'm new here, just curious to know about statistical strategies in machine learning. Well, you're in the right place. You're in the right place. The book that we're going to is called An Introduction to Statistical Learning. So you're in the right place for it. And, we're going to go ahead and, just keep on going with the book. And, you're welcome to join us for as long as you can. Again, I've told people, if you need to go, you can always come back. We know these sessions tend to go at least 2 hours. We haven't gone anything short than 2 hours, really anything short than 2.5 hours. So yeah, come and learn as much as you like, and if you need to step away, that's totally okay. My hair is not cooperating this morning. Ugh, I didn't put enough product in it, eh? I always, shower fresh and everything right before these streams, but I didn't put enough product in my hair. So you're going to have to forgive my hair. It looks terrible this morning. Sincerely, Sadiq says, hello, Dennis. I'm Sadiq from Raleigh, North Carolina. Oh, very cool. I have family in Raleigh. Let me know what part of Raleigh you're from. Lots of tech companies there in the Triangle in Raleigh. Hello, Dennis. How are you doing? Happy Sunday from Nigeria, from Michael. I'm doing well, Michael. Thank you so much for asking. I got up early. I've been up since 4:30 in the morning. I take my dog to the dog park. He runs around and has his fun. And then I go to Starbucks, come home, do some work, get ready for the day. Just so I've had a good morning. So we're gonna continue that with having a good class today. Nazish says, hi Dennis, really excited to be part of this session. I'm excited too. These sessions are fun. I hope they're informative for everyone. Honestly, it helps me too to kind of go back and look at some of these concepts in the book. I've had this book for a very long time. I'm embarrassed to show you the back because it's so dirty, and it's a book that I refer to quite a bit. But it's been helpful for me too to also go back and remember just little different things like, oh yeah. And actually, and now since I have a lot more experience in the industry, it's also helpful for me to go in there and say, yeah, I want to teach this because I know I've used this. I know this is important. And then I can look at other things and say, yeah, that's a good chapter, but maybe not as important because, it's been like multiple years and I haven't used it, so it's been good for me too to kind of go back and help these things, okay? Yes, somebody help Atharva. I think Atharva might be AI. Maybe we have it backwards. Maybe he's AI. So, because it sounds like he's just repeating the scripts from some of the previous sessions and some of my reels because these are some of the interview questions that I asked. So yeah, somebody help Atharva. Somebody guide Atharva in the right direction. All right, guys. So now that I'm seeing some of the hellos slow down a little bit, let's go ahead and get started, huh? So I'm going to switch over to my classroom view. And what I think I'm going to do, Hamad, that's a good point. Yes, something is not being understood here by Atharva. Let's all try to help him out. So I'm going to switch over to my classroom view. And I'm going to bring up my slides. And it looks like I might have to redo my classroom view. Give me just a second here, guys. For some reason, I have to refresh this every once in a while. Okay. All right, so this is my classroom view. Again, if you're on Instagram, maybe not the ideal platform, feel free to go to YouTube so you can get a widescreen view. But what I'm going to do is, today our focus is on chapter 4 of the ISL book. If you don't have the physical book, you can always go to the author's website, statlearning.com, and download the PDF. I am working from the ISL book that's for the R version, and this is their first edition. They've updated it since then, but it's the edition that I have, so it's the one I feel most comfortable teaching. Don't worry about the language, because if you haven't heard, the twist that I'm doing here, to honor the author's work, is that we are doing it with AI. We are not going to be doing any native code. We are going to be using AI to write all of our code. So it's going to be, a little bit of a twist, a little bit more fun that way, okay? So here's what I want to do. I'm seeing a lot of new people in the chat. Maybe you didn't come to the last session. So what I want to do is I want to go ahead and I want to start by doing a review of the previous slides, or at least the introduction slides, because I want to make sure that we're all on the same page. I know a lot of you also attended last week, so I'm going to keep it a little, I'm going to keep it quick for the introduction, but I do think it's good for us to see that, just to kind of get all of us on the same page, okay? So in my introduction, I want to cover the philosophy that I'm going to use for the class, a kickoff as far as how I see the class going, and then the agenda for everything that we're going to do for the remaining weeks, okay? So data science is a very serious study. It's a profession that you have to dedicate your life to. There is nothing that disappoints me more than when I see these, hack the interview or these shortcut sheets on LinkedIn making somebody think that they can become a data scientist in a month after reading a couple of sheets. It's a very serious profession. I equate it to being like a doctor or a lawyer, where you have to study a lot, and then after you finish your study, you're still going to learn a lot on the job. So for me, if I don't like that people are cheapening the profession by doing these hacks, then it's up to me to contribute and kind of help the data science ecosystem by teaching what I think is relevant. And that's really the point here of this course, that I want you to understand that I'm not offering any shortcuts, I'm not offering any hacks. It's going to take work to become a data scientist. But having said that, I assume that you want to approach this in a professional way. We're not just looking for a job, we're looking for a career, we're looking for a profession. So that's really kind of where I'm approaching this. In addition to that, it's also important for a data scientist to maintain flexibility in their thinking and carry that for the length of your career. You should always be open to more learning, different approaches, different thoughts than your own, so on and so forth. So that's part of also the philosophy that I want to encourage in you for attending a course like this. Okay? I teach with the Socratic method. That means that I ask a lot of questions. If you post a question in the chat, I might reply to you with a question, because that keeps the conversation going, and it kind of helps you kind of think on your own 2 feet, not to always just have the answer, kind of spoon-fed towards you, right? So I want to make sure that, you also understand that, I'm asking you to listen and participate as much as you can, I know that most people might be watching on their phones or things like that, but try to make this a dedicated time so that you can participate back, because I think it really helps you. And it also helps you to read the comments from everybody else, right? To read the answers from everybody else, to read the questions that you have, right? I think all of that really helps. I am not promising that you will be ready for a job after this, but you're going to have a pretty good foundation. You're going to have a really good foundation to continue your study and keep going forward with more of the things that you're going to learn and some of the things that aren't taught in this book. There's plenty of things that aren't taught in this book, and the authors fully acknowledge that, right? So I want to make sure that you have that understanding that this isn't for a job, but it is for a pretty good foundation. And again, it's for professional data science. This isn't just somebody who, I really need a remote job, or you just want to rush into it, right? It's intended, to help cultivate the professionalism that it takes to become a data scientist. So we are doing the Introduction to Statistical Learning book, and my intent is to honor the authors, because I want to be intellectually honest throughout this process. I'm not here to copy anybody's work. That's not my style. That's not intellectually honest. So we know that the authors have developed the ISL book for R, and we know that they've also developed the ISL book for Python. That's ISLP. So how can I build upon that work? Because that's the way I want to honor the authors. And what we're doing, I'm introducing ISLA, which is the ISL book with generative AI tools. This is rooted in what I call the blank screen effect. If you're a data scientist, a software developer, and other professions too, like lawyers, real estate agents, advertising executives, you should never start from a blank screen anymore. Gen AI has changed that. If you are starting from a blank screen, then you are a dinosaur. Your job will be eliminated. This is what I truly believe will be the future of data science development. You will not write algorithms. You will supervise ChatGPT writing algorithms for you. I'm 100% convinced of this. So we might as well get a head start now and start working with some of those tools and start working in that mode where we think of ourselves, this is fine, where we think of ourselves as developing the skills to do the managing of AI tools, not necessarily of writing our own code. So we are going to learn the concepts from each chapter, and then we're going to use AI to help our understanding of that and to handle the prompts that we create. And then our job will be to edit and refine the code to a deliverable state. We will be editors of code, not writers of code. And by the way, we already saw that. We saw that in last week's session. For those of you that attended, you saw that ChatGPT made a very fundamental, very simple mistake in one of the code scripts that it generated for us. So the AI tools are not perfect, but they're close enough. So we still have to be smart enough to be an architect and understand what we need, understand how we're going to prompt the AI, but then also be able to understand when it makes mistakes. So that's what we're going to be doing, okay? So I'm going to provide the general concepts that I pick up from the chapters. More specifically, the stuff that I know we use in the real world of data science. And in some cases, I'll point out stuff that maybe you don't use. That's going to be the case today. I'll point out some stuff that maybe you don't use, right? So that's kind of my intent. I'm not going to sit here page by page and copying the author's work. That's not honest. I'm going to give you the highlights as I see them as a chief data scientist. Maybe things I ask questions on, maybe things I know we've used, maybe like theoretical things I ask in interviews. I'm going to just kind of like be curating those out of the chapters and presenting them to you in these slides. And then we're also going to do 1 to 2 lab exercises. And then I also leave you with some like additional thoughts of where you can take this further. So if you want to do some of your own study, I'm gonna leave you with a couple nuggets to say, well, what about this? What if you extended it this way? What if the problem was X instead of Y? And how would you modify what we did today to do that? I'm gonna try to leave you with some of those things. But again, the work will be on you. The work will be on you to take that and run with it, okay? And then finally, as I said earlier, I'm working from ISLR version 1 that's available as a PDF. Let me go down here. Patrick has been kind enough to already post it in the chat. That is where you can download it from. And also, again, to honor the authors, that's also the author's website. That's the official website for this book. So please go there, support them. They've created a wonderful book. I'm not trying to steal any of their book or any of the idea. So please go to them, and that way we can all honor their work, okay? Yes, so if you want to know which one to download, there's multiple PDFs. Go ahead and download ISLR version 1. Again, it's just the one I like. It's the one I feel most comfortable with. If you want to download the other ones, it's up to you. But I will be teaching it, and what I show on the screen when I do show the PDF, it will be the version 1 of the R code version. Okay. Okay, so let's go to the next slide. Yeah, so you're encouraged to read the PDF prior to each session. So today we're on chapter 4, and we're going to do one chapter all the way to the end. I believe there's 10 chapters in that version. So we're going to go through today and then in the coming another 6 Sundays after today. Everything is as a live stream. I completely hate the thought of sitting here and recording something for you guys and then you having to see it. That's not my style. I'm never going to record content like that. I think that's boring. So it'll always be a live stream. I love seeing you guys in the live stream. I like highlighting your chats and things like that. So this is the format we're always going to do. I refuse to teach in any other way. I make the announcements on Instagram. I also post the thumbnails and the session ahead of time on YouTube. So make sure you subscribe to my YouTube, and when you see the new thumbnail come up, click on notify, and YouTube sends you an alert, I think like 5 minutes or 10 minutes before my stream starts. So YouTube will take care of notifying you and saying, hey, the next class is starting or whatnot. So feel free to click on that, and that way you'll never miss a class. Or I keep them up on YouTube. I host, it's in my, I think it just converts to a video, so you can sit there and watch it. Maybe you missed a particular portion and you want to review, whatever the case may be. Okay. Okay, so this is the chapters that we're going to cover, and give me just a little break here, guys. Hold on. Sorry about that. I had to sneeze a little bit. So these are the chapters that we're going to be covering. And then also, I do want to emphasize this again, because some of you, weren't here last week. And I think of this as like, if you were to go to an Olympic athlete, like a javelin thrower, right? And you were to take lessons from them, they're probably going to focus on a lot of the general stuff, right? They're going to show you, how to hold it, how many steps to run, at what time to throw the javelin, right? They're going to do that. But you as a beginner, you might have questions beyond that and say, well, like, why do I put my wrist in this way? Or like, why does my arm have to be like at this angle and not this angle, right? And that javelin thrower, that expert athlete is going to tell you, I don't know, I've just always done it that way. It's just kind of habit, right? There's things that they literally can't explain because that's just the way they've always done them, right? So I feel the same way because I've been a developer and in the field and a data scientist for a long time, that sometimes I may be glossing over things that to me are just like natural things that I haven't thought about in years, but to you, they might still be new. So feel free to, kind of call me out on that. If there's something that's not clear, I encourage you to come back with questions and just, let me know what, something needs more explanation or whatnot. But, that's just the way my mind thinks because I've been at it for so long, right? I don't think about like the small little individual things. I just do them. I've just done them for years. So I hope that's clear. And, again, just encouraging or feel free to stop me and keep going. Okay. All right. Let me check the chat here. Patrick's doing a great job of answering it. Okay. Yeah. It looks like Patrick's handling all the questions. If there's anything else that's needed, let me know. I'll stop the session. But Patrick, thanks so much for answering all those. All right, let me see if there's anything else in the setup that we should go over. Otherwise, we're going to jump to chapter 4. Okay, so this is the general concepts. Yeah, so I'm going to come back to this slide because there's one more thing I want to cover with you guys. This is it right here. Okay, so real quick, again, I realize that this is a repeat for those of you who attended last week. I apologize, but I'm seeing some new names, so I want to make sure we go through these. In chapter 1, this is important. You're going to find these 4 tenets or these 4 premises that the authors put forward. And I really like those premises, and I want to make sure that you also understand them because I think they're important. So the first thing is they talk about how they fully acknowledge that there's more models out there. There's more to learn. There's plenty of things out there for you to tackle. But they have narrowed it down to what they think are the most flexible and most widely applicable models across industries, right? See, that's what makes this book so good, that they recognize that their work is not just academic. They realize that it will be used out there in business applications. So the authors clearly acknowledge that you're going to be working for somebody, you're going to be in some sort of business environment. So these are the most widely applicable in industrial approaches to data science. So I think that's really important to understand because one, it helps you understand how these chapters came to be, how they chose these chapters. And two, as I said earlier, finishing this book, finishing my course, finishing any class is not a straight jump to getting a job. It's a good foundation. You're still going to have to build upon it. You're still going to have to, learn more about different things, right? For example, I don't want to speak for them, but I think the authors would agree that this is not necessarily a good book to learn neural networks, right? They cover neural networks very little in this book, right? So you're still going to have to go out and do your work, but the authors do try to provide the most applicable models in here. Second, no single approach is going to work well for any given problem that you have. They're going to have trade-offs, but most importantly, this is where the experimentation in data science begins. Some of you were in the chats earlier this week where we talked about what's your favorite machine learning model, right? And that's a trick question. You shouldn't have a favorite machine learning model because there is no favorite. Every piece of data, every project, every endeavor you're going to take in data science is unique. So you can't say, oh, that data looks like some data I worked on last year, so let me use the same model. No, right? No approach will work well in all situations. You always have to run a proper experimentation process. That's the science part of it, right? So keep that in mind. Super important premise. This one is also very key. I'm copying directly from the book. We assume that the reader is comfortable with basic mathematical concepts, but we do not assume a graduate degree in mathematical sciences. This is so key. And we've seen some back and forth. One, I get a lot of private messages from a lot of you who are intimidated by the math. Some of you put that in your comments. And sometimes we have to go back and forth in the comments with some people who just refuse to believe this. I guess there's a lot of linear algebra supporters out there that can't handle their world being rattled by by hearing this. But the reality is that the math that you need in data science is way overstated. It's much better to understand the models, what they do, how to use them, and how they can apply to different problems, and how you can use a series of those models to find the most applicable for your individual problem. And again, this is not me saying this. I said it before the office because I truly believe in this. I've seen it. I've seen it in the people that I hire, in the projects I've run, the way we execute those projects. You don't need this amazing graduate level, PhD level worth of mathematics, right? The time when companies only hired PhDs in mathematics has come and gone. It hasn't been that way for at least 6 to 8 years, right? And then finally, the authors, again, coming back to their acknowledgement that we're all going to be working in the real world, the book focuses on solving real world problems. And I love that because that's what I focus on too. That's what I try to center my content on. I've already been in the industry. Now I'm reaching my hand back to help all of you, but I'm going to do it with that twist of this isn't a school exercise. This is the real world. All right. We are out there, earning a paycheck from our skills, right? And this is what's required of that. That's different from academia. Okay? So, closing with that, I encourage you to read the ISL book. If you also want to know more about data science in the real world, I also will point you to my book, Your First Year in Data Science. I just published it last week. I'm #1 in the new releases in the data mining space on Amazon, so I'm really proud of that. So if you guys are interested in learning more about the real world of data science, there's a whole book on it. Really proud of it. I went through a lot of work to make sure I produced a quality product for you guys. It's all in color. All the charts are in color. So if you're interested in that, I'd appreciate your support. It's available on Amazon globally. I've made the ebook version affordable. So please consider the book, and I appreciate your support. All right. So these 4 tenets are what I like from the author, and I think that's the last part of the first chapter. That's the last part I want to talk about because I think it's super important, so feel free to revisit that. Okay, so now let's get started. I'm going to reuse one of my slides from chapter 1. And this is our first opportunity for participation here, guys. So listen up. I'm seeing a lot of YouTube folks, which is great. If you're on Instagram, feel free to join us. You're welcome. You're welcome to also participate and give answers as you see fit. What are quantitative outputs and what are qualitative outputs? Give me an example, give me your definition, give me your elevator pitch, whatever you'd like. And then if you want extra credit, tell me what's clustering. All right? So I'm going to give the chat here a minute. Let me know. You don't have to answer all 3, by the way. You can answer just one if you're comfortable. But what is quantitative, what is qualitative, and what is clustering? Answer however many you feel comfortable with. I'll give you guys a minute while I take a water break here. What do you guys think? Qualitative, quantitative, and clustering. Give me some definitions or examples. All right, Rahul, thank you so much. Rahul is giving us our first answer. Quantitative means which can be measured using numbers like count, average, sum. Okay. Explore the beauty. Wonderful. He's going to give us, he's volunteering for qualitative. Qualitative outputs can involve a set of land cover classes, water, built up forest. Okay. There's a name for that. Explore the beauty. Give me you understand what it is, but there's a name for some, like water, built up forest. I love the example. So to be fair, you filled that because I did ask for examples, but give me the name for that. There's a name for that, okay? Mamiya says when response variable is expected to be numerical, it's quantitative. Great answer. I'm on board with that. Quantitative output is numerical output, more so predicted number or figure. Okay, being, I'm on board with that. Clustering means grouping items in different classes. Nice, Rohan. I'm on board with that too. So Rohan volunteered for clustering. I like it. Nazish says qualitative. Do these individuals have a lung disease or not? And is in the form of yes, no. Ooh. Chat. What do you guys think? That's an interesting answer. Nazish, I love the way you're thinking about this. You had, Nazish, you had me at lung disease. You lost me at yes or no. Is it always yes or no? What do you think? What do you think, Chad? Is it always yes or no? You know what, Nazish? Ultimately, don't misunderstand me. I love your answer because it fits perfectly with what we're going to talk about today. But is it always yes or no? Tell me, guys. Quantitative like age, qualitative like gender. Yeah, okay. I'm on board with that. Patrick. Patrick is presenting us with a key word here. Qualitative is categorical. Is that right, chat? One, is that right? And two, are categories always yes, no? Because we've been told that it's also just yes, no, right? Is that the case? But Patrick, I'm on board with your use of categorical. That's a key word, right? We should be thinking about that. After all, today's chapter is categorization, right? So I like it, Patrick. SID official, deal with numerical quantitative and deal with numerical is quantitative and with variable qualitative. Clustering means grouping items into different subset from a set. Yeah, okay. I'm on board with that. I think that clustering can have more uses than that, but yeah, I'm on board with that. Qualitative is why and quantitative is how much. And quantitative is how much. I'm on board with your quantitative. Qualitative is why. Is it always a why? I don't know about that. Is it always a why? I think it could be more flexible than that. What do you guys think? Mamiya says when a categorical output is expected from response variable is qualitative. Love it. Love it. That's a great brief answer. Love it, Mamiya. I think you're on the right track with that, my friend. Rahul says clustering is when you group data with some similar features. Yeah. I like it, Rahul. I'm on board with that. Clustering is grouping different classes together. Yep. That's a good one, being. Clustering is grouping two or more classes based on their characteristics. Yeah, Rahul adds for qualitative. Qualitative means which cannot be measured with numerical accuracy. Text or image of categorical groups would have to be interpreted. Yeah, that's one use. But I just don't want you guys to think that that's the only use. There's a lot of uses for categorical, right? Or for qualitative outputs, I should say. So yeah, I'm on board with it, Rahul. Just make sure you understand that there's more uses than just categorical groups, okay? Or you can think of it more than just groups. Being says categories can be more than yes or no. I agree. So that's coming back to the earlier response about it being in the form of yes, no. Categories can indeed be a lot more then yes or no. And we're going to talk a little bit about that today. So I love the fact that we're hitting on that. I love the fact that Nazish brought up that yes-no, because that's really key. So yeah. Ashish says quantitative outputs, numerical outputs, qualitative outputs is categorical. Categorical output clustering is grouping without any explicit labels. Ooh. Hey, and by the way, guys, please try to not spam the chat. If you give an answer and it appears on your screen, I guarantee you that I see it. It just takes me a while to scroll down, okay? But please don't spam the chat. Okay, so is clustering... So you're saying clustering is always grouping without any explicit labels. Is that true, chat? Is that true? I don't know. I don't know if I'm on board with that last part. But you guys let me know what you think. And we're going to cover some of that a little bit today. Okay. So yes, no indicates binary classification, but we could also have different categories: lung disease, common cold, placebo, etc. Yeah. Yeah, that's good. That's exactly right. So you know what? I love Patrick's last comment there. It's a great segue for us to go into the slides for today. So let's consider this the end of our initial review and kickoff. And now we are into categorization, chapter 4. So everything else, most of the things from here on in, you'll be able to find in chapter 4. I'll tell you when you can't. So I'm going to give you my chapter notes. I'm going to give you a framework example. We're going to walk through a lab, through a coding example, and then I'm going to leave you guys with some self-study. Okay? So, what is categorization? Basically, it's what we just went through in the chat right now. It's talking about how not all measures are quantitative, right? There's plenty of use cases where you're going to need a number value back, a quantitative value back. But there's also a lot where you don't need a quantitative value. You kind of need a category, right? You need that qualitative output. So last week in chapter 3, we looked at linear regression, which is excellent for qualitative outputs, or at least we saw it being used for quantitative outputs. We saw it being used for quantitative outputs quite a bit last week. But it can also be used for these qualitative outputs, right? So this chapter focuses on logistic regression, linear discriminant analysis, or LDA, and k-nearest neighbors, or KNN. Because all of these are valid models for those times when you need qualitative outputs. Okay? So, next question for the chat. What is logistic regression? Think about the conversations we just had in the chat, right? We had some great answers, and we're thinking about qualitative outputs. What is logistic regression? What do you guys think? Why would I be bringing up logistic regression right now after the conversation that we just had? Give you guys a minute to think about that. If you don't know, it's perfectly okay to say I don't know. That helps me too, because it helps me gauge the level. But I want you to kind of just, do this mental exercise to kind of tie these things together. Why am I bringing up logistic regression right now, given the conversation we just had, and given that we're talking about these qualitative outputs, right? What is logistic regression? Okay, so Shantanu says logistic regression is about classification of categorical data. Okay. Give me a little more. You're super close. Give me a little bit more. Take me just one extra step further. Because you're so close, Shantanu. You're so close, but give me just one more extra step. Or anybody else who wants to build on his answer, give me one extra step. Give you guys another few seconds here to think about it. Being says logistic regression is one of the classification algorithms used for categorical distinction outputs. Oh, you're just as close as Shantanu. You're just as close as him. So go one step further. Go one step further. Oh, Mamiya, I love the way you put this. Classification of categorical data based on probabilistic approach. Yeah, I love your mention of the probabilities because that's going to be key for what we're talking about today. But still, give me one step further. One step further. You guys are so close. And there's a lot less participation on this one, so I'm going to assume people, don't quite know what logistic regression, or at least aren't comfortable expressing it, and that's okay. That's okay. We're going to try to change that here in this lesson. But I'll give you guys another 10 seconds here. Oh, explore the beauty. You're so close. Go one step further. You're so close. All right. Shantanu, yeah, you got the answer in the long run. So good job, Shantanu. Yeah, so I skipped over Rahul's answer because he's giving probably the best answer that I'm seeing here, right? Actually, Rahul and Patrick essentially have the same answer. But yes, the key here is that Rahul mentions the yes or no questions. Or Patrick, calls it the binary questions, binary classification. And that's exactly right. When you hear logistic regression, you should be thinking about binary classifications. 2 classifications, yes or no. Yes or no, true, false, is a member of the class, is not a member of the class, right? So I think it was Mamiya that talked about the probabilities, right? So that's exactly what logistic regression is. And by the way, guys, I started off like this, one, because I think it's a nice tie to, the conversation we had and, kind of understanding the qualitative nature and stuff like that. And somebody had mentioned the previous question about, it can be a yes-no thing, one or the other, right? So that's all on the right track. But another reason I asked this is because, believe it or not, this is a popular interview question. People will ask you, what is the difference between regression and logistic regression? I've had that question in interviews before. I've never asked that question. Perhaps I should work it into my interviews. But I have had that as an interview question before, where they will ask you, what is regression and what is logistic regression and what's the difference? So you should be prepared to know those types of things, and hopefully you will be after this and after so much more study, okay? But that's what you should be thinking about. You should be thinking about as soon as you hear logistic regression, you should be hearing, okay, I have 2 categories, so this is a binary classification, and I'm going to be receiving a probabilistic answer. Okay, those are the 3 things that should come to you when you think about logistic regression, and that's essentially what I have shown here, right? Sorry, guys, I have to take these camera breaks because I'm sneezing. I apologize for that. But when you're thinking about logistic regression, you should be thinking about binary yes-no decisions. And again, whenever you see quotes, that means I'm pulling direct from the authors. The authors say it models the probability that Y belongs to a particular category, right? A particular binary category, a particular yes-no category. Another way to put it is that you know what class you're looking for. So the answer is, what is the probability that Y belongs in that class? So does this person have cancer? Yes, no. right? Is this person a potential client for our sales? Yes, no. And then the answer might be 0.7. And then that gives you a probability that that person does have cancer, or is a potential client, or things like that. Okay? So y equals mx plus b is something that we learned last week, right? And you should always be thinking about y equals mx plus b for the rest of your data science career, because it really explains a lot in data science. How it relates to logistic regression is that over on this side, on the left-hand side of this graph, this is pretty much a standard regression method approach, right? A linear regression approach. The challenge is that linear regression can give you negative values, and it can also give you an unlimited number of values, right? But since we know that we're logistic regression, we're talking about probabilities. I didn't mention this earlier, I'm sorry, but the fourth thing you should think about when somebody tells you it's a logistic problem is that your values are between 0 and 1, because it's a probability, right? It's you'll see how it's a proportion, right? So you should always be thinking of values of 0 and 1. So therefore, a linear approach is not going to work. That's what this, the right side graph shows. That we're going to use an approach that's going to always give us values between 0 and 1, no matter what data we put in. So that's another really key difference between the regression we learned last week and most regression approaches versus logistic regression. We're going to modify our math a little bit so that we're always getting a proportion, a probability of class membership. So in this case, the authors were using a loan company and the probability of default, which is the y-axis, and then the balance, which is the x-axis. So these numbers is the value of the person's balance, the client's balance, and then this shows their probability of default, right? So this is also a good opportunity for review here. There is a name for what the balance variable is, and there is a name for what the probability of default is, right? Or if you think about this formula, tell me which one is the x and which one is the y. And again, there are proper, data science names for these. They're on the next slide, so before we move to the next slide, let's just take this as a little bit of a touch point, right? What is the name for these variables? So if you're new to data science, this is a good opportunity for you to learn too, right? So what do you guys think? Yeah, Patrick, thanks for handling that. Guys, I push out on as many platforms as I can to let you know that the streams are going, but the best format is on YouTube, because YouTube does give the wide version. Unfortunately, Instagram only gives the vertical. So I understand that on Instagram it may not be convenient. That's why I push out on multiple platforms. So please, switch over to YouTube, as Patrick and other people are suggesting. There's only so much we can do here, guys. It's a limitation of Instagram. So give you guys another minute there. There is a name for the balance variables and the probability of default. How do they fit into this formula? But there's a name for these. I understand this is a little bit of a beginner question, but it's good. We have different levels in the chat, so let me know. Lakshmi, is it Lakshmi Matella or Lakshmi Matella? Lakshmi Matella, I don't think I've seen you in the chat before, but you're coming in strong. You're coming in strong with a perfect answer, right? X is the independent variable and Y is dependent. Perfect answer. That's exactly the answer we were looking for. So good job on that. I've never seen you in the chat before, but coming in hot. Explore the beauty of nature says y is the response variable, x is the predictor variable. Perfect. That's another way of saying it. Response and predictors, certainly valid. Shantanu, yep, you got it. Patrick, x is the independent variable, balance. Yep, and y is the dependent, probably the default. That's exactly right. Yeah, perfect. You guys got it spot on. So let's move forward on that. Another thing I want to mention to you guys, super important principle here, guys. Write this one down, okay? You'll note that, as I said earlier, the binary is for the yes, no. You're always going to get a value of 0 and 1, right? You're always going to get a probability that it belongs to a class or not. So in this case, staying with the author's example, it's going to give you a probability of default. Here's the client's account balance, and then we run it through the model, and then this is the probability of default. Like I said earlier, it might give you an answer like 0.7. Now, the challenge with that is that you have to translate that into some business impact. All right, I'm giving you the real world stuff here, guys. This is why this is important. Just because it's 0.7 doesn't mean it's an answer. And you can't just say, well, we'll only take the people that rate as a 1.0, right? Because then you're still missing a lot of people who have pretty high probabilities of default, right? So what ends up happening is you're going to have to set a threshold and say, okay, we think at 0.75, that's way too much higher a probability. That's when we're going to say deny the person, right? Or whatever measures your loan company would take for that. But who says it should be 7.75? Maybe it should be lower. Maybe it should be higher. You don't know that, right? So I'm using this to illustrate that these are the times where your model answer is not the answer that you give to your clients, to your stakeholders, to your colleagues on the business side. This is where the work of interpreting your results takes over. Super important, guys. This right here is what separates the okay data scientist from the great data scientist. Because an okay data scientist, or even a below average data scientist, takes this graph and puts it in a chart and emails it to the stakeholder. Bad, right? A good data scientist goes out and says, okay, I'm going to pick values at 0.6, 0.7, 0.8, 0.9, 1.0. I'm going to look at those balances. I'm going to look at the number of accounts, and then I can come up with projected losses at each one of those levels depending on what the business chooses, right? And then keep in mind that each one of those also has a potential loss in revenue because at those levels you have a different level of clients that are paying, that you are accepting, right? Not just the rejection side, but the ones you are accepting, that's your revenue, right? So I'm kind of taking this little pause to highlight that with you guys, because again, this is where kind of like the real data science separation begins, right? Like the statistics and math nerds just stop at this chart, but the good data scientists take it a step further and say, I'm going to translate this into business results. This is like this is where, like, in my book, I call this the result interpretation or the model interpretation. And this is where that work begins, where you're going to say, hey, I'm just giving you the probabilities, but this is what it means. If you go ahead and install this threshold for when you're going to reject clients, or deny a loan or whatever the case may be, this is what it means for the losses. This is what it means for our revenue, right? So I kind of want to stress that with you because, this is where like that real work of data science begins. You never send these results to the business. You send them your interpretation of those results. All right, so everybody with me? I really hope that sticks with you guys, because that's what separates the below average data scientist to the better data scientist. All right? And then the great data scientist can stand up in front of them and run a whole presentation in front of them, right? That's a whole other skill. But that's really kind of what separates the below average to a really good data scientist, to be able to take these probabilities and make them mean something for the business. All right, you guys with me on this? Give me some feedback in the chat. I love the way you guys answered. I'm loving the participation. You guys are doing fantastic, so let's keep going. But give me some feedback in the chat if that resonates with you. All right, let me go up here. All right. All right, so tell me about this formula. What do you guys see? I see a couple things that are jumping out at me. What do you guys see in this formula? What do you guys see? All right, good. I'm seeing some good feedback in the chat. Okay, it looks like that is resonating with you guys. Well, good. You know, because that, again, that's me giving you that real world insight, right? The books aren't going to tell you to do that, but that's what you learn when you're out in the field. Okay. Okay, so explore the beauty says logistic regression formula. Yeah, but tell me more about it, right? Aren't there a couple things in here that kind of jump out at you? Okay. Patrick and Rahul, are you guys like copying off each other's work? You guys hit it exactly right. The equation of the line and the exponent, right? Both Patrick and Rahul came up with that answer really at the same time, right? That's exactly right. Look at that exponent. What is it? It's y equals mx plus b, right? As I mentioned to you guys last week, you know, the authors use, you know, the Greek alphabet for this. You know, I learned it in a different way, and I've seen it expressed in the way that I do it. That's why I always stick with y equals mx plus b. But yeah, that's exactly right. They're using the exponent as the formula that we've already seen. So at first look, this can seem a little bit intimidating, but it's just y equals mx plus b used in a different way. Okay? Ashish says it squishes the output between 0 and 1. That's exactly right. That's the second thing you see, right? It creates a proportion, right? This over this means it's a proportion. And you're always going to get a value between 0 and 1. That's exactly right, Ashish. That's the other answer I was looking for. Because then, this over here, the output, right, makes sense. Because this represents the probability of x belonging to the binary category, the yes, no, the true, false, the cancer, not cancer, right? So that's what should be jumping out at you, right? Where it's an exponent and it's a proportion. It's a 0 to 1 value. So, yeah, Rahul. Not only was the timing amazing, is that you guys also gave nearly the exact same answer. Right? Like your answer is just like your two answers are variations of each other. That's crazy. Excuse me, guys. I guess I have my allergies acting up or something. Sorry about that. But yeah, you guys are giving fantastic answers. But that's exactly what you want to be thinking about, right? The math can seem a little bit intimidating, you know, when you hear about these, like this different function you have to use for the output and all that. But it's just y equals mx plus b. That's all it is, right? All right, let me go to the next slide. So here we're just reinforcing what we just went over, right? Px is the probability of y belonging to the class. X is the independent variable, as you guys previously correctly identified. We also did the independent variable is x. B is the coefficient, or the first beta 1 is the coefficient, and beta 0 is the intercept. Right? And then down here, I think it was explore the beauty of nature. Yeah, so explore the beauty of nature. I think your answer is more like this, right? Because just like we saw last week, you can also have multiple independent variables, right? You can have multiple independent variables to determine one dependent variable. So yeah, so explore the beauty of nature. You're on the right track, my friend. But yeah, you can have as many x's, as many independent variables as you need. And most of the time you will, right? It's rarely just one, right? But yeah, so I like the way our conversation has tied into this slide, because this really should be kind of connecting some of those thoughts in your mind. All right, let's go on to the next slide. So far, we've talked about qualitative outputs. But what about the inputs? There's going to be times when you're going to have a situation where you need to use a binary value as an input to a model. Not an output, but an input. And is that possible? You guys let me know. I mean, you're kind of seeing it on the screen, right? So let me know what you think of this, and let me know if you can think of a scenario where you would need that. Satya, you can mostly find me on YouTube. That's probably the best platform, but I'm also on LinkedIn and on Twitch. And really all three of those will give you a wider screen format. So Twitch, YouTube, LinkedIn, you can find me on those, Data Science with Dennis, and that'll give you a wider view. So what do you guys think? Are qualitative inputs useful? You want to give me an example of one? Give you guys another minute here. Yeah, Rahul's giving a great answer. Yeah, Rahul's giving a great answer. Where you want to predict if a particular demographic feature is responsible for a customer being poor, rich, or whatever outcome. Yep. Yeah, demographic features is one of the ways that this is commonly used for any number of demographics, or maybe regional if you live in certain regions or states or whatever the case may be. So yeah. Yeah, so the answer really is that qualitative inputs are very useful. They're very useful and they're very common. You know, and really, I don't want to single out any industries or any particular business cases because there's so many. You're going to use this virtually in any industry or company that you end up at. Qualitative inputs are very useful, and that's where dummy variables come in. So dummy variables are basically binary values. Are they part of the demographic or of whatever category you want to come with, or are they not? So that's where you see, if you look at the two formulas, the difference between the two formulas is the very end, right? The 1 or the 0. In this case, they're looking at students and their probability of default. So here, the person is a student, or here, the person is not a student. Member of the category, not a member of the category. So a member gets a 1, a non-member gets a 0. Right? So dummy variables and binary values like this are extremely useful. You're gonna use them quite a bit. Qualitative input are useful. For example, which city is someone from? Does logistic regression still work? Yes, it absolutely still works. You're seeing it on the screen. It's the same formula, right? You're still using the y equals mx plus b as an exponential. It just so happens that one of your x's, or one of your independent variables, is either a 1 or a 0, no other value. That's the dummy variable part of it, right? That you're saying it's either 1 or 0. It can't be anything else. It's either a member of the class or it's not a member of the class. So yeah, you're seeing it right up on the screen. Same formula. It's just that it's an x, right? The x is a 1 or a 0. The independent variable is a 1 or a 0, right? Satya, okay, Satya, nice to see that you made the switch to YouTube. Yeah, guys, I apologize for that. I push out on Instagram because that's where my biggest audience is, but definitely join my YouTube, subscribe, click on the notification. It'll tell you when the class starts, and it'll give you a nice wide format. So I'm glad you made the switch, Satya. Hamad says we have to convert qualitative inputs into binary. Yes. For the regressions that we're doing, yes, you do. That's not always the case, and we're going to talk about times when that's not always the case as far as binary, right? Because there are going to be times when you need more than the binary class, right? But there are times, but yes, but for regression and in the examples that we're talking about, the person, the attribute, whatever, you're either part of the class or you're not. Again, that's the dummy variable part of it, right? But that's what you want to do. Just 1 or 0. That's all I need to know, right? Yep. So Ashish, you're definitely looking ahead there, where you're changing qualitative inputs to quantitative, like one-hot encoding or some other techniques. Yep. And we're going to talk about that a little bit. But yes, you're right. It's not always binary. There are times when you do need more than that. And yeah, I'll hit upon that a little bit, but really that's more of an advanced discussion for another day. But yeah, I'm on board with your statement there, Ashish. Okay, so let's go to the next slide. And this is kind of headed in that direction. Now, Hamad and Ashish, I love your comments because it's a good segue for this next slide here. Okay. What about classification with more than 2 outcomes, right? Because we've already agreed that logistic regression is for that binary output, right? It's the probability of belonging to a class, right? That's what we're going to get from those formulas we saw, right? We agreed that it's a proportionate formula. It's always going to be 0 to 1, but it's really just for 2 classes, right? Here's the probability of these independent variables resulting in being a member of the yes/no class, the true/false, the default, not default, cancer, no cancer, right? But there's plenty of times where you're going to need more than 2 outputs, right? So this is where the authors are putting forth LDA, linear discriminant analysis, right? That's their approach to it. So I want to switch over to the PDF. Give me a second to bring that up. So this is in chapter 4. And this is their linear regression side, or their logistic regression. But I want to skip ahead to their LDA portion, because we've essentially already covered all of this, right? I've taken all of this text, and I've shown you what I think is the most important, right? So that's multiple linear. It should be coming up here. There we go. So now this is where they talk about LDA 4.4 in version 1 of the R book of ISL, right? This is where they talk about having to use multiple classes and the theorems that they use for it. And I like this section of the chapter because they talk about a couple of really relevant things. One, this is one of their really first explanations of confusion matrices, right? This is where they start to introduce confusion matrices. They also start to introduce some of the charting that you're going to use. Not that you're going to show your stakeholders, but the charting that you use internally. So I think this is all really valuable stuff. And I'm kind of scrolling because there's another thing I want to show you here. Bear with me a second. Here. They also have a great explanation of the ROC curve. So I encourage you to read all of this. I encourage you to understand what an ROC curve is. It's one of the questions that I ask in my interviews. I want you to know, I want you in my interviews to give me a really solid theoretical explanation of the ROC curve. What does it show you? What are we talking about when we talk about an ROC curve? That's a question that I ask. If you want to work for me, you got to know the answer to that question. And again, here, really good explanation or a really good start to understand a confusion matrix. Super important. That's another question I ask. What is a confusion matrix? What does it tell you? Right? So I'm pointing this out. Yeah, and by the way, yeah, this is also good here. The errors and the type 1s, type 2 errors. And that's another question I ask. What is a type 1? What is a type 2? What is the difference? Right? Give me a real world example of those. So there's a lot of really good text in this LDA section. And I'm going to encourage you to look at it and look and study it on your own. But I'm not going to have a section on LDA because in practice, in the real world, you are most likely going to use other models for multi-class classification. This is kind of where deep learning starts to come into the equation. So Ashish, we know with your comment and Hamed's comment, right? This is where you start to talk about different encoding methods for those times when you're going to have qualitative inputs with more than binary classes, right? When you have to go beyond those dummy variables we talked about, right? When you start to talk about that, yes, LDA can be used for multiple categories, but in reality, you're probably going to use a neural network, right? For most of these classification problems like this, for multi-class, you're going to need a neural network or some form of deep learning, right? So that's why I didn't really invest the time in an LDA explanation, because from a practical perspective, there's probably other models that you're going to explore that are going to be superior to LDA in a lot of situations, right? So Rahul, the answer is you're most likely going to start with a neural network exploration. Because, and another reason I say that is because when you're talking about these multi-class problems, it's usually not just 3 or 4, right? You're usually talking about something where you have 10 classes or something like that, right? It's going to be something where you have a lot of classes to look at, and when you have that many classes, you're usually going to have a lot of data behind it. So you start using some deep learning approach. Or even, in some cases, you'd be using like an XGBoost approach, right? So, or something else like that, right? Jeremiah says, is it because it's easier to use deep learning than LDA? No, it just tends to be more effective because you're going to have more classes. When you're looking at multi-class categorization, it's rarely just going to be 3 classes, right? 4 classes. It's going to be like 10 classes, 15 classes. I've done models with up to like, I think 35 classes or 40 classes in one case that I can think of, right? So 40 classes means you're going to have a ton of data. And so it becomes a deep learning problem at that point. So just from like I say, but in practice, right here in my notes, like as a practical perspective, right, you're gonna be saying, okay, let me start looking at some deep learning. Let me start bringing in some bigger models. Let me start going to a GPU instead of a CPU, right? I mean, it's kind of a step up, right, in all respects. So that's why I'm telling you guys, read the LDA section. There's great discussion in ROC curves on the confusion matrices, great explanations. But from a practical perspective, I don't want to invest more time in this because I just don't think it'll be worth the time here, given that you're mostly be going into deep learning techniques when you're really talking about multi-class approaches. So again, this is me curating the chapters, right? This is me saying, yeah, you're going to need that. Maybe you don't need this so much. So I'm thinking that LDA, you're going to be using other approaches instead. Okay. Rahul says, what kind of deep learning are we talking about? It depends, Rahul. It depends on the problem. It depends on how much data you have, how many independent variables you're going to have, right? I'm just saying that you most likely would not be using LDA, right? And again, we don't want to get caught up in saying, well, I'm always going to use a neural network. I'm always going to use a CNN or whatever the case may be, right? I'm not saying you should always be like that narrow. I'm just saying that this is where LDA is kind of put to the side and other approaches are explored because it most likely becomes a deep learning problem at that point. That's all I'm saying, okay? So I'm going to leave you guys with that because, LDA, is good, and it's good for study, academic stuff. But there's deep learning is usually where comes into the picture when you're talking about these big multi-class problems. All right. Yeah, Jeremiah. So neural network can be one of the ways, but it can be in any number of things, right? The point is that it probably won't be LDA. All right. So let's move on here, because now we can talk about the second model that's introduced, and it's K nearest neighbors, KNNs. And I'm also going to kick off by telling you to not confuse it with K-means. So I know a lot of you read the chapter ahead of time, and if you didn't, that's okay. But does anybody want to volunteer their understanding, their elevator pitch for what KNN is? And if you're feeling brave, tell me about K-means also, or pick one of those. Pick one, pick both, whatever you're comfortable with. Or maybe you're not comfortable at all. You can just sit back. That's okay. But does anybody want to volunteer to tell me about nearest neighbors or K-means? I'll give you guys a minute here on that. What do you guys think? Maybe we've taken a step up in the level of complexity here. That's why I'm getting less answers. Okay, Lakshmi volunteers. It is used for both classification and regression. Okay, Lakshmi. Patrick says KNN is using nearby points to test our points to assign a class. Yep, I'm on board with that. Anybody else, or anybody want to try K-means? Explore the Beauty of Nature says KNN is classification, means, and observation is likely to have similar values as values of its immediate neighbors. Okay, I like that explanation. Jeremiah says for KNN, if I am not wrong, we would have a test point which we try to observe which are the points that are nearest to the test points. I'm not sure if I get what you're trying to say there. Rahul says these are clustering approaches. KNN uses the distance between all nearest points, where K-means uses the mean distance, I guess. Ooh, Rahul, I love that you took a stab at K-means. I'm not sure if I'm on board with your K-means explanation. There's a key difference for K-means, though, right? So help me find that key difference. Oh, okay. Patrick already found it. And actually, it ties to Hamed's answer, too. K-means is an unsupervised algorithm for clustering data in a natural way. That's exactly right. When you hear K-means, you should mostly be hearing unsupervised approaches. And Hamad says KNN is supervised machine learning model used to overcome the problems of classification and regression. Yeah, Hamad, that's a great answer. But yeah, both of you hit it right on the head. KNN, generally speaking, is a supervised approach. K-means is an unsupervised approach, right? So what Satya says K-means is based on the calculation of square mean of individual points, and a linear line is drawn with the lowest squared error. Okay, Satya, I like that explanation. But yeah, both of you hit it right on the head. KNN, generally speaking, is a supervised approach. K-means is an unsupervised approach. I don't know. I don't know, chat. Is Satya right on that? I hope I'm understanding your explanation correctly. I'm not sure if I'm 100% with it, though. Tungamac, welcome to the chat. I don't think I've seen you before. Prediction based on nearest attributes from a set of data. Yeah. Yeah, nice answer. I like that answer a lot. That answer will work. Lakshmi says it uses Euclidean distance to measure the proximity between data points. Yeah. Yeah, in a way. Underneath the hood, it is doing that. Yeah. But yeah, you know, I want to come back and highlight Patrick's answer and Hamed's answer because both of them are sharing some key points, right? KNN is supervised. It helps you overcome the problems of classification and regression because it is a way you can use for multiple classes, right? And then Patrick also talks about how k-means is unsupervised, and he also mentions the key of clustering, right? It's a clustering approach. Well, excuse me, both of these KNN are clustering approaches, and that's kind of what you should be hearing in your mind, that it's a clustering approach, right? Clustering is very key in a lot of problems, right? Because again, not everything has a quantitative output. You're going to have qualitative outputs also, right? So that's what KNN helps you with, right? She says K equals 3 as an example. We find the 3 nearest neighbor points to our test point, and then we categorize our test point. Yeah. So, by the way, I make a mention here too that unfortunately I'm not on board with the way the authors wrote this because KNN is actually mentioned in chapter 2. It's only briefly referenced in chapter 3, even though they give you lab exercises in chapter 3, not chapter 2. So it's kind of out of sequence. It's a little messy, you know? So I will ask you to refer to chapter 2 for KNN. And this is one of the charts from chapter 2, and it's a good segue from all of the answers that we've had so far, right? Because this is showing KNN. This is showing clustering methods. So what you should be seeing is that both of these charts have the same dots, right? The dots are in the same locations, right? The difference is how many clusters you're using for your dots. So here we can see that the algorithm has determined 2 clusters, or excuse me, 2 categories, and then it has the different clusters of where it's putting each one of those members. On top of that, you can also see the correlation of members of each cluster to each other. So for example, let's hone in on this one here, this one here in the lower quadrant, lower left-hand side of this chart. You can see that it actually belongs to the blue class. But how close is it to the other ones? It's not, right? And that's why, even though it's part of the blue class, it actually sits in the orange class. And it sits just outside of the blue class. But it's also very far away from the other class members. Over here, you have 2 class members that are very close to one another. But then you also have this orange member that's still within the orange, but still kind of close to the blue, right? So it's like orange but leaning blue. Or there's this one here that's literally on the border between the 2. But it's still labeled as being part of the orange cluster. I'm highlighting this because, again, this is important for that business translation of how you will actually talk about these things to your business stakeholders, right? You're going to be talking about these things in terms of why these clusters share, these items, these members share the same attributes. Why are they orange? And why are they so close to each other? Very, very important skill as far as being able to translate your results. So, I couldn't find a chart that's a good example of this, right? But let's pretend that right here in this corner, I have a member, and we'll say for the moment, it's neither orange nor blue. We'll just say that it's a purple color, and it sits right here in this corner. It sits really far from the blue clusters, and even though it's in the orange cluster, it sits really far from any of the orange members. What's the name for that? What would you call that? Or why is it important to think about those types of members that sit? Why is it important to think about a member that sits in a corner like that? I'll give you guys a minute to think about that. Ooh, if you guys are fast on this one. Fast, fast, fast. Explore the beauty of nature, you got it. It's an outlier. Right? That's why you want to take the time sometimes to plot this out. Or to think about those values, right? Because you're going to assign values too. To think about those values. But yeah, that's an outlier, right? That's super key to be able to acknowledge in your items, right? To be able to say, yeah, I was able to plot this, but it sits way off in the corner. It's not near any other members. It's an outlier. Or in some cases, and I want to come back to, Lakshmi, it can also be an anomaly. Sure, it can be anomalous data. But keep in mind, though, in a lot of these cases, we're talking about qualitative data, right? Qualitative data is often not always an anomaly, right? So, coming back to Servan's question, another way to also look at this for your outliers, or for these items that sit in the corner, nowhere near any of the other members, you know what else it means? It might indicate a need for a new class. Maybe you need more than the classes that you have. So yeah, it's an outlier, but what are you going to do about it? Well, maybe you need to introduce a new class. So Servan, I like your question. Hey Dennis, any real-time example from your experience? Yeah. I'll give you a really interesting example that I actually created this project and we actually ran with it. I love this project. So I want to keep things generic because I want to protect my clients. But a lot of clients that you're going to run into, a lot of projects, are going to be concerned with how you are addressing policies and laws that are out there, right? So you want to make sure that you're always addressing policies and laws, because the policies and laws that you don't cover are what are known as an emerging risk, right? That's the business term for it. Because if you can say these are the 10 laws and this is how I'm covering those 10 laws, anything that falls outside of those laws is a risk to you, right? Because that's something where you could be potentially breaking the law. So I was approached by a client that wanted to identify emerging risks. And a clustering approach, very similar to what you're seeing on your screen, it is what we created for them, right? Because if you want to think about this as another way, guys, another way I think about this and the way I explain it to my clients is that this is a big filter, right? A clustering approach is a big filter. I'm going to create a really solid model that can take your data and filter it into these categories really quickly. It's almost like one of those in the US we call it like a colander or a sieve, something where like you would drain your spaghetti, right? You put your spaghetti in the top and all the water comes out, right? So it's a big filter, a big sieve in that way, right? So if you have that and you have everything being categorized, what's left in the bowl? What didn't get categorized or at least strongly categorized? If you do it right, the stuff that's left over in the bowl, the stuff that didn't get filtered, that's your emerging risk, right? So it's almost like you're creating a filter to see what gets omitted, right? because that stuff that gets omitted could be an emerging risk in that scenario. This is the item where you couldn't classify a law to it or a policy to it. Or rather, it's the other way. This is the law that you couldn't classify a policy to it. So because you don't have policy to cover that law, that's an emerging risk, right? So that's how I mostly use these clusterings, where it's just like a big filter for you to dump a bunch of stuff into. It all comes out as it should, and then you look for what's left over. And that's, and then that's the business value, right? What's left over are the things that you should be like, well, we need to take a look at this, right? That's how you identify what you need to take a look at. So Sravan, I hope that helps you. Because again, I can't give details with my clients and all that, but that's an example of that, where you can use it as a big filter to find out other things that do classify properly, and those are okay. But what doesn't classify properly? What kind of sits out there on the outside? What did get classified, but is really far from the centroid or really far from the other members? Is that a need for a new class, right? Okay, Sirvan says that's awesome. Thanks. Okay, cool. I'm glad that helped. So Jeremiah says, how do you determine whether it's just an outlier or whether you should include a new class? That's the experimentation, right? That's the experimentation of data science. You should be trying multiple classes. You should be trying what those different scenarios look like. What does it look like for 3 classes, 4 classes, 5 classes, 20 classes? There's a lot of value in that. Yeah, Patrick, thanks for the answer. Hamed says, how a single data point makes a new class. Do you mean how you put it into a new class? Or what do you mean, Hamad? Let me know what you mean there. Nazish says, so an outlier won't get filtered, right? No, it will get filtered. It will get categorized, right? The filtering comes in you saying, well, show me the ones that look like outliers. Show me the ones that aren't close to the centroid, that aren't close to other members of the same category. That's the filtering I'm talking about. And that's more of a straight programming exercise, right? That's not data science. That's getting more into the interpretive side. Because again, those are the ones that should raise concern, not just for you, but for the business, right? Because why is it an outlier? Because in my example, right, that it would be an outlier because you don't have a policy to help you with a law that exists. So that's how you kind of, rationalize that out. Okay? All right, so are there any more questions? Because otherwise we are going to be going into the lab side of this, because my next slide is the framework example. But any other questions there before we move on? Yeah, Jeremiah, you're asking the same question twice. It's the experimentation. Generally, you would start with the number of labels that you have, the number of classes that you have. Right? That's a starting point, but you can experiment with it beyond that. All right. So, we're going to move on, and we're going to start looking at the lab, and we're going to start, using ChatGPT to help us. Sravan says, Dennis, you are making me love DS more and more. Well, good. I'm glad. That's kind of the reason why I started this whole content creation effort. And I also want you to love it in a very professional way, not just the other junk that you find on YouTube. But yeah, so thanks for that feedback. All right, so let's look at the next slide. So here's the framework, right? What is the result that we are optimizing for? That's always a question we're asking of ourselves. What does the code look like, right? And again, we're not being level 1 analysts, we're being level 2 data scientists, and we're prompting an LLM for assistance. And we are going to be code editors, not code writers. We're going to establish a professional level development environment. We're going to find an appropriate data set. We're going to create a logistic regression model. That'll be one exercise. And then we're going to create a KNN model. And then we're going to look at the, we're going to look at the metrics for all of these models. Because really, this is kind of like the basic modeling aspect of being a data scientist. Okay? All right, so this is where we leave the deck. And we're going to go to working in Visual Studio Code. And we are then going to also work in Terminal. So I think that this VS Code will be big enough. If not, let me know. And then I'm also going to be using a terminal window. So I won't use the same trick question as last time. But if you think that we're going to sit here and work in a notebook, that's wrong. Professional data science development is rarely done in a notebook. You're going to hit a lot of ceilings and a lot of needs in a corporate enterprise distributed environment where a notebook simply is not going to work for you. So we are working in a professional way with a dedicated IDE, right? We're using VS Code. You can use something else, right? I mean, I've experimented with a couple other ones. You really choose whatever you'd like. I just happen to be using VS Code. And then we're also going to be calling everything from a terminal. And you can see here, I already have a dedicated environment, a dedicated Conda environment where I'm running all of my code, right? Because you always want to be running in your own isolated environment. And sometimes you want to have an environment for your development, for your testing, and for your deployment, right? But that's one of the things I want to make sure I also emphasize, that professional data science, professional development is not done in a notebook. It's done in a dedicated IDE and in the terminal. All right? I mean, I know that rattles a lot of cages because a lot of people have never even programmed outside of a notebook. But if you want to work in a professional environment with a professional approach, this is how we're going to do it. All right. So we're going to start by establishing our file that we're going to need. And let's call this logistic regression. So that's our blank screen, but we're not starting from a blank screen. We're going to be using ChatGPT. So let me bring that up. And again, if you need me to zoom anything, let me know. Okay, so these are the frameworks it knows. Scikit-learn, Stats Models, Keras, TensorFlow, PyTorch. PyTorch is for people who don't love themselves. And yeah, so I think this is reasonable code to start from. All right, so now let's continue our prompting. Let me make sure I bring up OBS also so I can see your questions. Okay. So we're going to tell it we want to use scikit-learn. And then it's important for us to see our metrics, right? Because we're data scientists, right? So we always want to measure our metrics and see how it works. Just a regression model. All right, let's see what it gives us. We're going to do an install of scikit-learn, which already exists in our environment. That's pretty standard. It's going to use NumPy. It's going to use train test splitting. It's going to use a learning data set. All right, what do you guys think? Can you guys see that okay, or should I bring that to VS Code? Yeah, this looks really good, actually. Explore the beauty of nature. Don't take it seriously, man. It's just lightening the conversation. Relax. You can use PyTorch all you want. All right, what do you guys think about this code? Sorry, you guys are too serious. I just like picking on PyTorch and Java. It's just for fun, guys. Relax. What do you guys think? Line 9 here is jumping out at me. Excuse me. What do you guys think? Does this code look reasonable to everybody? Or anything else jumping out at somebody? What is this telling you guys? Anybody? Okay, so Patrick says it seems good. It does seem good, right? Like I think this code is reasonable. But again, we're not being blind here. We have to use our own skills. Because remember, guys, we also saw the ChatGPT make a very basic mistake last week, so we got to be on our toes here. So what is special about line 9? What do you guys think? Okay, Hamad said also looks good. All right. Well, look, the answer is that line 9 jumps out at me. Like, that's the first thing I noticed. 1, it's telling us what our sample size is. 2, it's telling us n features equals 20. That means it's going to use 20 different features, 20 different x's, right? Coming back to our formulas. It's also telling us classes equals 2, which is what we would expect, right? For logistic regression. And then it sets a random seed, which is common, right? But those things you should be looking at, right? Because ChatGPT could have made a mistake, right? It could have said n features or n classes equals 6. Are we doing logistic regression at that point? No, right? That's not logistic regression, right? So these are the types of things that we again, as editors, should be looking at. This will become our new work, right? We're not going to be starting from a blank screen, but we sure do need to verify what it tells us, right? Yeah, Patrick. So it is our data set creation, Patrick. But there's a lot of really important things in here, right? Because it's telling us what ChatGPT chose for us for that data set, right? So really important. Same thing here. Here we can see that ChatGPT has chosen our test size for our test train split, right? Our train test split, right? It's telling us that it's going to train on 20% of that data set, 20% of the 1,000 samples, right? Is that reasonable? Yeah. Are there times we want to adjust that number? Sure. Depending on the data we want to use. But these are the things that like your trained data scientist eye should be looking at and should be saying, oh yeah, wait a minute, that does look good, or no, whoa, wait a minute, what's going on there? Okay, see, so Hamad Javed says train test should be 70-30, I think. Yeah, maybe. There's times when you're going to want to adjust that. I mean, we haven't run this particular code, so I can't tell that. But yeah, Hamad's right on that. There are times you're going to want to adjust that. But again, my point here is not to stress the methodology. It's more about hey, we didn't write this code, so we still need to be editors of it. We still need to kind of take a critical eye and say, yeah, that looks good, or no, that doesn't look so good. I think ChatGPT made a mistake here, right? So I want to kind of stress that to you guys, because it's super important to be able to understand that, and that we're not just sitting back, right? We still need to be trained. We still need to be a pretty smart data scientist, but we still need to kind of, go for it, right? As she says, surprisingly, ChatGPT gave me almost the same code in the same random state. I am glad. Assuming it's correct, right? We haven't run it yet. But yeah, generally speaking, that's a good thing, right? But we haven't run it yet, right? So I love the fact also, another thing that caught my eye, guys, we're going to run this code shortly, but another thing that caught my eye is that it also gave us the accuracy like we asked. It also gave us a classification report, and it also gave us a confusion matrix. That's a very reasonable amount of metrics for us to use. So I'm really happy that ChatGPT did that. We only asked for accuracy, but it knows what we're asking for, and we should ask for a classification report and a confusion matrix. I was planning to iterate that, right? To say, okay, yeah, that's good, but then give me this, and we can still iterate through this. But ChatGPT kind of anticipated our needs and gave us the classification matrix and the classification report and the confusion matrix. So I think that this code looks reasonable enough for us to run. But yeah, let's try it. So we're going to go to our terminal. And what do we call it? Logistic regression. Okay, so now we're going to verify that the file is there. And it is. We have two files. I see my logistic regression. So now we're going to run Python regression.py, and let's see what it gives us. Okay. So I hope that's clear on your end, guys. Let me know if it's not. But it's giving me an accuracy of 85.5. F1 score of 0.85 for the 0 category, and 0.86 for the 1. The support column, right? That sums up to 200, which we shouldn't be surprised at. And everything else looks pretty reasonable. It's giving us a confusion matrix. I love how it laid it out. So what do you guys think? Give me your feedback on this. What do you guys think of these numbers? Anything jumping out at anybody? What would you be looking at to make sure that ChatGPT gave you valid code? There's one item that's jumping out at me. Yeah, there's one item that's jumping out at me on this chart. As far as, me verifying that ChatGPT is giving us a reasonable approach here. What do you guys think? If you just want to give me a looks good to me in the chat, that's perfectly acceptable. But there is, some things that are jumping out at me. One thing that's jumping out at me, I should say. Wow, we're almost at 2 hours, guys. Jeez, thanks for hanging in there with me. Wow. What do you guys think? Anything jumping out at the answers? Okay, Rahul, I appreciate the honesty, my friend. To be honest, I don't know how to interpret this, I'm afraid. Rahul, that's perfectly okay, my friend. It's important for us as data scientists to recognize our limitations, right? To be able to know when you can speak intelligently on something and when you can't. So Rahul, I appreciate the honesty. Totally okay. Patrick says all the numbers look reasonable. Michael says same. I don't know. Michael, I don't know if you're agreeing with Patrick or Rahul. It's kind of polarized there. Bala says macro average for precision and recall. What about them? Is something not sitting right with you there? Let me know. A lot of 0.85 by Michael. Okay. That's a good observation. Patrick says, do we usually break out precision and recall for each class? Yeah, you do. Yeah, even in the multi-class, you would do that. Yeah, that's standard. Yeah, see, Michael, now Michael, you got me super curious on whether you were agreeing with Patrick or Rahul. So, Michael, are you good with this, or do you need a little help? Let me know. She says my code gave me the same numbers. Okay. Ashish, do you know why that is? I know why. I fully expected that. So for extra credit, let me know if you know why it gave you the same numbers. But I fully anticipated that. I'm not surprised at that by all. Michael says with Rahul, okay, so Michael's being honest. He doesn't know how to interpret this. That's okay. Okay, so yeah, so a couple things jump out at me here. One thing we're going to start off on a basic level. The first thing that jumped out at me is the support numbers, because it's basically telling you how many are found within each of those classes. And what I'm looking for is that I want to see a balance between the two classes. So when you are doing categorical problems, classification problems like this, you want to make sure that your training data has enough samples that represent each of those classes, right? It's what's known as balancing. So when you hear about a balanced data set or a balanced training set, that's what you're referring to. So if you have two classes, or you want to make sure that you have roughly the same number of examples from each class in your training set. So that's what the support number is telling you. And this is a reasonably balanced set, because it's telling you how many are members of each class, right? So this is telling you that of the 0 class, the null class, it had 93 members, and it used 107 members of the positive class in the training. Or in the test, right? So that's a very valuable piece of knowledge to know, really to kind of validate your model, right? Because if these numbers were unbalanced, like it was like 15 from the null class and 185 from the positive class, that's a very unbalanced set. I wouldn't put a lot of faith in that model. Like no matter what the other numbers say, the entire model is probably not useful, right? You should probably throw that one away. But this one is reasonably balanced, so we can have a pretty good level of confidence in the model. So that's the first thing I'm looking for, right? I want to make sure that I'm using a balanced data set, right? The other thing that jumps out at me is that we can look at these precision and recall numbers. And by the way, the F1 score is an amalgamation of all those numbers, right? So you can kind of use that as your single value if you want to just look at something to evaluate. These numbers tell me that it's a reasonable model. These are reasonable results. It's certainly reasonable for your initial model, which can then be like your baseline model that you compare against, right? Because we should always have a baseline model. So this is reasonable, right? But that all depends on the business needs, right? Let's say that I want you guys to clear your mind, right? And I tell you that this model is a model that predicts whether somebody will default on a loan or not. And this is telling you overall at this we'll focus on the accuracy number. The accuracy value is 85.5. Your F1 scores are in that same range, so that means you can take a pretty good confidence interval or confidence feeling in that accuracy number, right? Do you think this is reasonable for a model that is going to make loan decisions? So Hamad is asking a similar question. If accuracy is more than 0.7, then model is all right. So again, let's clear our minds. And I'm telling you that this is for a bank. This is for loan decisions. And it has an accuracy of 85.5. How do you guys feel about that? So tell me how you guys feel about that. What's your take on that? 85% accuracy for a model to make loan decisions. Tell me how you guys feel about it. So I am Agnes. I am Agnes. The goal of this model in our example right now is that it makes loan decisions for a yes, no of getting a loan. How do you guys feel about that? I'll give you guys another 30 seconds in the chat. Let me know. You feeling pretty good about these results? Okay, so Hamad said for me it's more than reasonable. Okay. Anybody else? Just give me a feeling on it. You don't have to give me a rationale. Give you guys another few seconds here. Ashish says good enough. Maybe good enough. Okay. Anybody else? Patrick says 15% of loans will default not good. No, Patrick, that's not what this is telling you. This is telling you the accuracy of the model, right? That's what it's telling you. The results itself is more in the precision and the recall, right? Michael says good enough, but I think it depends on the bank. Okay. Explore the Beauty says this is okay. Okay. Moriah, welcome. I don't think I've seen you participate before. Welcome to the chat. It says in between may be good to good enough. Okay. Okay. So let's stop right there, right? Now, clear your mind. And I tell you that this model is a model that's inside a fully self-driving vehicle, and this is the yes/no on whether to press the brakes or not and stop. Now what do you guys think? Is 85% accuracy good enough? Give me your answer to that. Forget the loans, forget the banks. Now this is a model that's inside a full self-driving vehicle, a Tesla or whatever. And this is the model that decides yes, no, press the brakes. What do you guys think? How are you feeling about 85% then? Okay. See, Karthi says no. Moriah says not good. Jeremiah, no. Ashish, no. Yep, that's exactly right, guys. Karthi came back and corrected themselves on saying hell no because they wanted to make sure that we got his answer. Okay, Karthi, message received. Hell no, we got it. Okay, good. You guys are getting it. What's the lesson here, right? The model looks reasonable, but what's your real world application? How are you using this model? How is the business using this model? Again, guys, this is the below average data scientist to the great data scientist, right? You always have to keep the business part in mind, right? This is what I want to impress upon you, right? That's the lesson, right? That's my Yoda Jedi mode, whatever. I'm not a big Star Wars fan, but you now understand the lesson. All right? We as data scientists cannot live in numbers alone. You have to understand the real world impact of what we're working on. Is this model reasonable? Maybe, maybe not. What are we using it for? Where are we going to use it? How are we going to use it? How fast does it reply? Think about that. A model, just even if you got good accuracy, maybe it's too slow. Maybe the model doesn't work fast enough for you to press the brakes in time, right? You got to take this all into account. You got to remember these things, right? You got to know what the business approach is. Nobody in the real world of data science, nobody is giving you a paycheck to think just about numbers, or they're asking you to think about business impact. That's how you earn a living in data science. Okay, guys? So as she says, thanks for the example, Dennis. I love this. Good. I'm glad you guys are getting it, right? Because remember, I'm not here to be a college professor. I'm here to tell you about the real world, right? So that's my addition to the ISL book, to everything we're talking about, right? So keep that in mind, guys. All right? So you guys are getting it, right? But that's what I wanted to get across to you guys. All right, let's move on. I'm ready for KNN. Who's ready for KNN? Okay, so one thing we're going to do with our chats, and one of the things I have found very strong about ChatGPT is that we can ask it to remember different pieces of code, right? So let's make sure we do that. All right. All right. So see, ChatGPT has now saved it for us, because we're going to come back to this model. I want to talk about one more thing at the end. Guys, we are past the 2-hour mark. I love this. Thanks so much for the participation. Thanks for hanging in there with me. Some of you have been with me online from the beginning, so props to you guys. Okay. So all right, let's see what it has for KNN. KNN is going to give us a classification. All right. It's giving us basically the same code, but it wants to use the classifier with neighbors equals 5. So I'm not sure if I'm on board with that. What do you guys think? I'm going to bring this over to VS Code so you guys can see it a little better, but I'm not sure if I'm on board with this. So we're going to call this knn.py. What do you guys think? I don't know if I'm on board with this because of the classes. If you guys notice, this is basically the same code as before, but it still wants to use k equals 5. I think that this would give us not so great results, because there's only 2 classes, but it's asking for 5 clusters. What do you guys think? And by the way, you guys are asking really good questions in the chat. I'm going to come back to them. Meta, I want to come back to your question. Hamad, I want to come back to your question. Really good questions. So remind me at the end if I don't come back to them. You know, guys, I'm not on board with the number of classes. And I've seen ChatGPT make errors before and on other stuff I work with it. Weirdly enough, if you ask it to review its own code, it will make changes. So I want to do that. And it corrects itself. Or at least it says it's corrected itself. Change n classes if needed. Okay. That's weird. The only correction it did is it added this comment here. I want to see the rationale it gives me for this. All right, what do you guys think? Is that a reasonable rationale? It just doesn't seem right to me that it's telling us that we can use five models or 5 clusters for the neighbors when we know there's only 2 classes. What do you guys think? Is it asking for 5 clusters or using 5 neighbors to assign a class? Yeah, that's true. I could be misinterpreting the code. We can increase the number of classes. Yes, we can, right? And that's the first answer it gave us, right? It said that we can adjust the n classes parameter. The KNN method requires selection of k, the number of neighbors, not to be confused with the number of classes in the earlier section of this chapter. Is that pulling from the book, Patrick? Okay, he's pulling from ISLR. It seems like ChatGPT will be assuming it's binary. But it's telling us that it doesn't have to be binary if we don't want it to, right? It said that we can adjust it. Okay. So, Patrick, thanks for that quote. Yeah, I guess I'm tripping over my own shoelaces here. But let's go ahead and try it then. So that means we can go back to our terminal. Python. Okay. So our accuracy is a little bit different, but we're also using presumably different. Well, I guess no, it's going to be the exact same data. So it's the same data, right? And we can verify that because we can look at the support numbers, right? Same data. But you can see that the results we're getting are different. I mean, look at our F1 scores. Our F1 scores have dropped considerably. So what do you guys think of these results? What do you guys think? Give you another minute here to think about in the chat. It feels like there's a room for improvement here, yeah? Yep, she says accuracy is slightly lower. Yep, it is. Michael says not good. Did I change k equals 2? No, Patrick, I did not. I kept it at 5. We kept k at 5 and number of classes at 2. Personally, I think that's going to be a big part of that, right? A big cause of that. So there is a couple ways I want to go about this. Yeah, let's. I'm trying to think about the best way to go about this. Let me go back here. And let's hit on Patrick's earlier point about how neighbors is something that we can modify, right? As Patrick pointed out here, the KNN method requires a selection of k, the number of neighbors. So let's pick a different number of neighbors. What if we went down to, no, let's increase it actually. All right, what do you guys think? Before we run this, give me a 1 or a 0 in the chat. Do you think, give me a 1 if you think that our results are going to improve. Give me a 0 if you don't think it's going to improve. It's going to stay the same or go lower. What do you think? Changing the number of neighbors, what is that going to do? Because remember, as we said, what it does is it takes in the other points that are close to it and creates those clusters, right? And makes those decisions on where it belongs, right? So here you're using more of those neighbors. So what do you guys think? Is it going to improve? Give me a 1 if it's going to improve, a 0 if you think it's going to be the same or lower. Okay, Rahul and Patrick are both on improve. So is Ashish. So is Lakshmi. Yeah, and I generally agree with that. We should see an improvement here, right? Are there any other concerns that we should have now? Can us changing this to 8 have any other impacts that we should consider? I can think of one. Give you guys a couple seconds to think about that. In the meantime, I'm going to run it, but I want you guys to think about that. Are there any other impacts we should consider given that we now change to 8? So these are our results using 8, right? Ah, Patrick hits on a good one. More neighbors equals more computation. That's exactly right. What else could it mean? Does it mean more data? What does that mean for our 0.2 for our train test split? Earlier, some of you thought that the train test split should be more like 70-30. Yeah, and Jeremiah's right. It's not any better. So now, I want to go back, and I want to increase my samples. And now, using the earlier advice, I can't remember who it was, but somebody suggested a 70-30 split. I want to do this. Right? Let's run this version. Still 8 neighbors, right? Now what do we think? It's gone up, right? Our accuracy has improved. It's gone up by almost 2 percentage points on the accuracy. And our F1 scores, look at our F1 scores now. Our F1 scores are much more reasonable. So now, what if we go back, or what if we pick something in between? We went from 5 to 8. Let's pick a 6. You know, just increase the neighbors a little bit, not as much as 8. Now what? $81.3, so it dropped. So there's a big difference between using 8 neighbors, right, which is 82.4, versus just 6 neighbors, right? Let's see what this looks like. Now we're pushing it to 12. And 84 is an improvement, right? That's an improvement over 8. What was 8 at? 8 was 82.4, yep. And now we are 84.07. What do you guys think now? 84.07, now we're approaching what we were getting before with the logistic regression model, right? What do you guys think? Let me know what you guys think in the chat. The chat has slowed down. I'm guessing you guys are thoroughly confused now. Is anybody out there confused and wants to admit it? Lakshmi says increase the accuracy but increasing the neighbors. Yep, we sure did. More data is more better. There's some interplay between a number of neighbors and available volume of training data. Yeah, there's a correlation there, Patrick. But we are causing that correlation because we are asking the model to use more neighbors, right? So we are the cause of that correlation. But Lakshmi's observation is valid, right? It increased the accuracy, but increasing the neighbors. And we should expect that, right? Because we're giving the model more data to work with for each of the individual data points, right? So here's where I want to go with this. And this is going to be a little bit of a new concept, but something super, super important for you guys. This number of neighbors, right? And this conversation that we're having. We started at 5, we went to 8. No, let's bring it down to 6. Well, what about 12? That conversation, that's the experimentation of data science. This is where the experimentation of data science begins. So when I tell you guys that, data science is a scientist, I think of myself as a scientist first, we should be applying the scientific method. This is where all of that begins. So the takeaway here is something known as a hyperparameter, right? That's what you're talking about when we're adjusting the neighbors. Adjusting the neighbors is an example of hyperparameter tuning. So that's where you would begin your experimentation. What happens if we just use 2 neighbors, 3, 4, 5, 27 neighbors, right? Where is like that diminishing returns, or where does the improvement happen the most? This is where the experimentation of data science begins. So you would want to do some what's referred to as hyperparameter tuning to figure that out. This is an example of that hyperparameter tuning. And then you might want to make adjustments to say, well, if I'm going to increase my number of neighbors, then I need more data. Right? So now it's on you to go out to the business and say, hey, I need 10,000 more records. Or maybe you need to examine how balanced that data set is, because if it's an unbalanced data set, you have to fix that, right? Very few things are going to help you there from an experimentation perspective, right? So these are the things that you're kind of being slowly introduced to. So I'm showing you a manual example of how to conduct that hyperparameter tuning. But there's ways for you to do it via code, right? You're going to want to Google about grid searches, right? Because grid searches is essentially what you would use. Or in some cases, for something like this, you could do it by yourself in code, right? You can do it by yourself doing the... just doing a loop, right? And trying different versions of the model. This is going to be my version 1, my version 2, my version 3. Okay, what did I change from model to model. You want to minimize the number of changes you're doing in each model. Okay? So I want you guys to think about it in those terms. That this is where the experimentation of data science begins. All right, there's one more thing I want to cover before I leave you guys, because I think we should be looking to wrap up the session. We're hitting 2.5 hours, guys. Good for you guys for hanging in there with me. There's one more thing I want to cover, and again, we are not code writers, we are editors. So I want you to, we're going to go back to our chat GPT. So use version 1 and so here's one more thing I want to leave you guys with, and I meant to show this to you guys last week, but we just ran out of time. But I want to copy this code, and we're going to go back to Visual Studio. We're going to go to our, let's create a new file. Logistic. Here's another thing where I'm going to rattle some cages. But you guys need to get used to this, because again, we are professional data scientists in here, right? So professional data scientists write programs, not scripts. So this is a script. This is a pretty straightforward script with sequential programming, right? But if you want to get out there in the real world and you really want to, if you really want to impress on a code test, or you really want to impress somebody on your first day, because you landed a job and you want to show that you work in a professional environment, this is a type of code I want to encourage all of you to start with or start working on, right? You should have an entry point. You should be pointing to a main method. The main method sits here, and it's basically just using the same code we did before, but in a way that's broken out by methods. You have your imports at the top, you have the methods that you're going to need, and then you have the main, right? So in main, you're loading your data, right? So that means you're calling your load data method, which is really the same as before, right? Same lines, but it's a much more organized, much more reusable way, and it's also commented, right? ChatGPT added the comments for us. But this is how you lay out professional code. And I have a template, and I want to show you one more thing that ChatGPT does not add, is you also want to add a template header, or excuse me, a file header that always sits at the very top of all of the code that you write, okay? So you're going to describe what the file does. In your old school files, your old school guys, they also include the name of the file at the top. That's something that's kind of fallen out of practice, but you are going to come across some files that do that. But you always describe what your code does and any inputs and outputs that you need. And then you always write a copyright. Your employer or your client usually owns the copyright. So that's me. I have my own LLC. And then you always list yourself as the prepared by person, or the programmed by person, because in the real world, you do not own the copyright to your code. That's called your stock in trade, right? The stock in trade is that you wrote the code, but they're paying you for it, so the company owns the code. You never put a copyright of yourself. And then that's where you start the rest of your Python. So if we run this Python will run the same as it did before, right? It's not going to be any different, but it's much more readable, and it kind of adds that professional polish to your code. All right? So I want to leave that with you. I meant to leave that with you last time, but I want to make sure that you are also just taking the time to do that extra polish to your code. Okay? So if you have any questions on that, let me know. I might put this file up on our Discord so you guys can see an example of it. But start working away from notebooks, start working away from scripts, and start thinking more about programs where you're taking the time to create your own methods, and then the next iteration of this is to create your own classes, right? In theory, this could be its own class, and it should be its own class, right? We could easily rewrite this to be its own class, but these are the types of things that I want you to think about when you're getting out from the to the real world. Okay. All right, guys. So going back to the deck, I've hit on all the lab items that I wanted to do. We created a logistic regression. We created a KNN model, okay? Self-study. We only did single, well, actually, no, I guess we did do multiple features, right? So what does it look like when you play with the features? Can features be a hyperparameter that we talked about? Can features be a hyperparameter that you tune? Yeah, it can be, right? We were using synthetic data. So now, can you replicate these results with real-world data? Go out and find a real-world data set. So for example, you're probably going to have problems with balancing, right? How do you overcome that? And then third, can you replicate these same results with another framework, right? If we go to the beginning, or I guess, you know what, let me somebody was butthurt in the chat when I said don't use PyTorch. So go ahead and use PyTorch. What does this look like in PyTorch? Right? Go use another framework and recreate the same results. Right? So those are all things for you to think about as far as your self-study. All right, guys. So I'm gonna look at the chat questions because I think we had some good ones. Last call for questions. We've gone for 2.5 hours. So last call for questions, but I'm gonna hit some of these questions. I think you guys are asking some really good ones. So let me go back to my broad view. All right, we had some really good questions. Yeah, so Meta asked a great question. How does the team check its applicability that it is actually satisfying business metrics requirements? You don't know. You don't know the answer, and that's why you should be involving the business. The business ultimately makes those decisions. And they know their data best, and they know the goal that they're trying to achieve. The best that we can do as a team is to present them with options. And to say, here, we did our modeling, and here is the 4 options you can choose from. And if you choose this option, these are the trade-offs. If you choose that option, these are the trade-offs, right? Or the business might tell you, yeah, show me 5 different models, but only if there's 75% accuracy above or not, right? They might set that threshold for you, but then you can show them different options above that threshold. So that's another way to do it. But the key takeaway here, Meta, is don't make those decisions on your own. Your stakeholders know that best, right? We conduct the experiments. We report on those experiments. We report on what the impact is of each of those selections, and then they choose from there, right? So that's the key takeaway you should be thinking about, that we as a data science team shouldn't be in charge of making those decisions. The business should ultimately make those decisions. All right, let me make sure I go to some of the other ones. Yeah, Hamad says, considering your autonomous car example, it's horrible. Yeah, it can be absolutely horrible depending on the application. So, yeah, so when somebody says, I got 85% accuracy, great, maybe, but what are you using it for? How, is it effective for the real world application that you're going to take that to, right? See, again, this is one of the reasons why I get so disappointed in all of the people that are obsessed with math and data science. Data science is not a math exercise. It's a real world applied exercise, right? You can't just be siloed into your numbers and formulas, right? That's not data science. Data science has real world applications. Data science has real world implications in the effects it has on people. So yeah, in a decision for a car to stop or not, that's a terrible accuracy rate, right? It doesn't matter how beautiful the formula was to get there, and this is some great formula that I moved into code. Who cares if it can kill somebody, right? So don't get caught up in everybody else talking about the math and you got to know linear algebra. No, it's an applied science. Okay. Lakshmi says also 730 split improved, I guess. Yes, it did improve, but we should have expected that, right? We should have expected that because you're giving more data available for the model to learn from, right? Or to test on, right? and it's going to make those adjustments based on that. So yeah, it did help, somewhat expected, but you also don't want to get too crazy with that tuning, right? Because then you could be running into issues where it's more of a bias that's in your training data. So you want to be careful with it. It's a careful balance. But again, that's the experimentation of being a data scientist. Okay? Okay, we got a Stack Overflow question. Patrick says stop off. Yeah, thanks a lot to Patrick for all his moderation and all his work. Okay, Lakshmi says we can also use feature selection for improving model performance. What is your view on this? Absolutely you can, right? You can absolutely do that. Again, it's tempting to think about it as a hyperparameter, but it's really not. It's more about how you're setting up your entire experiments, your entire modeling to begin with. Because when you're talking about feature selection, you're also talking about feature engineering, right? What are some of the features that are there that you can modify into other features? What are some of the other data sets you can bring in, right? Answers aren't always within your data set. You might need some external data, what's known as enrichment, right, to help you with that, right? So yeah, Lakshmi, I love your thinking. You're on the right track with that. Because there are times when you are going to have to bring in other data, or maybe, there's a time where you're doing all this testing and you can't get beyond that 85% that we saw, right? Because we didn't see anything above 85. But now you're saying, well, wait a minute, let me bring in this other data set. Let me bring in this macro financial data. Let me bring in this weather data. Let me bring in, other sales information that just came, that was just made available to us. Yeah, so you're on the right track, Lakshmi. I love your thinking. That's exactly what you want to be doing at all times, right? That's you using your creative data scientist mind. So good track on that. Ashish, thank you, Dennis, for that extra tip, especially the note. Thanks again for the hard work. Yeah, you're welcome, Ashish. And I'm trying to show you guys in a professional way, right? If I'm contributing to the world of data science, I want to create professional data scientists, right? So I'm teaching in the same way I teach people that have worked for me over the years. And I think I'm teaching you stuff that nobody else out there is talking about, right? Because they haven't really worked in the real world. I mean, most of your data science people on the web haven't really worked in the real world. They just haven't. So yeah, so I'm showing you guys that. Explore the beauty of nature. Thank you for the tip. How does this compare with OOP? Yeah, great question. Love the question. Breaking out your code like this. Let me go back to that. Breaking out your code like this with a main entry point and your main methods, this is the start to OOP. The next iteration, as I mentioned earlier, is to take all of these others, these supporting methods, and create a class out of them. You can absolutely do that, right? And creating classes is your start to object-oriented programming, right? It's more reusable, it can be consumed in many different ways, so on and so on, right? So yeah, great question. And this is where it starts. So explore the beauty. If you want to kind of take that as your next step, that would be a next step. Take this code here and break it out into a class. That's a great step towards OOP. And if you send me that, or you create that in a coding test that somebody gives you, that's like what you're doing, right? Like you're adding that extra professionalism to your code when you start writing like this, and then you take it to a class and you consume, and then you instantiate the class properly and you use the class like you're showing some really good stuff, right? That's a strong application if you're still trying to, land a data science job, okay? Synthetic data eliminates EDA? No, it just so happens we didn't do EDA for this particular exercise, right? But no, it's no EDA. You're always doing EDA. Thanks so much, Dennis. Next Sunday we'll be covering Chapter 5. Yes, we will, my friend. And great job on participating today, Rahul. You gave some great answers. But yeah, Chapter 5 is next Sunday. That's exactly right. Jeremiah says good night. Okay, good night, Jeremiah. And Neruth Mani joined late but still gained great value with content. Thank you. Well, thank you so much. Appreciate that feedback. Feel free to go to the replays. As soon as I finish, the replay is posted on YouTube. So if you want to catch the first half, go and see it there. We must optimize skewed data always. This example, it happened that the data was very balanced, right? But it's not always going to be that way, especially in real world data. So I agree with you, Hamad. Sirban says, thanks, Dennis. You're welcome. Thanks for coming. Lakshmi, thanks, Dennis. Learned a lot from today's class. Great. Nazish says, thank you, Dennis. Your session was really what to learn if the goal is to work in the industry. Yeah. Yeah, Ashish, that's what I'm trying to do here, right? I love the book, but not everything in the book is real world. I'm trying to give you guys the real world. I'm trying to give you that because I don't think anybody else out there is qualified to do this, right? A lot of the influencers out there, they just haven't worked in the real world, right? Or they're fake videos, right? Because you can make stuff on ChatGPT and do the faceless videos and all that. But yeah, I'm giving you the real world answers. All right, guys. So I'm looking at the chat is slowing down. Thank you so much for joining me. We went for more than 2.5 hours. I know some of you were here from the very beginning, so good job, guys. You're showing me that you really want to learn if you're here for the whole session. So thanks so much. Really appreciate your support. I have fun doing these. So it's still summer. It's hot out there, so stay cool out there. Take care of yourselves, take care of your families, and I'll see you next time. Good morning, everybody. Happy Sunday. How are you? I hope you're doing well in your part of the world. I hope your families are well. And also, I hope that you're ready to come and learn and have a good time and make some more progress into our continued study of the Introduction to Statistical Learning book. We've been having some really great sessions. I had a really good time during last week's session because there was a lot of interactivity and a lot of questions. So really happy to see that. And I think we're going to have a little bit more of that today. I think today is a very special chapter. For today, I do want to cover chapter 5. We've been making great progress. The whole book is only 10 chapters and we're already on chapter 5. So we should all feel pretty good about that progress that we made. And I already see a couple people in the chat that have been consistently coming, so I'm really glad that you guys are getting something out of this, and I'm sure that there's people also that are watching the replays, which is also fantastic. So I think we should all just kind of take a little bit of a step back and realize that we're making some really good progress. This is our 3rd session. We're already on chapter 5. The entire plan is to have 8 sessions, so we're almost at the halfway point of the sessions overall. So really, we've been doing so well. So thank you so much for making this a positive experience for both me and for you. But today is going to be chapter 5. We're going to learn about resampling. We're going to learn some terms and some definitions. To me, well, let me put it this way. I've gotten questions in the past in the chat or messages or whatnot or comments where people say, well, where can I learn the vocabulary of data science or can you teach me the vocabulary of being a data scientist? Because sometimes I say that in some of my content where I tell you that when you've done the work, when you've really put in the time to be a data scientist, it comes out in how you carry yourself, the vocabulary you use, the terms, the way you explain things. There's no shortcut to learning that. I'm not going to sit here and type like a list of words that, as a cheat sheet that people can use. That's not my style at all. But I think that today, with chapters like resampling and some of the methods we're going to look at, this is kind of where your vocabulary and your approach to data science kind of takes a step up, right? Here's when we start talking a little bit beyond algorithms and like, I don't want to say the basics of data science, but I think that in this chapter, you really kind of take a step up in your thinking and in your overall approach. I really didn't understand the intricacies of data science until I really understood some of the resampling concepts that we're going to cover today. What do you mean an algorithm learns it? What do you mean it trains itself? What? Like, what are you talking about? Like, it started to make sense for me after reading a chapter like today. So I'm super excited. I put these materials together like, the night before or a day before because, sometimes I need a refresher. So it's been fun to go through some of these chapters to kind of bring all that to you. And as I've done before, I'm going to break out the things that I think are the most important. I curate the chapters for you because obviously I love the authors. I love this book, but I've seen, I come from the real world perspective. So I've seen some of these things definitely used and some of these things less used, right? So I'm going to give you some of that today also because, it's always helpful to have like that real world check. So I see people already joining us on YouTube and already joining us on Instagram. Bala R, can you please start? That's what we're doing now, my friend. Pump the brakes here. Pump the brakes, okay? Calm down. Everybody calm down. We're going to have a great session. I think I might need more moderation on Instagram for things like that. But yeah, I see people in the chat already. If you're on Instagram, I love that. Instagram will always be my favorite platform. However, for classes like today, it might be a little bit better for you to view it on YouTube. That way you get a widescreen format. You can see the different things that I'm sharing on the screen as far as the different, kind of like a classroom view that I have. So please consider also joining us on Instagram. On YouTube, because I think the format's just a little bit more convenient there. Or you can always, join us right now on Instagram and then watch the replay later on YouTube. So I want to acknowledge the chat because we have so many people already in there. If you are joining us, feel free to introduce yourself or just say hello. Or maybe you just want to hang back and just, enjoy the materials. That's okay too. But I want to give it just a couple of minutes here so that we can kind of see where everybody's at and just say hello to everybody. All right, so Joseph Hernandez, my good friend Joseph, a huge participant in our chats and in our Discord. So if you'd like to join the Discord, please do so. We've been having some great conversations on there. It's a great way to keep in contact with everybody, kind of away from the streams or away from more static content. If you need a little bit more real-time feedback, the Discord is great for that. So Joseph, glad to see you here. And Joseph is also helping with our moderation on the YouTube side. Hamad, good to see you. Another great participant on Discord from Haripur, Pakistan. Welcome, Hamad. Good to see you. Rex, our good man in New York City. Yes, I've heard that it's rainy in New York City. I still have plenty of friends there. I heard there was a big rainstorm yesterday. So Rex is also helping us with the moderation on the Twitch side. We have a growing presence on Twitch. I think we're going to get a lot more participants on Twitch. So Rex is going to be helping us with that. So thank you to Rex, Joseph, and Patrick Stefanik for helping us with the moderation. If you want to give them a shout out. Rohan, my good friend from Bizag, India. Nice to see you. Glad to see that you're still coming back to the classes. Thank you so much. Explore the beauty of nature. Great to be here today. My good friend, Explore the Beauty. Explore the Beauty is one of the folks that has been here since the first session. So thank you so much for your continued study. I hope this is helping you. I know you've been there from the first session and you stayed for the whole session. So that's not easy because sometimes we go 2 hours plus. So thanks a lot for that. Good to see you, my friend. Hope you're well. Samir Sen. Samir, good to see you again. I haven't seen you in a little bit. I know you've been a great supporter in the past. I hope you're well. Hey, Dennis, checking in from Lalitpur, Nepal. Hoping you're doing great. I'm glad today I'll be here the whole session. Wonderful. We'll be glad to interact throughout the session. Wow, 2 wonderful things. Thanks so much, Samir. And we're going to need the interaction. I'm going to be asking a lot of questions today, okay? So I'm going to be asking a lot of questions and you guys are welcome to reply. I know some people are maybe a little hesitant to reply. That's okay if you just want to hang back. But sometimes it just helps to see where each other's thinking is at, right? Part of the scientific process is understanding and being able to appreciate other people's perspectives. So we're going to do some of that today, okay? So Rex saying Twitch is here. Yep, thanks so much, Rex. Appreciate you doing the moderation there. I am 541 Vikral. Hi, sir. Hey, nice to see you. Let us know where you're from, and I see that you're on Instagram. Feel free to switch over to YouTube. Just might be a little bit more of a convenient format. Michael, happy Sunday, everyone. Michael here from Lagos, Nigeria. Nice, Michael. Good to see you, my friend. I'm pretty sure you've attended the classes before, so glad you're well. Good to see you. Alan Valdez. All right, boss, I'm in. First time caller, long time watcher. All right, Alan, thanks so much. Thanks for stepping up and saying hello. Really appreciate you doing that. Good to see you. And, maybe you'll feel comfortable participating in some of the back and forth and some of the questions, because I do throw out questions. So I appreciate that you're here. Joseph is very conveniently putting out a link to the Discord. If you guys want to join us on Discord, we've been having some really good conversations. Please go ahead and join us. And again, it's a good way to keep the conversation going beyond when I'm online or other things like that. Plus, I think it's really cool to see the community helping each other. We have some really smart people in there, so really, really glad to see that interaction. Amina Blue says, hello, Dennis. I have a few questions regarding the previous lies, if we could go over them. Thanks. Yeah, I think you might have sent me a question overnight, and I mentioned that the Discord would be great for that. But yeah, if you want to, hang out And I will make time towards the closing end of this session, of today's session, to address some of those questions, or people have, well, undoubtedly questions will come up during today's stream, right? But let's hold those to the end if you don't mind. But I appreciate that that you came back, and I'll be happy to address them. Okay. Stippus says hello. Stippus, nice to see you too. I think you're one of our more recent joiners on Twitch, so glad to see you there. I'm slowly growing on Twitch. I finally got to the double digits on Twitch. It's been a long climb with the Twitch platform. I guess it's because it's so oriented at gaming. But, slowly, guys, we're gaining an audience on Twitch. So good to see that you're checking in. And by the way, again, if you're on Instagram, maybe you don't have a YouTube account. Most people do, but maybe you have a Twitch account. And Twitch also provides a good widescreen format for you to view all the classroom material. Amine says, watching from Morocco, it's 4 p.m. actually. Yeah, I'm sure it's a little bit later in the day in Morocco and in a lot of countries. For me, it's early morning. For me, it's 8 a.m. and I love streaming at this hour. But yeah, it's the most convenient hour I could find for most regions. But thanks for joining from Morocco. Alan Valdez says that Discord link has expired by the. Yeah, Alan, thanks for that. We do need to update the Discord link. Joseph, there is a newer one available. I just don't think I've sent it to you, but we'll take care of that, Alan. We'll take care of that, a little later today, or feel free to send me a DM and I'll get it to you. But yes, you are right. I think there is a more current link, and which I'm really disappointed in, because the initial one I created said it was non-expiring. I set it for non-expiring, but then for some reason at 60 people, it just stopped accepting people. So I don't know what happened. But yeah. Al Kathiri says hi from Oman. Nice. I don't think we've had many viewers from Oman, so nice to see you. I don't recognize your name, so I think you might be the first time joining us on the Sunday session, so welcome. I see that you're on Instagram. Feel free to switch over to YouTube if you're comfortable. That way you can kind of see the classroom view and all that, okay? Ahmad says, congrats on 2,000 subscribers on YouTube in advance. I appreciate that, Hamad. It's gonna be a little while still for 2,000, but thank you for that. I just crossed 1,000. Working my way up, right? You just got to keep at it. But you know what? I'm just having fun with this because I'm passionate about data science. Hopefully, I'm just letting all of the other stuff kind of follow behind, right? I'm just going to keep on doing the best I can to bring you my experience from, my time in the trenches in data science, and hopefully good things will come, right? That's all we can do. Michael says Discord link not working. Yeah, you're right, Michael. We'll get that fixed. Okay, looks like Joseph has published a new one, guys. So let's go ahead. So maybe you guys can try that one. If not, Joseph, I'll send you the latest one. I can't remember where I posted it. I should have sent it to you via private message. But yeah, but Joseph looks like he's generated a new one. Hey, Adela, let's try to not spam the chat, please. Okay. Well, first of all, today we're really not taking questions. I'm willing to take questions at the end because I'd rather get to the class materials, because I know that's why some people show up. But please, let's not try to spam the chat. If you post your message and it appears on your end, I guarantee you it's appeared on my end too. It just takes me a while to get to the questions. But please, let's keep it professional and not repeat the questions. Okay, so what I want to do is I want to cover the class materials, and then we'll do questions at the end, because I'm almost positive that today's session is going to bring up more questions, right? So totally get it that some parts of today are going to be maybe just a little bit challenging, but I think that it's going to be fun. And today might be one of those sessions where you kind of have to, take in the information, walk away from it, and then things will start to light up. But like I said, for me, chapter 5 was a huge aha moment in my own, education cycle. So, interesting topics says, can you tell me what is going on in brief? Just join now. Well, thank you so much for joining. I appreciate that you're spending some time with us. Essentially, we are going through Introduction to Statistical Learning, which is a great book for data science, for professional data science. Today is chapter 5. You are welcome to look at the previous replays that are stored on my YouTube channel for the previous chapters. But today is chapter 5. So let's get into it, because I know people showed up for the class, so let's do it. All right. Chapter 5 is resampling methods. And by the way, guys, if you need me to blow up anything on the screen because it's not big enough on your screen, let me know, okay? And let me adjust a couple things here to make it even bigger. Get rid of that, and we're gonna get rid of, oops, nope, got that wrong. Okay, that makes it slightly bigger. Okay, chapter 5, resampling methods. All right, what is resampling? Let's start right there. We're gonna start with audience interaction right away. If you're comfortable, because I understand this is taking a step up, right? But if you're comfortable, give me your elevator pitch on what is resampling methods. Well, what are we referring to when we're talking about resampling methods? You can give me examples of resampling methods. You can give me a definition, whatever you guys think, whatever pops into your mind when you're thinking about resampling methods. I'll give you guys, a minute or so there to think about it. Amrapali, hello, welcome back. I'm pretty sure you've attended our sessions before, so good to see you again. So we're just getting started, and the current question for the chat is, what is resampling methods? Just tell me what you think it is. No, don't need to give me a fancy answer. Just give me your elevator pitch, or give me examples of what it is, or something that you think is associated with it. What do you guys think? Okay, so Hamad is stepping up, putting up our first answer. Resampling is drawing samples from training data to fit in our model. Okay. If you want, you can just agree with Hamad, right? You can say, yep, I agree with Hamad. Or, okay, so Alan says, I agree with what Hamad said. Praveen, good to see you again. Welcome back. Yep, but Alan says, I agree with Hamad. Anybody else? All right. David Warder, welcome. I don't think I've seen you before, so welcome to the chat. David Warder says, using individual data points more than once in planned methods to increase your statistical power. Okay. David, I like your take on this. You came at it from another angle. We're gonna come back to what David said. I like it. Explore the beauty. Says this is a technique to modify the training data to improve the model's performance and increase overall accuracy. All right. Bright Eggbee, and I don't think I've seen you before, so welcome. From my understanding, a method to balance data set with unbalanced labels. All right. All right. Amram Pali says, picking different combinations of samples from the same pool of a data set. All right. A resampling method is a way to understand data better by taking multiple smaller samples from a set of data. All right. Samir says creating new samples from existing data sets. Okay. All right, anybody else? These are great. These are all great answers, by the way. Anybody else for resampling? Good answers, though, guys. Great participation. All right, so I'm going to give you a couple different definitions that the authors give. These are two items that I've pulled from the book. These are directly in the book, and in fact, I think that they're in the first section, right? So this is what they're offering. What do you guys think? Exploring the beauty adds examples include bootstrapping and cross-validation. Okay, I love that you jumped to the examples. We're gonna get to those, but yeah, I love the fact that you pointed those out. So what do you guys think of these definitions with the authors? Do they kind of fit what the previous answers that we saw? Because it's nice to see that most of you did have an opinion on what resampling is, right? Some people would shy away and say, well, I'd rather not say, but you guys did a great job with coming up with them. But what do you guys think? What do you guys think? I mean, I think that, personally, I think there's a pretty good parallel here with what the authors are saying versus versus what we saw in the chat. So you know what? Let's make this a quick poll. Give me a 1 if you agree that that the chat correctly identified what the author said, or give me a 0 if you think that there might be some other gaps or if you see it a different way. But generally speaking, I think that it deserves a 1, but give me a 1 or a 0 in the chat. All right, so Rex is voting with a 1. He thinks that we're pretty closely aligned with the authors. What do you guys think? Anybody else? All right, there's another couple 1s. Okay, yeah. So I think that we're in general alignment with what the authors are writing. Yeah. Okay. I'm seeing a lot of 1s in the chat, and I think you're right. I think that we are understanding the what of resampling. Like, what is it, right? But here's another question, another similar question. But I want you to think about this way though, right? Why does resampling exist? I think we gave ourselves a pretty good definition of the what, right? What is resampling? But why does it exist? Like, why would you need to do this? Like, why is resampling even a thing? So give me your elevator pitch on that. I mean, the authors dedicated a whole chapter to resampling, right? So it must be important in some way. But I want to understand the why. Because remember, we're professional data scientists, right? So we always kind of want to seek out the purpose for what we're doing, right? Because otherwise you're just a monkey, at a keyboard, right? But you want to understand the why of, why are we pursuing resampling? Okay. Okay, so Deb is stepping up and saying if sample does not represent the population correctly. Rex says to mitigate issues with small size data sets. Because data sets are usually big. So this is Samir, by the way, because data sets are usually big. So in order to simplify the decision-making process. Joseph says we would like our sample to be more representative of our population, perhaps. Okay. It is sometimes expensive to collect large samples of data, so resampling help us. Okay. David says data is finite. You can't always go out and efficiently get more data, so you have to be efficient with what you have available. All right. Hamad says because of limited data. Okay, guys, so let's put a stop there. Because I'm not sure if I'm on board with the answers so far, right? Because at this point, there seems to be a little bit more of an emphasis on the sampling side, right? Because that's kind of like where these answers are headed, right? Like, I appreciate the participation, guys, an A for effort, but let's kind of rework ourselves back, right? Because I really enjoyed Explore the Beauty's mention of bootstrapping and cross-validation. Now, I know a lot of you have read the chapter ahead of time, or maybe you're already familiar with the book, or a lot of you can give me a definition for what cross-validation is, right? Cross-validation isn't because of some of the items that you guys are mentioning here. It's not because of limited data or because the data is too large, so we want to maximize the efficiency. That's not really what cross-validation and bootstrapping is for, right? So let's kind of hammer that conversation back into it. Hamad says also model validation and estimating accuracy of parameters. Okay, okay. See, so now I think that we're kind of getting ourselves back on the right track. So let's try to build on Hamad's statement there, because I think that's a little bit closer to where we want to be. Yassine says, so that our model doesn't just memorize the data and be able to detect patterns and generalize. Okay, okay. Michael says to eliminate bias, I guess. Okay. Michael, I think that's a creative answer. I think you might be on the right track there. Rex says to evaluate model performance. Okay. Yeah. You know, Rex is the first person to mention model performance, right? And that's kind of a key thing, right? Hamad says model validation, we use cross-validation for accuracy parameters. Model validation, we use cross-validation for accuracy parameters. We can use Bootstrap. Maybe, I don't know. Amrapali says to improve the accuracy of population parameters. Okay. All right. You know, I love this though. I love that you guys are taking a refreshed look at this, because some of you are kind of like revising your previous answers, and your second answers for everybody I've seen so far is definitely more on the right track. So I'm liking where this is headed, right? So I think you guys are successfully coming back onto the right track. So this is great. Nyan, good to see you, Nyan. I know you've attended before, so good to see you. Resampling is done so algorithm learns in a more generalized manner and not succumb to overfitting. Oh, Nyan, Nyan, you're so close. You're so close. You had me at learns, you lost me at overfitting. You're so close. But yeah, Nyan coming in strong with their first message. But yeah, like you had me at learns, you lost me at overfitting. We're gonna get to that, okay? All right, so let me go to the next slide, because what I'm gonna do here is I'm gonna break down the two statements that the authors made that we just saw in the previous slide, right? So this here is the first statement broken down. Samples from a training set. Well, that's just the training data. That's all it is, right? That's just the training data. We know we need training data. That's no surprise. A model of interest. Well, that's what we're trying to find, right? That's the proposed solution, effectively, right? I mean, that's what we're after. That's the whole point, right? Obtain additional information about the fitted model. Well, that sounds an awful lot like the metrics, like the performance metrics, right? So what we're really asking there is, how did our experiments go? Right? So think about these three steps that we're talking about. Where's the data? We're going to fit it into the model, or use it to improve the model. And then what did that do to our metrics? Right? So let me say that again. Where is the training data, or what is the training data we want to use? How does it fit into our model, or improve or modify our model, right? Because I don't want to say improve or deprove or improve or break, I guess, or break our model, right? Because it can go either way. So how does it affect our model, and what was the result of those metrics, right? Doesn't that sound suspiciously like I just described a training cycle, right? Is that not an algorithm training cycle? What is the data? What do you think the parameters for the weight should be? And what happened to the metrics? How did it perform? That sounds like a training cycle, right? Let's look at the next slide. This is the second message that they made, right? The second message that I pulled out from the first slide. Repeatedly draw different samples. Well, that sounds just like training data we want to use, right? Fit linear regression to each new sample. Well, that's the proposed solution, right? And in this case, they've determined that it's a linear regression problem, right? And the third statement they made was examine the extent to which the resulting fits differ. Well, isn't that also looking at the metrics? And how did our experiments go? If we look at all three of these, the training data, putting it into proposed solution, how did our metrics change? Doesn't that sound like a training cycle? So give me a 1 in the chat if that sounds like a training cycle to you, or give me a 0 if it doesn't sound like a training cycle. What do you guys think? Because see, to me, like the authors basically told you the same thing twice. They just said it in 2 different ways. But give me a 1 in the chat if that sounds like a training cycle, or give me a 0 if that doesn't sound like a training cycle to you. I'll give you guys a minute there to vote. So yeah, if you're still on if you're still on Instagram, feel free to join us over on YouTube. The YouTube's format, right now, when I have the classroom view up like this, it doesn't always look so great on Instagram. So if you go to YouTube, you get a wider screen, or you can join us on Twitch. We have our great mod, Rex Riker, over there modding on Twitch. So might be a little more convenient than Instagram. I love Instagram, great platform. It's been good to me. It's just not great on Sundays when I teach this class. Okay, so I'm seeing a lot of 1s in the chat. Right? And yeah, I think you guys are seeing it, right? Resampling is just a training cycle. It's how algorithms learn. Resampling is just a umbrella word or the concept of how you train an algorithm. Here's the data, try it against the model. Here's what we learned, right? Here's the metrics that changed. But that is effectively what resampling is. There's different ways to do resampling, and those ways have different approaches. But when you think of resampling and the ways to do resampling, you should be thinking about, oh yeah, that's the training of a model. That's how a model learns, right? So some of you mentioned some of these terms that are now up on the screen, right? We saw people mention cross-validation. We saw people mention bootstrap in the earlier conversation. So I don't want you to kind of get confused in those, right? Because when you think about cross-validation is resampling. Bootstrap is also resampling. So by definition, cross-validation is the process that you use it's a process that an algorithm goes through to learn. Cross-validation is a way that an algorithm learns. So is Bootstrap. Because the algorithm is going out there, getting the samples, trying it against the model, and then trying it against the metrics, right? And then it makes adjustments and starts all over again. That's just kind of repeats that training cycle over and over again, right? But that's really what you should be thinking about when you hear resampling. Because see, I think some of the earlier answers kind of caught up in the sampling side of, oh, well, it must mean I don't have enough data, or I need to do this, and this, to kind of, try my data over and over again. Trying to get caught up in that, just think about how it's training. It's how the algorithm actually learns. It's kind of like a multi-step process that's just repeated over and over again. But it guides the algorithm to a new solution, to hopefully, not always, obviously, but hopefully an improved model. So in that second step, right, when you try to fit that model, it's going to be better with each iteration, right? So if you remember nothing, well, there's 2 slides I really want you to burn into your minds. This is one of them, right? Cross-validation, resampling, Bootstrap is resampling, which means that cross-validation is how the algorithm learns. That's it. That's all it is, right? Oh, excuse me. So I did want to say one thing though, because I did have a third bullet here, but for in practice. This is where I'm giving you like the real world of how this is done out there, right? In the real world, in the current state of data science, you're not all two things. One, you're not always explicitly naming or explicitly pointing out the steps for cross-validation or your resampling phase. There is no specific resampling phase. It's usually part of your overall model training phase. And I say that because most libraries will support an individual cross-validation function or method in their libraries. We saw that earlier this week, right? If you attended Tuesday's chat, I did a session on Meta, Profit by Meta, and they happen to have an individual cross-validation method. You're not always going to find that. What you are going to find is you're going to find a fit method. And the fit method is the one where it kind of consumes cross-validation, right? Like the fit method will use cross-validation during its process. It's just not expressly told to you that way, or you're not expressly going to write that in your code. You're not going to call a cross-validation function. You're going to call a fit function, right? So in those terms, you can kind of think of how cross-validation is kind of consumed by a greater fit function. That's how it's being done in most libraries out there, right? Second thing in practice is that of the two resampling approaches, cross-validation or bootstrap, cross-validation is definitely more dominant. Bootstrap is a lot more convenient when you have fewer samples. But you're not always going to have that choice, or that that's not always going to be something that you explicitly choose. In many cases, the fit function will choose for you, based on how big your training data is, or it'll just use cross-validation no matter what. And that brings its own pluses and minuses. But you're not always going to have to choose cross-validation or bootstrap. And like I said, in some cases, you might not even know you're calling it. You're just calling it a fit function, right? So I want you to be aware of that, because this is one of those concepts where you want to learn the concept and kind of what's going on underneath the hood, but you're not explicitly going to be calling this in code or kind of using it on a day-to-day basis, right? As an example, when I'm running one of my team meetings and one of the data scientists that works for me is giving me a report on their model or on their progress, they're not really going to say I'm in the cross-validation phase. They're going to say I'm in the model fit phase, or I'm in the model development phase, right? It's just not something that you would explicitly call out that way. It's already kind of happening in the code and underneath the hood, because it's really just kind of like the only way that the model is going to learn, right? So just kind of want to give you that real world check on it, that in practice, you're not going to be talking about cross-validation on a day-to-day basis, but it is a critical portion for you to understand in data science. Okay, so let's move on to the next slide. I have two slides today that contain the primary takeaways that I want you to remember. And this is the first one. So first of all, realize that this is where the experimentation side of data science begins, right? That process that we just went through, those 3 steps, here's the data, fit it to the model or try it against the model. What did we learn? How did the metrics change? That process, you're going to repeat over and over and over and over again, right? Or resampling is doing that over and over and over again, right? So that's basically the experiments of data science, right? So when I tell you guys, follow the scientific method, choose the experiments, design the experiments, write the code, that's what we're talking about, right? How are you going to fit your data against your model? That's cross-validation. That's resampling, right? So I want you to kind of think about it. This is where it begins. This is where you can say, oh, okay, yeah, I need to run multiple fit cycles, cross-validation cycles, and that's my experiments, right? Here's what I changed in this cycle. Let me mark that down. That was experiment number 1. Okay, let me make these other modifications, or new data came in, or the latest quarterly results came in. Let me run that. Okay, here's what happened then. Let me mark that experiment number 2, right? Oh, okay, yeah. You know what? I switched from my champion model process showed me that I should be trying another model. Let me try another model. Oh, yeah. Here's what happened. Okay, here. Let me write that down. That's experiment number 3, right? And then in turn, that can become, in a different format, that can become what you report to your stakeholders, right? Because they're going to challenge you and they're going to say, well, how do you know that this is going to work? Well, here's my list of experiments. Experiment 1, we tried this. Experiment 2, we tried this. Experiment 3, we tried this. And you would have the metrics for each one, because the metrics is a part of the cross-validation, right? So again, this is where the experimentation portion begins. Second thing to remember, this is also where the computational needs come in of data science. So when you hear about, how much processing power data science takes, whether you should be using CPU or GPU or things along those lines, this is kind of where it starts. Because this is where you see the repetitiveness, right? The constant testing that's happening as you're developing these models. This is kind of like the start of that, right? I mean, obviously that conversation gets a lot more complex, but I do want you to understand that you should be starting to be able to see why people say, like, I'm waiting for a training cycle to finish, and why it can take multiple hours, multiple days, right? Multiple weeks in some cases. But this is where that begins, because you're repeating that same cycle, those same 3 steps over and over again, right? The cross-validation over and over again, right? And then finally, if you read the chapter, or you're going to read the chapter, you're going to see some of the same metrics that we saw before, right? We've been focused a lot on MSE, right? The mean standard error. You're going to see that because it's really what you're doing, right? Like when I say, how did your experiment go? What I'm really asking is, did your MSE improve? Right? And that's what you're going to be asking, right? And you're going to be developing a baseline model and saying, here's where the MSE is if we don't touch anything. And then here's how experiment 1 went. Oh, that's a much better MSE. Here's experiment number 2. Oh, that was terrible. We got terrible results. And how do you know that? Because you can compare it against your baseline MSE, right? Or previous experiments, right? Because you can redefine your baseline, right? As the experiments go on. But it doesn't get more complex than what we've seen already. You're still measuring against the same metrics, right? A metric like MSE is still going to be valid no matter whether you did the computations by hand or you had a whole room full of GPUs. It doesn't matter. Did it improve or not? Right? That's kind of like the bottom line. Did you get better or not? Right? So I'm going to pause there and let you guys take that in a little bit. I'm seeing people still join in on Instagram. Welcome. I love that. But Instagram is not always great for today's session. So if you want to switch over to YouTube, get the widescreen view, you can see all the notes and the code I have up on the screen. But thanks for being here. Let me go ahead and look at the chat. I see a couple of different things I want to address. Alan says, Bootstrap not to be confused with front-end CSS framework. Yeah, thanks for pointing that out. Thanks for pointing that out, Alan. He's right. Bootstrap is a concept in the chapter that we're looking at today, and it also happens to be the name of a front-end GUI HTML framework that's available by, I believe that's put out by Twitter. I think Twitter was the originators of that. And by the way, I love Bootstrap. It's a great framework if you guys haven't looked at it. For data scientists, Bootstrap is a great framework to learn because it's so easy to make something look good. I cannot tell you how many presentations I've done using a Bootstrap front end because I can put it together so quickly. So yeah, thanks for pointing that out, Alan. And as a side note, if you guys want to look at Bootstrap, it's a fun framework to work with. Ravindram, we're going to come back to questions at the end, okay? Okay, but I think I've covered this slide enough. Right? But I hope that you guys are kind of starting to get it here, right? We're just talking about training an algorithm. This is the training part of it. Whenever you hear those terms, resampling, cross-validation, bootstrapping, that's what we're talking about. We're talking about building up an algorithm. All right? Let's go to the next slide here. Oh, where am I? Sorry. So they give you two ways to do this, right? Cross-validation is the first one. And I'm going to put this up on the screen here. And the reason I'm putting this up here is because, well, let me take a step back here. To me, this is one of my favorite questions to ask in an interview. I ask this in just about every interview that I run. So if you want to work for me, I will ask you, what is cross-validation? Can you please tell me what is cross-validation and why does it exist? Now, I think all of you can kind of guess at the model answer because I basically just gave it to you, right? In what we've been talking so far. That's the model answer for me. The reason I'm putting these definitions up there is because I want you to see how similar they are to what we've already been talking. The problem that I've had throughout the years is that when I ask about cross-validation, and by the way, I'm not going to pick on anybody, but I saw this problem in today's chat and also at the meta conversation. The problem with that question is that people inevitably give me the answer for k-folds validation. So I want you to see what the authors wrote here, because it fits the same approach that we used before, right? Because you can see here, divide the available set of observations, the fitted model is used to predict, and the responses for the observations in the validation set, right? So it's basically the same thing, right? Here's the data, try it against the model, what are the metrics? But people usually end up giving me the answer for k-folds cross-validation. So what I want you to understand is that cross-validation, the model answer for cross-validation is that it's the way the model learns. It's the way the model understands and trains itself. K-folds is how it chooses the samples from the data. That's it. That's all. That's all the difference is, but it's a really vital difference. Because like I said, people usually end up giving me the k-folds answer instead of the cross-validation answer. So I want you to understand it's kind of like the umbrella. Well, the bigger umbrella is resampling. The next level down is cross-validation. And then below that, or a component of cross-validation, let's say, is the k-fold side. Because people also kind of forget that there's still also leave one out cross-validation, right? And just nobody really mentions it, right? That is a valid way of doing it, right? So I kind of want you guys to remember this, because this is kind of where you would start to separate yourself from, not just in interviews, but in your own data science practice, right? Because we're not trying to pass interviews here, right? We're trying to be professional data scientists. And I want you to kind of have that separation in your mind, because this is sorely lacking out there. So if you can do this, you will distinguish yourself among your peers, right? So I want you to think about the answers that you guys have given me and realize that it's not about the size of your data set. It's not about overfitting. It's not about all these other things. It's just about training my model and how I'm choosing the items from my training set, right? Like the process, the theory that I'm using for choosing from my data set, right? Because leave one out cross-validation is significantly different than k-folds, but it's still a way to learn, right? You can still learn via leave one out. And again, I also want to point out that this is one of those things that you're really not always explicitly choosing in your code. You're not always saying, well, I want you to do cross-validation and I want you to do it via leave one out, and it has to be via k-fold, right? So this is more about understanding the theory and the process, but in the real world, you're just going to be using like a fit function to help you come up with the model. The libraries kind of compress all of that for you into a fit method, a fit function, right? All right, so back to participation. I have a third bullet on here. And the authors talk about this. Remember in the previous classes, we've talked about qualitative and quantitative problems. Oh man, shoot. I'm sorry, guys. I have an error in here. It's not quantitative, it's qualitative for this question. Sorry about that. So we've talked about quantitative answers and qualitative answers, right? We've talked about how quantitative is when you have like a specific value or specific number you can give, right? Whereas quantitative is more about like categories or, you know, some sort of a classification, right? A lot of you have attended the previous session, so I'm sure most of you understand this, right? So, what about qualitative problems? Those classification problems where we're getting like a classification or a category answer. How do we have to treat those differently during resampling? So have a minute to think about that and let me know in the chat. What about qualitative problems? How are we going to go about those? The authors tell you, but they don't tell you. But, you know, you guys are all smart. You know, I see this chat. You guys are a really smart chat. What are we going to do about those? What are we going to do about qualitative problems? Let me know what you think. I'm going to be reading the chat here, but you guys tell me what's going on. Give you guys a minute to think about that. Again, reminder, if you're on Instagram, love Instagram, but these classes are just better on YouTube or Twitch. Okay, Ravindran is offering up the first answer, and he says confusion matrix. Give me a little bit more information there, Ravindran. What exactly do you mean, please? Sarvesh, welcome. I don't think I've seen you before, Sarvesh. So welcome to the class. We use encoding to convert it into a quantitative problem. Okay, Sarvesh, I think you're on the right track. Take what you just wrote and take it just one step further. Take it one step further. But you guys are welcome to write about qualitative problems. How are we handling those? The authors, I think if I remember right, it's like a little subsection in one of their chapter sections. But what about qualitative problems? Okay, Hamad says agree with Sarvesh. So Hamad, take Sarvesh's answer one step further. What does it mean? What does it mean for everything we just discussed? What does it mean for the next slide that I have on qualitative problems? What are you expecting to find on that slide for qualitative problems? Ravindran says, I didn't get what's the question. Could you explain it, sir? So Ravindran, thank you for the clarification. Good job. A data scientist always asks for clarification. We know that there's quantitative problems when you're trying to do like some sort of like dollar value or something that's measurable, right? A scalar value. And we also know that there's qualitative problems where it's like a class or a category. You know, like when you're trying to do like a yes/no question, right? Those are two different types of problems in data science. What do the authors say about the difference between qualitative and quantitative problems and resampling? That's the question. Anybody else? A little bit less participation on this one. And I'm not surprised by that. Give everybody another 30 seconds or so here. I still see people popping in and out of Instagram. Love seeing you here. Thank you so much. Feel free to switch over to YouTube, and you can see the widescreen format, so you can see the entire class layout and all that. Sultan, question is not fully visible. Yeah, Sultan, I see that you're on Instagram. Feel free to watch us on YouTube. Data Science with Dennis is my channel. I'm live there now also, and it gives you a better view of everything on my screen, okay? So thank you for that feedback. Okay, Rex says, yeah, this question has me scratching my head. Okay, Rex, okay. All right. Okay, so I think I've given enough time. You know, Rex, I'm gonna just assume that you scratching your head is maybe rooted in suspicion, right? Because you guys know I like to give trick questions every once in a while, right? And this is a trick question. The answer is there is no difference, right? There is no difference in qualitative versus quantitative problems when it comes to resampling. Because that theory, right? Remember these 3 steps, right? Here's my data. I'm going to try it against the model. Here's what my metrics say about my latest experiment. That's the same for everything, right? That doesn't change. Those 3 steps are a fundamental building block of data science, right? So it's a trick question. There is no difference for qualitative problems, right? So I want you to remember that what we're talking about is one of the most fundamental, most important things in data science. You should be doing this no matter what. You're going to be doing this really, I mean, for the majority of your career, all of your career, right? There will be no project where you're not using cross-validation, bootstrapping, resampling in general, right? Training cycles, right? This is the work that an algorithm goes through to build itself up, right? The repetitiveness of it, the experimentation side of it, you're always going to be doing it, right? So Rex says, yep. Yeah, Rex has attended enough of my live streams to know that I like to throw trick questions out there for you guys, right? So when I said, what does qualitative what do I say about qualitative problems on the next slide? There is no next slide. I'm not gonna. There is no need for me to highlight qualitative problems because it doesn't change. You're always going to be doing this. There is no different training cycle for qualitative problems. So if we go back to Sarvesh and Hamad's answers about encoding it to convert into a quantitative problem, that's like a step in the process, yes. But there is no difference, right? You're still going to go through that same cycle, right? You're describing the tool to how to get there, and that's great. I commend you for that. It's an important part, and we cover this more in future chapters, right? The encoding side, I mean. But the process itself is still the same, right? Whether you're using a qualitative problem or a quantitative problem, doesn't matter. You're going to go through this over and over again. Okay? I want you guys to remember that. So, going to the next slide. Give me just a second to peek ahead. Yep. So, this is what I would consider a model answer when somebody like me asks you in an interview, what is cross-validation? Right? It's the process the algorithm goes through in order to learn from the training data and create a model that can be used to predict future instances. That's what cross-validation is. Or you could say the same thing for resampling, right? That's what resampling is. There's different ways to pick the data, whether you're using k-folds or leave one out, but this is what cross-validation is. So don't confuse the two, because again, when I ask this, people give me a k-folds definition. But this is what cross-validation is, right? It's data science, right? It's one of the fundamental building blocks of data science. And here's another definition I've also used. It's like when you were in school and the answer's in the back of the math book, right? What do? You go through the problem, you try your best, you apply what your teacher told you, and then you go in the back and say, oh yeah, I got it right, or oh no, it went terrible, here's where I went wrong. Is that not cross-validation? Is that not what we just talked about? Right? The data. You tried your best to solve the data, to solve that problem. How did you do? You go and check the answers in the back of the book and you say, yeah, I did good, right? The process I just followed, the model I just created in my head for that math problem, it worked. I'm going to continue doing that because it worked. Or no, I did terrible. I need to fix my process. I need to adjust something, right? That's cross-validation. That's resampling. That's learning. That's training an algorithm, right? And the reason I give you these two slides is because maybe the first one maybe, but certainly the second one, this is what I use to explain to my stakeholders, right? This is how you should be talking to the business, right? I want to bring this all together back for you guys because again, we're being professional data scientists, right? This is what the type of explanation I want a data scientist who works for me to be giving to the stakeholders, to the business, right? I don't want you talking in math and code to them. I don't want you explaining k-folds to them, right? They don't care how you're selecting the data, how you're generating your samples. Right? To them, you could be using a room full of monkeys to select your samples. They don't care. But this is how you should be explaining it to your stakeholders. Right? Because some of them, you're going to get this question. I've gotten this question hundreds of times in client meetings or with stakeholder meetings. Well, Dennis, when you tell me like it learns, like what are you talking about? Like how does it learn? What are you going to do? Right? Or sometimes, you're going to get clients who are aggressive. How do I know you're training this right? How do I know these crazy math algorithms are going to be correct? Well, because we put it through a process where it comes up with answers and checks itself. We put it through a process, we enable the code to be able to try your data and it'll try one way. And if that way doesn't work, it'll fix itself and start all over again. That's how you want to explain it, right? You just managed to explain cross-validation without looking like a math nerd. So I'm giving you guys stuff like out of my own playbook because this is stuff that I've used with clients. But this is what you want to be explaining as far as what some of these items are, right? Whether it's in interviews or, as you go on to work or things like that. Okay? So Ravindran is putting out a good question on the chat. Is cross-validation used in supervised learning? Anybody want to help Ravindran out? I'll leave that with the chat. You guys can answer that. I'm going to move on in the slides, but if you guys want to think about that and you want to help out your fellow, data science student, Ravindran, I think, is asking a pretty interesting question there. All right, so on the next slide, we're going to talk about Bootstrap. And I got to be honest with you guys, I kind of hesitated to think about whether we needed this section or not, right? For a couple of reasons. One, like I said, you're not always going to be explicitly, you're not going to be explicitly calling resampling per se. You're not always and then when you're not always explicitly going to be saying, well, it has to be cross-validation or it has to be Bootstrap. That's not really a decision you're going to be making on a practical basis, right? The second reason why I hesitated to do this is because the overwhelming amount of projects that you're going to be working on are going to be deep learning projects, right? We are living in a big enough, technology age where basically everything is measured out there and there's plenty of data for just about anything you need, right? I mean, it may not be easy to get, you may not know where to get it, but the data is out there, right? For just about anything you need. Like there's really not as many like small, um, there's not as many instances of projects where you're going to have very few ground truths to work from, right? Like a really small data set, right? So bootstrapping, I think, is still valuable for you to know on a general basis, but we're living in a deep learning era, right? Or I should say in a big data era, right? So yes, I think it's fun for us to go over this, but just keep in mind that, you know, the explicit needs for this is going to be not nearly as big as you think. Okay? And what really drew me to this was this chart, and obviously the charts I'm giving credit to the authors for, but this chart here is straight from the book. And the takeaway that I want you to remember is that the difference in bootstrapping is that you are allowing samples that contain the same instance of the same data, right? So you can notice here in the first example, it uses observation number 3 twice. Down here, it uses it in observation number 2 twice. So, you know, that's not really common, right? There's not a lot of instances where you're going to say, well, I need to repeat my data in that way, right? I mean, where you're going to find this, and the reason why it's called a bootstrap is because maybe there are times when you need to take a smaller data set and build it into a bigger one by using a kind of like a temporary algorithm to help you, right? So for example, we very briefly covered in the past how you can have a set of data that's not labeled, right? So that's an unsupervised problem. If you wanted to, and if the data in the project lends itself to it, you can turn an unsupervised project into a supervised one by labeling your data. That's a valid strategy in some cases, right? So that's an example of where you might use a bootstrap approach, where you can maybe manually label a few records, create a little, like, you know, temporary algorithm, a bootstrap algorithm that's going to take those labels, learn from them, reuse them in a similar way that's up on the screen, and then you're using that algorithm to further train other unlabeled data sets, and so on, right? You kind of like, you take this small data set of 5 samples and you turn it into 20 samples, and you turn it into 60 samples, and then you turn it into 80 samples, and then all of a sudden you might have something you can work with, right? So that's kind of like where that bootstrap approach comes from, where in those early stages you have to reuse data, right? You have to reuse your samples, and that's what's being illustrated in this chart. But again, that's not really going to be a common thing, right? It's not always going to be something that you're going to need, because so many projects that you're going to be working with are going to be big data projects. Okay, so I hope you guys are with me on that. If not, let me know in the chat. All right, let me go back to the chat. Remember, the question in front of the chat right now is coming from Ravindran. Is cross-validation used in supervised learning? So let me know what you think about that, chat. Ravindran says, Ravindran adds, because based on the definition, it compares only in supervised learning, data is labeled, i.e. only correct pairs. Is he right? Let me know, guys. Yassine says, I think it is used only in supervised learning as it requires the existence of labels, outputs, and targets. Okay. Who agrees with Yassine? Let me know. Ravindran says, in simple terms, is bootstrap multiple randomly picked sample space from a single data set? Well, Ravindran, that definition can fit cross-validation also, right? So yes, the randomness is part of it, but it's part for both cross-validation and bootstrap. The difference for bootstrap is that you can reuse samples within the same training set, which typically you wouldn't need to do, right? But that's the bootstrapping aspect of it. Okay. Mahmoud says, I can't watch live now. Will you be posting it later in your account, please? Yes. As soon as the session finishes, it's archived on my YouTube, and then I usually put a notice on Instagram to say when the replay is available. But yes, Mahmoud, yeah, you're welcome to watch it afterwards. Everything is posted there. Thank you for the question. Sarvesh says, wouldn't bootstrapping change the distribution of training data? Yes, absolutely it would, Sarvesh. That's a great observation. And that's one of the I don't want to say dangers, but that is one of the results of Bootstrap. That you are kind of, you're introducing a lot of new risks into your training, right? But again, this is one of those situations where you're only going to do it where you have very, very limited data and there's no hope of getting more data, right? When that happens, that's when you want to say, okay, let's try this bootstrap approach, right? Like you basically just say, I have no choice but to reuse my samples, right? So yeah, it does affect that distribution, right? But what else are you going to do, right? You can use the bootstrap in the manner I just described so that you can get to a point where you don't have to do that anymore. You can turn, I don't know, 20 labeled samples or whatever the case, a small number of of now labeled samples to a point where you can now use something else, right? Like I said, turn an unsupervised problem into a supervised problem and move up from there. But those initial stages are still a bootstrap approach, and that's where the bootstrap term comes from, right? If you guys aren't familiar, well, I don't know this for a fact, but I'm guessing that this whole bootstrapping name comes from software development, because in software development, there's a similar concept of bootstrapping, right? How do you write a new a new software development compiler? Well, you got to use another compiler to help you write the initial parts of the code to bootstrap that the new compiler, the one you want to write, up, and then you can use the new compiler to compile itself, right? It's the same process or the same concept here. Okay. Amrapali says, I think cross-validation is used in unsupervised as well. All right, I appreciate that answer. Who agrees with Amrapali? So we have people who say that it is only for supervised, and people who say it can also be for unsupervised. Joseph says, following Sarvesh's question, is there a way to measure the degree to which the distribution has drifted or changed? Yeah, that's statistics, right? You can do a distribution on your own, right? So in this case, you would do a distribution of your X column, right? Because that's your independent variable. So yeah, you would just chart that out. What is the distribution of X now that you've included observation number 2 twice? Yeah, you can graph that out. It's just a standard distribution in your, that you would do in any statistics package. Or in this case, if we're assuming linear regression, you would just, maybe do like a new scatter plot or something, right? But yeah, you could do that. Ravindran says, is that possible to change the sampling method in Bootstrap? Yeah, but then it's not Bootstrap, right? Then you could be saying you're doing more of a cross-validation approach, right? Because Bootstrap without the ability to repeat samples is cross-validation. Now, if you have a small data set, that's not going to go well, right? In some cases, your data set might be so small that you can't even do an effective randomization because there's not enough there to choose effectively, right? But yeah, you can do it, but then you're not bootstrapping anymore. All right, good questions, guys. Good questions. I think this might be the last slide. Oh, okay. So this is the second takeaway. And this is the last slide before we start looking at some code, right? So this is the second takeaway. Cross-validation, and again, this is me telling you guys as far as like, using the proper definitions and the ways I've seen people maybe not do so great in interviews with me. Cross-validation is how the model learns, right? K-folds is how those samples are chosen and managed. Same thing for leave one out, right? leave one out is a little easier. It's kind of self-explanatory. But I don't want you confusing these two because, again, I've received the definition for k-folds when I ask about cross-validation. All right, so this is the second slide I want you guys to burn into your brain. If you remember nothing else, remember this slide. Because it's a popular interview question, right, to ask about cross-validation. So I'll leave it up on the screen. Aya says, hey Aya, nice to see you. I think you're also one of our Discord members, so welcome, Aya. Feel free to switch over to YouTube, Aya, because that will give you a better view into all the code and stuff. We're about to get into the code, so that might give you a better view than Instagram, but thanks for joining the class. All right, so let me check here, but I'm pretty sure we're going into the coding next. Yep, okay, so we're going into the framework and coding next. So before we leave this deck, right, because we're going to switch over to VS Code, any questions or any other thoughts? But again, we are going over one of the fundamental building blocks of data science. I mean, this is where the rubber hits the road with data science, right? Aka says, can you give the link for YouTube? You know, that's an excellent question. Let me see if I can't bring that up for you, Aka. And for Aya too, because I think Aya wants to switch over. Give me just a second. You know, it's in my Instagram stories if you want to look it up there. But I should have that handy. Yeah, it's right here. There it is. Okay, I'm going to drop it in the Instagram chat, guys. Okay, it's in the Instagram chat. If you guys want to switch over to YouTube. All right, so we're ready to go on to code. Last call for initial questions. You can always ask questions at the end, guys, right? But I don't want to charge forward if there's something out there. All right. So the framework we're going to follow is the same as before. If this is your first time joining, I'm going to go over it, but this is the same framework we've been following, right? My way to pay my respects to the authors and build upon their work, right? Because we're not copying their work. I'm trying to build upon their work. Is to do this via AI, right? So we're going to be level 2 data scientists and thinking about this in how we can go about using AI and not start from a blank screen. Because that's going to be the future of data science and we're preparing now for it, right? So we are going to be code editors, not code writers. We're going to be using ChatGPT. And we're always going to make sure that we have some result that we're optimizing for, right? You can't be a data scientist. You can't measure results unless you have something to measure against, right? So we want to be cognizant of those metrics that we are putting ourselves up against. Okay. So what are we going to do? We're going to use a professional level development environment. We're going to find an appropriate data set. We're going to put cross-validation on a model. We're going to provide all the metrics. And we're going to also make sure that we're presenting the final iteration of the code in a professional manner, right? A data science professional writes programs, not scripts. Python is a very capable language, and we can certainly do that, okay? All right, so let's get started. Again, if you guys need anything, you know, kind of blown up on the screen, let me know. But now is we're going to go to ChatGPT and we're going to be using VS Code. All right. So ChatGPT, let's get started. First, we're going to ask about the frameworks that it knows. So it's using scikit-learn, TensorFlow, and Keras, which is great. It's using XGBoost, or rather it knows about XGBoost, LightGBM, another gradient boosting. PyTorch is for the homeless, so we don't want to use PyTorch. And that's it. It showed us 5 frameworks. Okay. All right. Well, in the previous examples, we've been using scikit-learn, so I think we should proceed with scikit-learn and see what it gives us. All right. It looks like it's going to use the iris dataset, which is a common dataset for data science. What do you guys think? Can you guys see the code? Actually, you know what? Let me bring that code into VS Code. I think it shows up just a little bit bigger on the VS Code side. So we're going to start a new file, and we're going to call this CV. Let's just call it CV version 1 in case we do others. We may or may not do others. All right, so there's the code. What do you guys think? Anybody see anything jumping out at them or anything? Alan Valdez says, "Good job, ChatGPT. Looks like our code work is done." Yeah, maybe. Yeah. Remember, this is the blank screen effect that I have, right? You never want to start with a blank screen anymore. So yeah, it's given us a pretty reasonable code. Now, however, Alan, I think you said this is your first time joining. Remember that in other classes, we have seen ChatGPT make some mistakes, some very basic mistakes in some cases. So again, we're being editors. We can't just take it wholesale. We have to kind of still work it ourselves, right? But, it's always good to just kind of take a step back and just do like a smell test, right? Like this is what in software development you call a smell test. Does that code look good, everybody? Anything jumping out at people? Just give me your observations if there's any out there. There may not be any observations out there. That's okay. But let me know if there's anything jumping out at you. What do you guys think? What are we doing in this code? Think about all the stuff we've covered up to date in this book, right? Even in the other chapters. What are we doing? Alan says, does the variable get called after line 16? That's not a variable, Alan. That's not setting a variable. That's setting the parameter that's needed by cross-val score. So that's not a variable setting. That's setting a parameter. Good question, though. And you know what? In line 16, there's a lot happening in line 16. So if anybody wants to look at that and just give me your assessment. Like, does this pass the smell test? Ravindran says, can we add another model to compare the performance of both models? Yeah, of course, Ravindran. But walk before you run, right? We got to get the initial code base off the ground, right? And then we can make those adjustments. Right now, we're still kind of in a learning phase, right? What you're describing is a little bit more like a champion model process, which is great. I encourage that. You have to do that. But let's flesh this one out a little bit more, right? So look, Ravindran, let's build on your question. What model are we using now? What does the code tell us about that? And, you know, like Alan, what does the CV parameter represent here? Ahmad says, looks good. Okay. Anybody else? Or just give me your observations or anything that pops out at you. I see 1, 2, 3, 4 things that pop out at me in this code. I mean, and generally, I agree with Hamad. The code looks good. I think this is runnable code. I think we can use this as a jumping off point. But you know, we gotta exercise our own abilities, right? We gotta make our own assessment and see if it passes the smell test. What do you guys think? Okay, great. Yassine, wonderful. Great observation. It's using the k-folds cross-validation. Yeah, that's exactly right. So Alan, coming back to your question, that's what the CV value is, right? The CV parameter. Amrapali says CV is the number of cross-validation folds you want. Yeah. Yeah, great. You guys identify that correctly. We're going to be using cross-validation, and it's going to be a k-folds, right? We know we're not going to be using leave one out. All right, so that's great. That's one of the 4 things that jumped out at me. What else, guys? Anything else jump out at anybody? You guys are doing a great job so far. Okay, Yassine says it's a classification problem. Yeah. What kind of classification problem? Okay, Ravindran. Ravindran basically just answered my question. We are using logistic regression, which does binary tasks. That is yes or no. That's right. That's right. So it's a classification problem, you know, between 2 classes essentially, right? So Yassine and Ravindran, you know, are both correct in that. And we're using logistic regression, right? So yeah, you guys did great on that. So the other thing that caught my eye is that we're using the iris dataset. I think most of you are going to be aware of this, but for those of you that are not, the iris dataset is a classic dataset in data science. Every student on the planet has used the iris dataset. And it's one of the datasets that's natively available within scikit-learn, so you can use it too. The authors also use the iris dataset in some of the examples in the ISL book. So you're going to come across that when you see mentions of iris. But iris is a classic dataset, so I'm glad to see that we're being exposed to it today. We're also the other thing that caught my eye is we're setting our X and Y, right? So we know that from our previous classes that X is going to be our independent variable and Y is going to be our dependent variable, so also known as our target variable. So you see the target being noted there. And yeah, and then the last thing that caught my eye was down here, right? This is where the rubber hits the road, right? The cross-validation score is where the actual execution takes place, right? That cycle, that 3-step cycle we talked about, here's the data, put it against the model. How did we do? That's where that's happening, all in line 16, right? So line 16, like, is the thing, right? And also where the heavy lifting is. So when we talked about like those CPU cycles, the computationally intensive side of data science, that's where it's happening, okay? Okay, so Ravindran says it gives calculations of recurrent events based on the input. Yeah, it's going to give us the metrics, sure. Yassine says, however, maybe ChatGPT has made a mistake because the iris dataset is more than 2 classes of my knowledge. Yes, you're right about that, Yassine. There are multiple classifications, but it all just depends on how you structure the data, right? But yes, we could be doing this for a multi-class, but let's keep it logistic regression for now, okay? But yes, I fundamentally agree with you. Ahmad says, we loaded the data set of sklearn, which divided into x and y, dependent the model, we will use logistic regression. Yeah, Ahmad, that's a pretty good summary. Yeah, so I think that, so the bottom line is I think this is perfectly reasonable code, right? I expect that it will run. Nothing jumps out at me as being wrong. VS Code is not telling us we have any, anything that's blatantly wrong. So let's run it. All right, CV V1 PY is what we call this. So now we go back. Okay, and just in case you guys missed it, right? We're not using notebooks, right? We're using an IDE tied to our terminal. Again, if you need the code bigger or the terminal bigger, let me know. But we're gonna make sure our file is there. We're in the right directory. I think we are. Yep, there's our file. So now it's gonna be Python. py. Let's see what it says. So these are the scores it's giving us. It doesn't explain exactly what scores they are. I'm going to assume that these are accuracy scores. What do you guys think? Is that an effective output? Remember, this is the metric that we're measuring, right? Is this a good way to look at it? I think we've seen other ways that might be a little better, yeah? But let's modify this code. I think we need better metrics. Let's go back to our ChatGPT employee. Wow, that really expanded the code, eh? And it's going to give us a aggregate confusion matrix. Let's go ahead and create a new file. All right. So generally speaking, the top part is the same, right? It's going to use a different approach to k-folds. And then it's going to go ahead and do different splits of training and testing. It's going to create the confusion matrix down here. It's going to maintain a list of confusion matrices down here. And then it's going to show us the individual results, but then also show us an aggregate of the confusion matrices. So it's reasonable code, but a little bit messy, I think. But let's see how it runs. I think there's better ways for us to kind of optimize this code. But we're not going to be too strict about that because ultimately we still would just kind of want to learn from this code, right? So let's see what this gives us. Oh, did I know? Oh, I didn't save it, excuse me. Okay. What do you guys think? We saw some mentions of confusion matrix previously, right? A couple of you mentioned confusion matrix, right? Amrampali, did you say no? No, it's unclear. Did you mean to say unclear or clear? Help me understand, Amrampali. Hamad says standard deviation is high. Maybe model is overfitting. Maybe. We would find that out in future iterations, right? Or as Ravindran pointed out, we could also try different models, right? Alan says one is the mean, the other is the standard deviation. Yeah, I think you're right for the bottom result on it, Alan. I think you're right about that. Ah, okay. Alan says, what are confusion matrices for? That's a good question. Anybody want to help Alan out there? Okay, so Amrampali says, sorry, I meant previous code was unclear for evaluation. I agree, Amrampali. I think there was a lot of improvements that could be made there to those metrics. And I think confusion matrices kind of get that, right? Or get us closer to that, right? But yeah, I agree. It probably wasn't the best for what we need. Hamad says, not clear because of the chat. Okay, Hamad. Yeah, you're right about that. Let me see what I can do about that. It's to the side, isn't it? So maybe if I move this. Oh, let me put that down. Does that help, Hamad? If I move this to the side, away from the chat, I think that should make it easier to read. Let me know if that's a little better, guys. So Ravindran is trying to answer Alan's question. Alan asked about confusion matrices. Ravindran said it's mainly used for evaluating classification models. Okay. So Ravindran, take it a step further. What do you think about this matrix? Because we're looking at this bottom matrix here, right? And you know what? I think ChatGPT can improve on this, guys. So let me go back real quick. I think we can get it a little bit better. I only want to show the aggregate matrix. And I want to show labels, right? Let's see how ChatGPT does on that. So using the same approach, it's using the aggregate and then aggregate confusion matrix. Okay, this looks reasonable. Let's use this latest version. We're going to call this version 3. Let's go and try and run that. And I'm going to clear my screen right now to help you guys a little. Okay, there we go. Now what do you guys think? And by the way, I think it was Yassine that mentioned this. Yassine, you're right. Here, it's going to go ahead and show us the different classes that are available in the iris dataset. Right? It's showing us the 3 classes in this confusion matrices. In this confusion matrix. Explore the beauty of nature, trying to answer Alan's question, says confusion matrix are evaluation metrics to compare true positives, true negatives, false positives, and false negatives in classification tests. Nice. I'm on board with that description. Amrampali says confusion matrices will help us understand true positives, true negatives, false positive, negative by comparing the predicted labels with the actual labels. Nice. Very, very well said. Aditya and excuse me, I am annoying. Love seeing you on Instagram, but maybe if you want to switch over to YouTube, it's a little easier to see there, okay? All right, so what do you guys think about this confusion matrix here? What is it telling us? Did we do good? I think I can make that just a little bit bigger. Is that getting any bigger? Yeah, that's a lot bigger. What do you guys think? This is the answer we got for the aggregate confusion matrix. In this matrix, which true positive and true negative and other, it's confusing? Okay. No idea. How can I interpret that? Okay. Thanks for your honesty, Alan. You know, it's not always easy to admit when you don't know something, but that's a very valuable skill for data scientists, right? Data scientists should know when they can speak from knowledge and when they can't. So kudos to you for stepping up and saying, hey, I don't get this. Yassine says it looks okay for this specific problem. Okay. Why, Yassine? Why does it look okay? Like, what's your rationale for saying that? Because some people in the chat are saying, hey, I don't know, right? So help us understand your rationale. There's no wrong answer here, guys. I just want to see the rationale, and I'll walk you through it, right? We're gonna all learn this. I'll give you just a chance here to look at it. What do you guys think? Wow, guys, we are approaching 2 hours. Good for all of you guys for hanging in there. I just looked at the clock, and we're at an hour 45 right now. Wow, you guys are amazing. All right, so I love the fact that we can go over confusion matrices right now, and we're using this to evaluate our model. But by the way, understanding a confusion matrix, invaluable skill, right? And that's actually a question I ask. I ask, what is a confusion matrix and what does it tell you? That's one of my interview questions. So it's good that we're able to go over this right now. And what we're about to cover, I'm going to walk you through this. Keep in mind, you're going to be doing this throughout your career, right? Because this is basically like you using your mind to analyze and say, oh, okay, yeah, I'm on the right track, or no, geez, that was terrible. What am I doing, right? Okay. So Yassine says, because it only has made 4 guesses wrong out of 150 in a specific problem, I think we can afford this amount of mistakes. Okay. Okay, Yassine. So Yassine is saying that we've only made 4 mistakes out of 150. Some of you may be wondering how he came up with that. And he's right. You know, his read on that is correct. So let's go over that. So the first thing you should know is that the iris dataset is about that. It's about irises. It's about flowers. And within those flowers, within irises, there's different types of flowers, different types of irises. There's setosa, versicolor, and virginica, I guess it's pronounced. So you can have 3 classes of irises, right? So this algorithm that ChatGPT wrote for us is trying to establish taking data like the petal length and the color and the size of the flower and guessing which of the 3 categories it fits into, right? So that's what's represented in the columns and rows. Setosa, versicolor, Rahinica, those are all of the possible categories that we have trained the algorithm to learn. So you'll notice that it's the same values on the rows and on the columns. The rows usually represent your ground truth of what the model actually says they are, versus what the columns represent your predictions or what the algorithm said they are. Right? So here you can say that for Setosas, the data set contained 50 instances of Setosa, and your algorithm correctly classified 50 of them as being Setosa. It didn't choose any of the other ones. So in other words, we were perfect for Setosa. Our algorithm did not make any mistakes in identifying the Setosa category of irises. Okay, so now we go to the next line down. Now we're saying for versicolor, it put 47 as versicolor, but in 3 of the instances, it should have been versicolor, but it chose them as Rahinica. So that is how many errors? That's 3, right? 3 errors. Because it should have been under versicolor, but it put him under Rahinica. Of the Rahinicas that are in our training set, right? Or in our train test set, it correctly identified 49 of them as being Rahinica. But 1 was classified as versicolor, which is incorrect. So the 3 plus 4 is the errors, right? That's how many errors the algorithm made. And the 150 that Yassine mentioned earlier is because we know we had 50 Setosa, 50 versicolor, 50 Rahinica, total processing, total predictions or categorization tasks of 150 times. And in those 150 times, 4 were errors. So that gives you an accuracy, right? That's the whole point of that. But as you can clearly see, though, the accuracy rate differs according to the category, right? Each category can have its own error rate or accuracy rates, right? For Setosa, we're perfect, right? The algorithm didn't make any mistakes. For versicolor, we made 3, which is what? 6%, right? 6%-ish rate. And down here in Rahinica, it made 1 error, which is like a 2% rate, right? So that's why these matrices are so important, because now you're going to make some changes, and then you're going to see what the next matrix is, and the matrix after that, and matrix after that, and you can kind of get a sense for where you're going with your errors, right? So Ravindran says, yeah, Ravindran, you got it right. Yeah. Setosa is correctly predicted. Versicolor is predicted 47 times, and Rahinica is 49 times. Yeah. Amrapali says, yes, on board with Yassine. Yeah. Yeah, I think Yassine gave a pretty reasonable answer, right? So again, I don't like calling on anybody. I don't want anybody to feel uncomfortable, but let me know. Are you guys a little bit more clarified in confusion matrices? Give me some feedback here, guys. That process that we just went through of interpreting the confusion matrix is exactly something you're going to do over and over again in your life, in your practice of data science, okay? Alan says, can you tell us what you asked ChatGPT to do in order to get this single matrix? Yeah, sure, Alan. I'll go back to that screen. Here. Is that clear for you guys? Or maybe need a little bit bigger? I think, let me bring up like a text editor or something where I can show it a little bigger. I love the question, Alan, so I want to make sure I invest time in answering your question. Here was the revised prompt, Alan. I think you guys should be able to see that pretty good. So a couple of key things in this prompt from my experience of using ChatGPT. ChatGPT is not good about keeping the current state of the code you're working on and modifying changes. So I've had instances where unless I tell it to keep that code and be very specific about the changes, it'll write a whole other code, right? Like it'll turn logistic regression into regression instead, or just make these huge changes where you really just want a small change. So in this prompt, you have to be very specific about what you're asking it to change, right? You have to be very specific and say, this is what I want you to change, but keep the same code. Or in some cases, you'll see me say, I like this code, label this cross-validation version 1. Like you kind of bookmark it in the ChatGPT history, right? In the ChatGPT context. So this is what I used, Alan. And again, here I'm being explicit about saying only label or only change certain things. Because otherwise it'll make changes to the other parts of the code and then you know, kind of stinks, right? But that's what I use. Great question, Alan. What made you choose just the aggregate confusion matrix? Because it's helpful to see the folds along the way to kind of see how the algorithm is learning, but we just care about the bottom line, right? We're not going to deploy the folding instances of the algorithm. We're going to deploy the final model, right? So that's why I asked it to only show the aggregate one. It clears up the screen a little bit. And like I said, the other ones really aren't as relevant as they could be, right? Because that's not what we're going to deploy. That's not what the final model looks like, right? So that's why I did that, Alan. But let me go back to the terminal. But yeah, but look, I mean, let's take this another step further, right? How do we interpret this to the business? Right? We can say that we're pretty accurate, right? We're accurate overall. There are still some errors, but overall we have pretty good accuracy rate. In some classifications, we're going to be pretty good. In others, we might need a little room for improvement. But you present the business with what these numbers are, right? We're really good at Setosa. We're almost perfect on Britannica, and Versicolor might need some work. And that's it. That's all you present to them. You present them with the options, right? To say, hey, this is what the model will result. This is what it will do. And then the business can decide on, you know, mostly it will just involve the dollar values that are associated with each of those decisions, each of those errors in some cases, right? And then they'll tell you, yeah, that model looks good. You know, we can live with those results, or no, you need to modify a little bit. But the point I'm trying to make upon you guys is that's not your decision to make, right? You're a data science team, not a business team. So you're going to have to, you know, take something like a confusion matrix, write up a report on it, and translate that report into options, and then let the business make those decisions on those options, because that's ultimately, you know, kind of what they do or what they're best at, right? But I hope that made sense as far as the confusion matrix. But this is really kind of, you know, what you'll be doing as far as saying, yeah, this model's great, or no, this is terrible. Sarvesh says we can use Claude 3.5 Sonnet's artifact feature for coding. Yeah, sure. But I mean, basically all LLMs can do coding. It's just how much you're going to pay for it, right? On ChatGPT, I do have a paid membership. So, you know, I'm doing that because presumably when you would be doing this for a client, it would also be under a paid membership. But yeah, you can use Claude, you can use ChatGPT. I don't like how Claude limits the hours. You know, they do limit how much you can use it, and I'm not on board with that. So I much rather pay for ChatGPT. I like their tools. But yeah, there's a lot of tools you can do this. Ravindran says, shall we increase the number of folds to increase its accuracy? Maybe. Do we need to increase the accuracy, Ravindran? Yassine said it actually looks okay, right? We only made 4 errors. You got to know when to stop, right? I mean, you can't just, refine models forever, right? Businesses will give you a deadline. I think, I think the model, depending on the applications, right? This is going to be a useful model for a lot of applications, a lot of business use cases. So do we need to go further? Alan says, can we benefit at all from visualizing the final result? Sure. Yeah. People visualize the confusion matrices, but keep in mind that you do not want to show that to your stakeholders, right? Even this level of math is too much, right? One of the teams I've led, when I was first assigned to lead them, I walked into one of their meetings, like it was like my second day, and they were showing confusion matrices to the business, and I just about died. I was like, oh, just choking, like, what are you guys doing? Don't do that. So yes, you can visualize them. It's very helpful to look at the proportions, right? There's some proportions here that we could be changing, right? But leave it in the team room. Leave it in the data science team room, okay? You should be taking that, creating your own results, writing those results in business language, and then that's what you present, okay? But great question, Alan. Ahmad said ChatGPT uses 4% mini model after research. Yes, it does, Hamad, but only for like an hour, I think. They throttle it. They throttle you to like I think it was either an hour or 10 queries or something like that. They don't let you just sit there and go forever. It's very highly throttled for 4.0. They'll switch you to 3.5, I think, and that is free. And that coding engine in there is good enough. But 4.0, you can only use it for a limited time. 4.0 mini, you also mentioned. 4.0 mini is a little better in code, but it still makes mistakes, so be careful with that. Rex is asking an excellent question. How much of a code writer do you need to be in order to become a code editor? Yeah, Rex, really good question. And that is a little bit of a challenge, right? Because you do have to have some base level of knowledge to be able to say, oh, wait a minute, that code doesn't look right, or whatnot. Rex, a lot of this might just, I'm assuming somebody has, very limited coding background. In that scenario, it's going to be a lot of experimentation on your part, right? A little bit of trying different instances of code that ChatGPT gives you, running it, and then fixing the errors, right? Because Python will tell you when there's errors, right? And again, we saw that in the first class. In fact, Rex, I think you were there, right? Where they will make mistakes, right? And then the Python interpreter will tell you where the mistake is, and then you have to go and research that mistake on your own, right? So I think it's just going to be that process of, okay, well, that looks good, but let me run it. Oh, okay, here's the error. Let me go look at that mistake. Let me go look that up. In some cases, as you develop that skill more, you'll be able to see the errors on the screen within the chat window, and that's happened to me, where I'll do that and I can say, are you sure that this line looks right? I think you made a mistake there, and ChatGPT will correct itself. Doesn't always correct itself in the best way, right? Sometimes I found that the corrections themselves have errors, right? But yeah, I mean, you're just going to have to sit there and kind of develop an eye for it, develop the skill for it. In other cases, you might just want to do projects on your own too, Rex, right? Not everything has to start with ChatGPT. I recommend that because that's what the future is going to be. But if you're still saying, hey, I'm at a base level of development, then go ahead and start writing your own code from scratch. And that in itself will also help you develop that eye, right? That ability to read other people's code, ChatGPT's code, and be able to detect when things are wrong. Okay, so I hope that helps you. Explore the Beauty of Nature says, this is a good question. This may not be directly related to our current study. When presenting your results, should you include a detailed research publication style workflow? This would involve extensive literature, etc. I'm going to assume that you mean to the business, right? Or who are you saying when you're going to publish it? Or presenting your results. Who do you have in mind when you say presenting your results? Because I'm assuming you mean like your business stakeholders. So explore the beauty. Let me know what is the audience you have in mind? Because it can be audience dependent, the answer to your question. Let me know what audience you have in mind when you say that, okay? No, after the update, they let us use Foro mini model for free. Are you sure that's not throttled, Hamad? I mean, you may very well be right, but my understanding is that that's still throttled. Like there's still a time limit on there, okay? If you understand the code, you are good to be an editor. Maybe. It makes you faster if you know code already, right? But yeah, I agree with that. Hamad says, explore the beauty, does not agree with you, stakeholder, wants results that will not literature review, present your findings as PT. Hamad, you're partially correct, and that's why I asked explore the beauty to clarify, because he could be talking about other audiences where you would want to do a broader review, right? So it depends. It depends on the audience, right? Remember, as data scientists, we gotta clarify, right? In fact, Hamad, I think we had this discussion in Discord, right? You guys hear me use the term validate your assumptions, right? So that was me validating my assumptions. In some cases, Hamad is correct, but I think it depends on the audience. So let's see. So explore the beauty is going to clarify. Yes to the business stakeholders. So yeah, to the business stakeholders, you want to basically you want to limit the math, data science, the code, all that. So you just want to kind of give them the bottom line. Here's what we're good at. Here's what we're not good at with the algorithm that we made, right? If they ask further than that, you can tell them how many experiments you ran, what the results of those individual experiments was. In other words, how you got to the answer, not necessarily the technicals of the answer, right? Like the rationale more than anything else, right? The times when you do want to show a little bit more of that literature or a little bit more of that workflow might be like a model review team, right? So remember, guys, I make the assumption that the majority of us are going to end up working in large corporate environments, right? Most data scientists are employed in some sort of corporate enterprise environment, right? I mean, yes, there's government applications and research labs, but the majority of us are going to go work for like some, big corporate entity, right? And in those entities, you're going to have model review teams, right? Where they're going to review your algorithm and your process. So for those audiences, explore the beauty, you would want to do a little bit more of a just slightly more academic presentation, right? Of, the literature, the supporting documents, the supporting API documentation, how you derive your champion model process. That you're going to want to have more, right? But for the business stakeholder side, it's more about the results, right? Here's the number of experiments we ran. Here's what we think it's going to do for your business. Here are the different errors we could be making. What would you like for us to do? How would you like for us to proceed? That's really all they need. Because again, you could have done those experiments with monkeys. They don't care. They just care that you have a solution for them, right? So I hope that helped. I created a whole new website from scratch with ChatGPT. Good for you, Ravindran. ChatGPT is just an amazing product. Rex says, this reminds me of the conversation we had about developing business acumen. Yes, absolutely. Absolutely, it's related to that. Business acumen so we can communicate better with stakeholders. Yeah, Rex, that's exactly right. And Rex is referring to conversations that we are having in the Discord. Let me bring that up. So this is our Discord channel for today, for Data Science with Dennis. We have 67 members in the Discord. So feel free to join us. And Rex is right. We are having various conversations. We're having memes. I think Hamad included a meme yesterday, which is hilarious. So yeah, we are definitely having those different conversations. And you are right. You are correct, Rex. It is similar to that business acumen that we talked about. What was the screen I had up before? Yeah, I think I had that up before. But you are welcome to join us in the Discord for that. It pays to take extra business courses, extra communication courses in your studies, right? Because you are going to have to present those results, and being able to talk to the business is what separates you from other data scientists, other people on your teams. You know, we've had questions about leadership. I think that good communication is what moves you up into leadership, right? If you're able to talk to the business and talk to them in plain language, well, guess what? When they have project ideas or they have needs in the future, you're going to be the one they come to first, because you're the one who speaks English on the team, right? You're not the tech speak guy. Now you're talking to them in a way that they understand. So in turn, they're going to come to you in the future, right? So lots of value in being able to understand the business side and be able to talk with them, right? You know, as an illustration, I can think of a time, well, there's been many times in my career where somebody approaches me and says, I like coming to you because you talk to me in plain words. But I'm thinking about an instance, shoot, I just realized I can't tell you about the exact example, but I was working for a client, a large company, and it was a case where somebody approached me and said, I was leading one of their data science teams, and they approached me and said, hey, I think we have a customer service issue with topic X. I can't say what topic X is. We have a customer service issue with topic X. Is there anything you can do to help us? And we were able to create an algorithm for them that helped them identify different instances where event X could happen. And we were able to analyze, you know, how many times it had happened versus times where it could have happened but didn't happen, so on and so forth. And then we gave them those results, and those results ended up being worked out into a significant policy change within the company, right? Or an examination of those policies. But those are the times, you know, you're going to have those times in your career where people are going to feel comfortable approaching you. And then in turn, you're going to develop this great project that you already know the business needs, because they just spoke to you and say, hey, I think we have a problem here. Can you help us? Because, you know, you're our main guy. You're the guy we talk to. You're the guy that we know communicates well. So we're going to come to you first, right? They don't go and talk to the math nerds first, right? Because they don't understand those guys, right? So I think, Rex, you're definitely hitting upon an important part of it, where having that business knowledge is going to help you guys in your career. So thanks for bringing that up, Rex. Hamad says, ChatGPT can do wonders if you know how to use it. Yeah, absolutely, Hamad. That's very true. Joseph says, thanks for explaining how we effectively communicate to stakeholders. Yeah, I think it's an important part, guys. It's an important part of, you know, not just data science, but your overall career development. So definitely encourage you guys to look into books on emotional intelligence, or maybe if you're still in college, you would take courses on like interpersonal communication. I took a course in interpersonal communication in college that I really enjoyed. But you want to look at those types of things. Rex, thank you so much. Rex is providing the link to the Discord there. So if anybody wants to go to the Discord, again, we're having some great conversations, great knowledge being spread there. And it's a good way for you guys to kind of keep in touch after this is all done. All right. Okay, guys. Well, I'm glad we had that discussion on the confusion matrices. I think that's super valuable. So, where can you guys go with this? I want to leave you guys with some self-study, right? What about leave one out cross-validation? Excuse me. We haven't gone over that. Can you write code for leave one out? Or, excuse me, let me say that another way. Can you get ChatGPT to write code for leave one out? I bet it could. Okay, so you do that. What does that confusion matrix look like? Do you think it would be better or worse than the confusion matrix that we saw from, you know, the K-folds validation? It's kind of hard to beat our error rate, right? We got four wrong out of 150, right? So on probability alone, you would say, no, it's not going to be better, right? But maybe it can. There's advantages and disadvantages to leave one out. So I'm going to challenge you guys to go out and do that. Work with ChatGPT in the same manner we've done today. We only gave it a handful of prompts today, guys, right? We only used like, what, not even 10 prompts today. So build on that and go do leave one out. What does that look like, right? Okay, guys, but I think I covered everything I wanted to do with the today's lesson. Thank you so much. A lot of really good feedback. I really enjoyed this. I'm willing to do questions now if you guys have questions, whether it relates to this study or not, because I know I might have skipped some in the chat, but maybe some of those people are still in the chat or maybe they're not. But I know we're already past 2 hours. So thank you all for hanging in there with me. A couple of you have been here the whole session, which is amazing. Kudos to you guys. So I'm open for questions. Again, if you posted something before, go ahead and repost it in the chat so that I can see it again. But questions on the lesson, questions on anything else, this is the time for it. But I think this is such a pivotal chapter. I hope that you guys are starting to see, you know, those building blocks, those fundamentals of data science. Like you're always going to be doing this, right? You're always going to be, where's my data? Try it against my model. What did it tell me? That is data science. In fact, that's what we're supposed to be doing. So give you guys a minute here for questions. Okay, explore the beauty. Oh, you know what? Let me go to a bigger view. So explore the beauty says, could you please recommend some books on business problems solving for programmers? You know, explore the beauty, I don't think there's a lot of good ones for them. That's one of the reasons I wrote my book, Your First Year in Data Science, to kind of help you start to make that transition into a team. Because look, another part of business, of moving into the business, and I'm telling you guys, you're going to be employed by corporate entities, is how do you work within the data science team? Most study is just done on your own, but now you're going to be a bigger part of a team, right? So I cover that in my book. I try to kind of address that, you know, your first year in data science. So you're going to find some help there, explore the beauty. But as far as business problems for programmers or like use cases, I can't recommend one because I've never needed one. But I really don't know if there's a good one out there. I'm guessing there is, but I can't recommend one because I can't speak intelligently on it. So I don't want to give you bad advice. So sorry. But it's good that you're at least thinking about it, though. But, you know, work on the communication side, right? There's plenty of communication books out there, okay? Ahmad says, thank you very much and learned a lot. Thank you, Ahmad. I appreciate you being here. And appreciate your support of the Discord also. I know you're in Discord quite a bit. Mohammed Mesalmani says, do you think Masters in University of Texas at Austin, the online program Data Science, is worth investing in? I don't know that program in particular, Mohammed. So I really can't comment. I mean, I've been to that university. I've been part of the career fairs of that university, so I know it's a very good university. But I can't comment on their particular program. Sorry. You know, I don't like to speak on things I don't know about. So I wish I knew more about individual programs, but I do not. So, yeah, I mean, I couldn't advise you. Alan says, I'm actually confused about what we would gain from using leave one out, and furthermore, why should we accept the k-fold validation as our final answer? Well, I think you're hitting on a very important point there with leave one out. What are we doing when we try leave one out? Like on a meta level, right? What are we doing there? And that's open to anybody in the chat, right? What are we doing when we're going to say, let me go to leave one out? I'll give you guys a hint. It begins with the letter E. What do you guys think? What are we doing there? Give you guys another second to think about it. There we go. That's right, Alan. It's an experiment. You're suggesting another experiment, and that's a good thing. You want to experiment, right? That's a positive thing of data science, right? So yeah, we're experimenting. You should always be looking to experiment, right? Now, having said that, when you say, what would we gain from using leave one out, maybe you wouldn't. And that's going to be driven by any number of factors that are not always under your control. Maybe there's a business deadline. Maybe there's a lack of GPU resources. Maybe the business says, yeah, that's good enough. Or think about the opposite of that, right? As Yassine correctly pointed out, we had 4 errors out of 150 instances. Is that a good error rate for loan decisions? Yeah. Is that a good error rate for a self-driving car deciding when to press the brakes or not? Maybe not so much, right? So it just depends. Maybe it's a good error rate, maybe it's not. Right? We went through that in that same exercise in a previous class, right? Where we saw a confusion matrix and everybody agreed that it was good for loans, but because it had a 85% accuracy, I think is what it was. But then we reframed the problem into, what if this was a self-driving car and decisions for a self-driving car? Do you want a self-driving car to fail 15% of the time? Probably not. So it depends, Alan. There is no individual answer, right? Every data problem is different. Every model is different. Every experiment is different. So yeah, sometimes it makes sense to continue. Other times it won't. Other times you will be told to stop. Other times you will be told to continue, right? The business will tell you to continue. So it just depends. Just depends, okay? Joseph says, thanks for clearly defining k-fold and cross-validation is really helpful. Yeah, you're welcome. And I'm glad you say that, because I think there is a lot of confusion out there between them, right? Cross-validation is learning. K-folds is just how you're selecting a different way to select the samples, right? But 85% of the time when I've asked that question, what is cross-validation? The applicant, the person I'm interviewing, tells me the definition for k-folds. Right? So please don't make that mistake. If you don't make that mistake, you'll be standing out among candidates, I guarantee you. Any advice to switch to big tech like Meta and Google? No advice in particular, right? I mean, to me, it doesn't make sense to limit your company choices like that, There are, believe it or not, guys, there are more companies on the planet than Meta and Google. I promise you, there are more companies than 2, okay? Yassine says, can you please provide a general idea about the technologies we might need to do data science professional environment and deploy models correctly? Thank you for your efforts. Yeah. Your first year in data science, that's basically what I talk about, right? What is that shift that you need to make from school to a professional environment, right? Academic programs don't teach you how to go after your own data. They don't teach you how to talk to stakeholders. They don't teach you how to deploy an algorithm and how to maintain it, right? Academic programs are terrible at all of those, right? So that's what I recommend. And really, it's not, looking at your question, it's really not about the individual technologies, Yassine, because a lot of those technology stacks will be decided for you based on where you work, right? Like, they're not going to change your technology stack just because you're coming in and don't know it. You're going to have to adjust to them, right? So that's what I would advise you to think about, You have to be flexible to where you're going to end up and what stacks that they end up working with, right? All right, last call for questions, guys. We're hitting on 2 hours, 20 minutes. Good job, guys. Anybody else? Last call for questions, or you can also catch me in the Discord. I believe Rex just also posted that Discord link as a reminder, so thank you for that, Rex. Yeah, and by the way, guys, shout out to Joseph and Rex for helping me with the mod. Make sure you thank them next time you see them. They're doing a really good job with that. Yassine says thank you. Yeah, I hope it helped, Yassine. All right, guys. So I think this is a good time to wrap it up. I really appreciate all of you being here. Come back next week, chapter 6. I got to be honest, I don't even know what chapter 6 is. I only look ahead a couple days ahead of time. But yeah, whatever chapter 6 is, we're going to be covering it next week. So look forward to seeing you there. I also stream every day at 1500 GMT, so come join for that. Yesterday we had a great session. We had a little game show, just to have a little break in the content and all that. But tomorrow we're back at it. Oh, and by the way, tomorrow I am releasing a video for the first time where I talk about how I made the mid-career transition from software development into data science. People have asked me that question. I've never done a full video on it. I've shared little bits and pieces, but this is the first time I'm sharing the full video. So that's being released tomorrow. Look for that on my YouTube channel, Data Science with Dennis. But thank you so much. Appreciate the questions, appreciate the participation. Take care of yourselves, take care of your families, and I'll see you next time. Hey everybody, good morning. How are you? It's Sunday, and Sunday means that we are continuing our class on the Introduction to Statistical Learning. So it's really good to have all of you here, really good to see all of you. I already see some people on YouTube. I already see some people on Instagram. So by the way, if you're on Instagram, love having you there. I love my Instagram audience, but for Sundays, it's usually a little better to watch on YouTube because YouTube gives you a widescreen format for all of the code and the notes and stuff that we're going to go over. So if you want to stay on Instagram, great, but consider switching over to YouTube if it's a little bit easier for you to watch. I put up a lot of stuff on the screen, a lot of things to cover today, a lot of good stuff to cover today. So really good to see all of you. Just in case you're not already aware, this is the book that I'm referring to, Introduction to Statistical Learning. I know that many of you are already familiar with the book. Again, this is where I think professional data science really begins. It's a book that's very popular in academic courses, but just a really quality book. So today we are going to be covering chapter 6. Believe it or not, there's only 10 chapters in the whole book, so we're already on chapter 6. So we should all be proud that we're making really good progress. We haven't missed a Sunday yet. Today is our 4th Sunday in a row. We just got a couple more to go. So, really proud of everybody that's been attending and, kind of staying for the whole time because we do tend to run a little long. So we should all kind of pat ourselves on the back for being able to get this far and being able to kind of keep up with the materials because it's not an easy book. But I think that I'm presenting it in an accessible way. And most importantly, I'm also going through and I'm picking out the portions that I think are more relevant or more the sections that I've seen used in the real world. So I'm not giving you things that I think are important. I'm giving you things that I know are important because I've been there, I've used them, I've had my staff use them or whatever the case may be. So that's really kind of what we're focusing on getting through here. So on top of that, we're also doing all of our code with AI. So that way all of us can kind of practice our prompts and practice what it's going to be a data scientist in the future. Because I really believe that all of us will be data scientists that are heavily aided by AI. So we should start practicing now for our prompts and how we put that code together. That's really kind of the goal here. Because, I really have a lot of respect for the authors of the book. So I want to make sure that I'm building upon their work. And I think that doing it via AI is one of the best ways to do that. So lots of things to cover today. And as all of you who have attended know, I do love to throw out questions to all of you and talk about these different things. So lots of that today. I'm going to be asking for a lot of opinions and a lot of your views today. So really looking forward to hearing, kind of where you guys are in some of these things. And as always, feel free to stop me if you have questions or, something doesn't make sense or whatever. You guys have been great about that. I'm really loving the interaction. So, we're just gonna keep that going today. All right. So I'm seeing some people already introducing themselves on YouTube, which is fantastic. So let me start going there. Abe, for some reason I don't see you on the screen, Abe, but I do see you in my chat, so I can go ahead and still highlight your chat. Abe was first today. So hello, Dennis. Happy Sunday. Hope you're doing well from Hyderabad, India, and also on time today. Well, it's very important to be on time on Sundays. But like I said, we do run long. So if you guys have to step away or you want to come during the later hours, we know we do tend to run long. So yeah, glad you're here, Abe. I'm doing well, thank you. I slept really well last night. Got some interesting things coming up this week. So yeah, it's a good day. It's a good day. Joseph, our good friend Joseph. Good morning, Dennis. Happy Sunday. Looking forward to today's class. Thank you, Joseph. I'm looking forward to it too. It should be fun. Today we're going to be talking about. Well, the title is Ridge Regression. And it's one of those topics that is really pivotal to understanding like the whole science part of data science. Last week we looked at cross-validation or, resampling methods. And to me, that was really pivotal in my learning. And today we're going to build on another topic that's also pivotal to learning. So glad to see that you're joining us again today. Rohan, our good friend. Good morning, Dennis. Rohan, good morning, Dennis and all. Rohan from Vizag, India. Good to see you, Rohan. Glad to see that you're coming around for the class. Hopefully you can stay for all of it, and would love your feedback at the end of it. Let me know what you think. Rex, our man in New York City. How are you, Rex? Hope you're well, my friend. Rex is also ably helping us on Twitch. He's a moderator there. He can cut down on some of the spam that we see on Twitch. Patrick says, good morning, Dennis and all, chiming in from Knoxville, Tennessee. Patrick, how are you? Good to see you. So Patrick's also one of our moderators, does a really good job of that, both on Discord and YouTube. So shout out to Patrick there. Mohammed Al Musa, hey Mohammed, how are you? Good to see you. Hope you enjoy the class today. I don't think I've seen you in the classes before, but welcome and let me know what you think of it. Hopefully you'll enjoy it. Sarvesh Padav, hello Dennis. Hey Sarvesh, how are you? Good to see you. Welcome to Sunday. Muatfer says, hey man, happy days from Turkey. Okay, cool. I think we've had a couple of people from Turkey, but not too many. Hope you're well. I think it's a little bit late in the day in Turkey there, so thanks for sticking with us. Hope you're well. Eshalmin El-Shamin Basim, I hope I'm pronouncing it right. Hello, I am a student pursuing data science. It's my first day today. Wow. Very cool. I am looking forward to learn from you. Wow, very cool. Thanks so much. I'm going to try my best, my best to help people. I'm open to being wrong. That's one of the things about being a scientist. You should always be open to a different perspective. So if I misguide you in any way, let me know. But hopefully, I can teach you a few things. If you want to get caught up on the previous classes, my lives are archived on YouTube. So this is our 4th session, so you're going to find sessions 1 through 3 already archived up there, so feel free to look at those if you want to get caught up. Mo says, hey, this is Mo. I'm here and watching on YouTube as well. Welcome, Mo. Good to see you. Mo, I'm trying to remember where you were from. I want to say that you were from Algeria? Remind me where you were from, Mo, but good to see you. Good to see you. And Mo mentioned he's on YouTube, which is ideal if you want to see the wide screen, because I'll be sharing a lot of stuff today. Yassine, good to see you. Hello, sir. Hope that you and everyone is fine. Yassine from Fez, Morocco. Well, but you're in Tangier, though, right? Or maybe you're still in Fez for the summer. Maybe school hasn't started. But glad to see you, Yassine. Glad you're here. Rahul, haven't seen you in a while. Hello, Dennis. Here again from the UK. Sorry, couldn't join you last week. Looking forward to today's session. Okay, very cool, Rahul. I'm looking forward to sharing the stuff from today, too. Rahul, remind me, I think you were in Birmingham in the UK? I think you're in Birmingham. Street Tennis Titans, welcome. Good to see you. Sir, how about econometrics? Today we don't really tackle a lot of questions, my friend. Today it's more about focusing on the class because we already go long enough as it is. I already talk too much as it is. So if we have time at the end, I'll circle back for questions. But let me get through the course materials or today's materials, and then we'll go from there. Okay. Okay, Mo, I'm sorry. Yes, you were from Jordan. Apologies. It's the first time, but for sure I will check archives video as well. I'm from the Kingdom of Jordan. Okay. Yeah, please check the archives for the first 3 classes. I think that they're kind of self-explanatory. If not, let me know if you have questions. Send me a direct message on Instagram or on our Discord. But yeah, really looking forward to sharing today's materials. Again, I think today is an important chapter. So Abdul Ghani 2400 says hello. Hey, Abdul Ghani, how are you? By the way, Abdul Ghani, I see that you are on Instagram. It's probably easier to switch over to YouTube, but you're welcome to stay on Instagram. I will do my best to try to share as much as I can on the Instagram narrow format. Rahul says, nice to see you too again, Dennis. I am from the South. I am getting everybody's location wrong. I think people are from Algeria. I think people are from Birmingham. I'm getting all these locations wrong. I'm going to stop guessing locations because my brain is obviously not engaged for that. So, yeah, so I'm still seeing people on Instagram that haven't introduced themselves. Feel free to do that if you'd like. But otherwise, I'm excited about starting today. Maybe today we can try to go under 2 hours. I don't know if that's possible because I do tend to talk a lot. But a lot of the time we spend is also the comments I get from you, and I love that. I love that you guys are interacting and giving feedback. So, if that makes us run longer, then I think that's a good thing. Hey, Leo, good to see you. Hey, Dennis, hope you're enjoying your weekend so far. I am enjoying my weekend. Anytime I get to spend time with you guys, it's very enjoyable. Yesterday I think we had a great stream, and I had some there's this new restaurant that opened near me that serves like hot spicy chicken, and I really like hot chicken. The thing is, I haven't found a place that like really has like blazing hot chicken. Like, I'm not gonna say I'm an expert, but I can handle a good amount of spice. So I went to try this place, and it wasn't nearly as good as I thought it would be. It wasn't nearly as hot. So, but it was still good, still having a good weekend, still spending some time with you guys. I have some friends coming in this week. I'm having dinner with a friend tomorrow night out here. So it's been a good time, really can't complain. All right, guys, that's all the introductions that I'm seeing. So unless there's any other questions, I want to go ahead and get started because I think today is going to be a really interesting way to look at data science and modeling in general, okay? So I'm going to switch over to my classroom view. All right. So today's chapter is called Ridge Regression, which is, I think, a very unique name, right? I think maybe the authors could have come up with a slightly better name. But what do you guys think? Let me see some participation in the chat here. What do you guys think about when you think about ridge regression? Like, what do you think we're going to be studying today? Like, what do you think this chapter is going to speak on? Like I said, it's a unique name. I'm kind of giving you guys clues. I would have named it something else personally. But what do you guys think? What is ridge regression? Or maybe some of you looked ahead in the chapter. That's totally okay. What do you think? What are we talking about? Give you guys a second to think about that. If you don't know, it's totally okay to say you don't know, too. Okay, so Patrick is volunteering. I think it has to do with regularization. All right, what do you mean by that, though, Patrick? Give it to me in English. Give me the elevator pitch on it. Patrick adds, but I don't exactly recall how that plays in. Okay. Hey, Tim, how are you? Tim checking in from Michigan. Good to see you, Tim. Hey, Tim, consider switching over to YouTube so you can see the materials better, but you're welcome to stay on Instagram if you'd like. Okay, so Ishalman adds, also known as L1 regression, where we add in a penalty term. Okay. Sarvesh says, from what I know, ridge regression is linear regression with regularization. Okay. Adam says, is our data linear or not linear? Yeah, right. The name kind of implies that, right? Like a ridge line instead of a straight line. Yeah. Anybody else? Or anybody else want to kind of expand on what they mean by regularization? I think Patrick and Sarvesh both mentioned that. Patrick says, my pitch on regularization, when the model gets complicated, there are lots of ways to fit the data. Regularization ensures that the fits are more realistic. Okay. Okay. You may call me Tim. I didn't subscribe, but no chat available on YouTube? That's weird. Anybody else having problems with chat on YouTube? Because it is a subscriber chat, but once you subscribe, the chat window should be open to you immediately. Rahul says, sorry, Dennis, please may I ask, are we covering only this topic from Chapter 6, Linear Model Selection and Regularization? Rahul, yes. Today we're just doing Chapter 6. We do one chapter at a time with the exception of the first class where we did the first 3 chapters. But yes, the Chapter 6 will be the focus today, and it usually takes us the whole time. Yassine says, I think it's about solving the problem of overfitting by selecting the more value to more impactful features and lower coefficients for unimportant variables. Okay. All right. I'm on board with the second part you mentioned, Yassine, about impactful features. I'm not sure if I'm on board with the first part of overfitting. Because you can overfit at any time, right? It doesn't matter how many features you have. So keep that in mind with your answer. I mean, I like your answer, but it's not just overfitting. You can overfit with any number of features, right? Overfitting is more of a function of your training methods than the number of features. But I think that Yassine's answer is probably the closest one. That's really kind of what we're talking about, right? And it's really not just, let me go to the next slide here. And it's really not just the most impactful features that, like he says, it's also just about any features, right? I pulled this chart here from Chapter 3, the chart that's up on the screen. And if you remember, this is one of the early charts that we saw about linear regression. You know, we talked about how TV spending, right? This value, the x-axis, is how much they're going to be spending on TV advertising, and the y-axis is how many sales happen at those spend levels, right? So we talked about how TV is the independent variable, and then we talked about how sales is the dependent variable. So we're trying to predict the sales, right? That's the target variable, as it would also be called, right? But here's the thing, like that chapter and all our discussion, we never talked about, well, how do you come up with TV, right? We never really talked about that. We just, the authors just kind of gave that to you, right? And so far, everything we've done has just kind of been given to us like, oh, we just know that TV is the independent variable. And even in some of the stuff we did last week with multiple independent variables, we just kind of took it for granted that these were the variables, right? But real life is not like that, right? Real life is also is going to be, you're going to have this wide data set, hopefully a wide data set, and it's up to you to determine what is relevant and what is not, right? In the real world, you are not told what is the independent variable. So you have to find the independent variable. And that's essentially what a lot of today's, or a lot of Chapter 6 is, right? How do you actually go about finding those independent variables, right? So it's really kind of what we're doing. So you're also going to hear this in terms of like feature reduction, right? If you think of your entire data set of every one of those being a potential feature, how do you reduce those to say, okay, well, I may have 10 different attributes that make up my sales, but it's really just these 3 that are the relevant ones. And that's effectively what we're doing today. So we can get kind of caught up in, well, it's regularization, it's feature engineering, it's feature reduction, it's, impactful features versus not. I'm kind of taking all the definitions, right? But it's really about how I have this entire pool of data. How do I choose which ones are the most relevant to my target variable, to what I'm trying to predict? Okay? That's really all we're doing. I'm trying to put it in plain English for you guys because I don't think the authors do a great job of doing that. Like, why not just call this chapter feature selection, right? Because that's really a lot of what we're doing today. And by the way, if you've seen some of my earlier content, you know that I have a series on interview questions that I ask. And this is one of the interview questions that I ask, and I've seen it in other interviews, right? If you're starting from a new data set, how do you know which features you're going to use? Or in my case, I ask specifically, what is your model, your feature reduction process, right? If I give you 10 factors, how can you tell me what are the most relevant ones? That's a very common interview question. So that's why I think that, the chapter is kind of important today. Okay. Let's go look at some of these answers. Lakshmi, welcome, says it is used in dealing with high dimensional data. Yeah, that's a portion of it. And we're going to talk briefly about that. Eshalmin says, I would add in this, we had a penalty term to reduce the error function and hence shrink the coefficient to prevent overfitting. Yes. You had me at shrinking coefficient, you lost me at overfitting, right? It's not just overfitting, guys. It's also just what features are relevant, right? You can't overfit unless you know what features are relevant first, right? And there's a lot more ways to commit overfitting, or commit the sin of overfitting than what we're going to talk about today, right? Lots of ways to do that. Adam Steezy says, wouldn't that price of how much we spend be dependent on how much spend? Adam, I think you might have it reversed here. So it's TV spend to the amount of sales made. So like you kind of think of it as revenue. So it's more about, the relationship between the TV spend versus how much that's going to come back to you in sales, right? But again, that's not really the focus of today. The focus of today is, well, how did you know that TV spend was relevant? Right? Because we never really asked that, guys. If we look at this chart up here, right? We never really asked, well, how did you come up with TV spend? Well, the answer is the authors told us that, right? And that's okay, but the real world is not like that. And that's why feature selection exists, right? Because you're not going to be told what is the relevant features. We have to find them, and that's what we're doing. Okay? Joseph says, I'm in line with Patrick on this one too. I like to think of regularization as trying to prevent overfitting. Yeah, but there's a lot. We're going to talk about this later on as we talk into more models. There are a lot of ways to commit overfitting, right? So I don't want you guys to be married to this chapter as being that, because overfitting is something you have to be aware of at all times, not just in this chapter, right? Like for me, if you guys really want to talk about overfitting, here's where I see overfitting the most. Where I've seen overfitting the most in the real world is in train test splits, right? Let's think about a train test split where you have your data and you decide that your training set is going to be 70% of your data, and then your test set is going to be 30% of your data. Right? Like a 70-30 split. Have you reduced your chances of overfitting? Yeah, you have. What if you come and you do it 95% training, 5% testing. Have you reduced your chances of overfitting? No, you've actually increased them, right? So that's where you're going to see overfitting a lot more. And I know that sounds like a weird example, but you're going to be tempted to do that when you have data sets that are limited. Not everything out there is a deep data problem, guys. You're going to be in business situations where you might only have like 2,000 samples in your training data. For most problems out there, that's not enough data. But your boss is going to tell you, well, that's what we have. Go to it. Super tempting to go, let me just put in 90% training and 10% test. Super tempting to do that, right? But you're overfitting. So that's why I'm using that example, because it's not wholly incorrect to say that this is for overfitting. It's more about the selection, and this is not the only way to overfitting. Like this in the field of overfitting landmines, this is a small landmine. There's much bigger landmines for you guys to avoid when it comes to overfitting. Okay, so keep that in mind. Rahul says, we can do correlation analysis. Yes, you can, but correlation analysis is reducing features to each other, not necessarily to the dependent variable, to your target variable, right? The correlation analysis helps you make sure that you're not kind of like double modeling on the same feature, but it doesn't necessarily tell you that it's correlated to the target. You could do scatter plots, which are kind of sorta a form of correlation analysis. It's kind of sorta. But in the traditional sense, correlation analysis is more about feature to feature, not feature to target. And we are more concerned about feature to target with this particular exercise. I hope that makes sense, Rahul. Eshalmin says, so is it that the features with shrinkage of the size of the coefficients, we are able to make it the relevant features? Yeah, that's a portion of it, and we're going to talk about that. So Ishalmin, you're on the right track. Hold on to that thought, because we are going to talk about that. I don't want to get into it right now because I want to show it in a little bit more of a visual way for everybody else, but you're on the right track with that thinking. Okay? All right, so let's go to the next slide. So this is basically what we just went over, right? The bottom line is that the best features in your model are not always known to you, right? When school's out and you're in a job, you're a data scientist, the world is not labeled, as we've talked about before, right? The world is not labeled, and features aren't labeled. There's not going to be an author there to tell you what the independent variables are. So that's basically what you have to find. So the chapter presents a couple of ways to do it. So there's best subsets, and then there's a stepwise selection. And those are basically the two tactics that we're going to focus on. Because this is basically how we can determine what combination of features makes up our best model. And keep in mind that your best model may not be a good model, right? So there's no guarantee here that you're going to find a great model. It's just that you're going to find the best model that's available from your current selection of independent features. Okay? And then the third bullet here is you should be aware that it's an iterative process. And when I was writing this section, I realized that we haven't really talked a lot about the iterative process of model development. You shouldn't be thinking of model development as a single cycle that you go through. You're going to go through various cycles, right? You're going to go through various cycles where you might say, okay, yeah, I went through this process to reduce my features. You know what? Let me assume that's my model. What happens if I take that and I apply cross-validation to it? What happens if I take that model and I get new information? What happens if I take that model and some new features have now extended my available data by another 10 columns, another 15 features? What then, right? So it's going to be an iterative process where you can combine some of these techniques. It's not always just like a one and done type of thing. You can modify and try different approaches at different times. That's totally okay to do that. Because not only is that a healthy part of the scientific process, to test your results, but it's also going to give you more confidence in your final model to say, not only did I find this via, stepwise selection, but I also ran it through cross-validation, and I also ran it against some, completely unseen data, and these are my results, so I have pretty good confidence in my results, right? So I'm going to try my best to not forget to point those times out, but there are a couple of times here where you could say, wait a minute, that was one result, and that's a decent result, but let me try a second iteration by doing this, this, and this instead, right? So we're going to, so kind of be aware of that, okay? All right, so let me go to the next slide. By the way, if I see you on Instagram, you're welcome to join us. You're welcome to stay on Instagram if you'd like, but you're also welcome to join us on YouTube so you can see the slides a little better, okay? All right, so subset selection. If this sounds overly simple to you, or maybe if it sounds a little bit brute force to you, yeah, you're probably right. It's not really complex, And this is one of the things I really love about data science. That a lot of these things that really sound like complex and like really like advanced and like super hard code and stuff, it's really not very complex when you break it down. I mean, here, this is called best subset selection, but it's just a brute force method. It's kind of like a Monte Carlo method, right? If you guys aren't familiar with like Monte Carlo methods, when you talk about Monte Carlo method, you're basically saying that you're running through the same problem, just different iterations of the inputs, right? That's a Monte Carlo problem. And you could argue that this is what's up on the screen right now, right? So if we look at these charts, the x-axis is the number of potential predictors that your model could have, right? So in this case, we are assuming that our model has 10 different features. And we are saying, okay, if we were just to use one of those features, give me all the permutations of those features, which in this case would be 10, right? 10 features, one model per feature, that's 10 different models. How do each one of those models do? Okay, now what about 2 features? Well, that's 90 permutations, right? 10 times 9. Okay, let me try all 90 of those permutations, and what are the results there? Because on the y-axis, by the way, if you guys haven't seen it already, it's the residual of sum squares, which we already know is one of the valid metrics that we've used in the past, right? The RSS for measuring models against each other, right? So that's all this is, right? We're saying if I decide, right, if I declare that my model has 2 relevant features, then I'm going to try all of those features, all the permutations, 10 times 9. Okay, what happens if I do what happens if I change my mind and I say no, my model has 3 features? Okay, well now it's 10 times 9 times 8, right? Now I got to try all those permutations. And so on until you get up to 10, right? So now you're trying every single possible feature combination out there. And there's no magic to this, right? It's almost literally like a brute force Monte Carlo approach. That's all we're doing. We're assuming that there are X number of features in the model, so let me try all permutations, all combinations of those features. So on this side, we see the residual of sum squares. And on this side, we see the R squared value. If you remember, RSS is a measure of how many errors that you are making in your modeling, and the R squared is a representation of how closely your training data fits your modeling data. Or excuse me, how closely your model fits your training data, right? So you shouldn't be surprised when RSS, the better values, are lower, right? You want the smallest RSS possible. And you want the highest value of R squared. Ah, Rahul. Rahul, you read my mind, my friend. Okay, guys, so Rahul is asking an important question here. Do you guys see any downsides to this approach? What are some of the downsides here? Anybody see any potential problems? Give you guys a minute to think about that. Rahul read my mind, so if you want a clue, you might want to start by reading Rahul's comment. I'll highlight his latest comment. What do you guys think? Anybody see problems with this approach? Eshalmin says the iterations. Okay, well, what about them? What about the iterations? Give me some more detail. Yassine says computationally costly, especially with a large amount of features. Okay. Patrick, seems like after 2 features, we are wasting compute. Okay. Rahul says with more number of features, it would take more time and become more inefficient. Yeah, you guys are right. You guys are hitting upon all of them, right? It's computationally costly. Absolutely. Yassine is right about that. Patrick, yep. After 2 features, there does seem to be like a diminishing returns, right? You know, but keep in mind though, Patrick, that could be just exclusive to this model, right? You really couldn't write that off because the whole point of doing all the permutations is that you don't know. How do you know that the 9th permutation isn't going to be like a really important one, right? Or excuse me, the permutations with 9 factors are going to be really important. You don't know, so you try them all, right? So I hear you. In this particular chart, there's definitely a diminishing return, but that's not always going to be the case, okay? And then Rahul says, with more number of features, it would take more time to become more inefficient. Yeah. And Eshalmin adding to his answer, it will be time consuming and computational, take a lot of time. Absolutely. Yep, Patrick, you're absolutely right. The growth is in a factorial way. So by 10 features, we need to try 10 factorial ways. Yeah, that's exactly right. Yeah. So you guys are doing this perfectly. You're hitting out on everything. Don't quote me on this, and I apologize if I'm misquoting the authors. But the authors do say this. And in fact, they put a number on it of about 40 features is what they think is like an upper limit for this. Again, I'm trying to make sure I'm not misquoting them, but I'm pretty sure that's in the book. You guys can read the chapter for yourselves and tell me later. But they put it at like after 40 features, you're kind of like, you know, should be moving on to other ways, right? But, you know, they recognize too, right, that this is inefficient. But it's a valid approach, right? From a scientific perspective, it's a valid approach because you don't know what you don't know. So you just try everything, right? The way to cover all your bases when you don't know is to try everything possible. It's not elegant. It's definitely computationally intensive, as basically all of you point out. But it's valid. It's a valid way to do it, right? And maybe you wouldn't want to do this locally, but on a good high performance server that you're going to have in a corporate environment, you know, it's still a reasonable approach. You can still, you know, do it you can still kind of find your iterations and run those iterations in a reasonable amount of time, right? So I agree with all of you. You guys are hitting it right, or hitting the right responses, but it's a valid approach, guys. All right, so don't forget that. Don't kind of miss those forests for the trees. It's ugly, it's not elegant, but valid. All right, Patrick says 40 factorial is like 10 exponential 47. Yeah. And like I said, I apologize if I'm misquoting the authors. You guys can check me, but I'm pretty sure that's what they suggest as an upper limit. Sarvesh, sorry I missed your answer early. Beyond 3 features, the RSS saturates. Yeah, it does in this example, Sarvesh, but as I told Patrick, it's not always going to be that way. Yes, there is most likely a diminishing return in all models, but it's not always that way, okay? And again, you don't know, so the answer is to do everything, okay? Leo says, in your opinion, what would be the ideal proportion of features for a model? Shouldn't we consider the size of the data set? No, Leo. That's you're headed down the road of bias there, right? You shouldn't have any sort of preconceived notion of that. That's why you go through the process to reduce the features and find the relevant features, right? So no, I wouldn't say that at all. There is no proportion. If anything, one of the things we haven't really touched upon yet, and this is a good time for it, is that remember that when you start modeling, even before you get to this process, you want the widest data set possible. So we haven't really talked a lot about data transforms or feature engineering, as some people would call it, where you want to make sure that you have the widest data possible, because that gives you the best opportunity to find a valid model or a more accurate model, right? 10 features might be able to get you to 85% accuracy, but you add a few transforms that gets you to 30 features, and now you're like at 95% accuracy, right? So you really shouldn't have any preconceived notions of that. The only thing you want is just want the biggest data set possible, because that increases your probabilities of finding a valid model. But anything other than that, Leo, you can't kind of go down that road, because otherwise you're saying, well, maybe I should cap it at 10 features, but there's no way to base that, right? What if there should be 15 features? You'd never know, right? So no, there's no proportions, no preconceived notions like that, okay? Patrick says, I think that's what this process reveals. Yeah, that's what we're trying to achieve here, right? But you're trying to achieve that with the initial notion of, I don't know how many there should be. You should start from that. That should be your knowledge base. It should be, I don't know what the answer could be, so I'm going to try them all. Rahul says, so what is this graph telling us when it's seemingly flatline? Okay, remember guys, it's only flatlining in this scenario. It's not always going to be like this. But what you would say here is you would say that after 4 features, maybe after 3 features, there's no net gain because your metrics are not improving. So I would interpret this as saying, pick the best of the different models that you tried that have 4 features, pick the best one, and that is your, I'm not going to say your best model, but that's going to be your most acceptable model, because anything beyond that doesn't really improve you in a significant way. Right? But then again, as we spoke on the earlier slide, what if your 4 feature model starts failing once you show it unseen data? What if a year in the model starts to deteriorate? Models aren't static, right? They change. New data comes in and can change the results of your model. So now maybe you need to go try that 5 feature model, that 6 feature model. The data says that there shouldn't be a difference, but maybe there is. Data changes, right? So that's what this is telling you, Rahul. That your best potential model is at around 4 features, and that there's no significant net change after that. But that's not always the case. Leonardo asks another good question. If we hit 90% accuracy, do companies consider that enough? You can't say that either. It all depends on the problem. Right? It all depends on the problem. So let me go over that example that we had earlier, because I know this. I know some of you already heard this example, but I know there's also a lot of new people, right? But let's say I have a model that I'm telling you has a 90% accuracy, and that model predicts the default of loans. You work for a bank, they ask you to do a default model for loans, and you got to 90% accuracy. Is that a good model? Yeah, that's pretty reasonable. If you can predict 90% of the time when people are going to default on a loan, yeah, most companies would accept that, right? Okay, so now you work for a company that develops autonomous vehicles, and you have a model that determines whether a vehicle should press the brakes or not, because there might be, an object or a person or something ahead in the road. Is 90% enough there? Maybe not, right? So it all depends on the problem. There is no single answer to that, Leo. Every problem, every need is different. So you really can't say like, well, I'm always going to aim for 90. Well, maybe you need more, maybe you need less. You never know. And this is why it's important to keep up with your stakeholders, right? And to keep those conversations going. They have to be part of the process to guide you in that way. All right? Leonardo says, oh Lord. I'm not trying to pick on you, my friend. I love the participation. I love your enthusiasm. Just kind of need to put some bumpers around your thinking a little bit. I'm here to be your shepherd, okay? So don't worry about it. All right. Rahul says, what if we start with 10 features and remove a feature one at a time in every iteration? Rahul, you're getting ahead of us, my friend. We're gonna talk about that. We're gonna talk about that. Hold on to that thought, okay? We're gonna talk about that. Eshalmin says, then how are we going to determine the optimal independent variables for our model? This is one of them, Eshalmin. This is one of them up on the screen. It's not elegant, but it works. Right? If we were to continue with this, we would say, okay, 4 features is it. So now, of these tests that I ran, I want to find the most optimal of those features, and according to my results, this is the optimal model for now. That's how you would interpret this particular chart. So that's what I would say, right? Okay. All right, everybody with me? I'm seeing the chat calm down a little bit. Is everybody with me? I think we're good on this, yeah? So this is best subset. It's not there's no magic to it. We're just trying every permutation. Okay? It's just that the relationship between computational power and efficiency on a due project that it seems hard to combine. Yeah, sure, Leo. But you're gonna have more computational power than you think you do, right? Because you're gonna be working in a server environment in a big corporate entity, right? Like a distributed server environment, a high performance environment, right? And second, you're gonna be doing this early on, right? Feature selection is done very early on in the entire process. So at this time in the process, you're unlikely to be like pressed for time, right? I mean, you want to keep the process moving along, obviously, but this isn't late stages, this is early stages, okay? All right, so I'm getting some positive feedback in the chat. It looks like you guys are ready to move on. Okay, so what if we can do this a little bit more efficiently? Right? Because we're trying every combination, but we're ignoring the results of each individual test, essentially, right? You don't care what any individual test marks, just try them all. So stepwise, helps us with that. Stepwise says, yeah, we're going to go through all the features, but I'm only going to add features based on if they improve the model or not. Right? So I'm going to start with these two features, and then I'm going to add a third feature. And I'm only going to carry that third feature into the fourth feature testing if it did really well in the previous tests, right? So it'll go through one feature, pick the best model from there, and then add a second feature while holding the first feature static. And keep adding features, find the best of the two feature models, and now you're going to hold the first two features static, and you're going to add a third feature, and so on and so on and so on. And in some cases, you might end up with 10 features, you might end up with just 2 features. But that's the steps that it's referring to, right? You're going to start with one feature, find your best model, 2 features, get the best model there, 3 features, best model there. And you're going to come up with a similar chart based on what, based on the errors that it's making, right? Because we're always trying to minimize the errors, right? The RSS. So that helps cut down on the number of permutations. Okay. Rahul says, would multicollinearity affect stepwise selection? Are we assuming here there is no multicollinear? Yeah, we are assuming that. Is that a dangerous assumption? Maybe. Some people would say it is. Right? And we're going to come back to that. Okay? We're going to come back to that. So, there's 2 types of stepwise selection. Forward stepwise means that we are adding features. I just finished describing forward stepwise. Start with one feature, add a second one, add a third one, add a fourth one. Backward stepwise selection says that you start with all the features and then reduce the features based on their effect on the model. So who said that earlier? I think it was Rahul. Actually, I think we have 2 Rahuls. Sorry. So I'm referring to Rahul Dev Sharma, right? So Rahul Dev Sharma wrote that earlier, right? Rahul, I don't know if you meant this on purpose or not, but you were describing backward stepwise selection. You start by looking at everything, and then you start reducing 10 features, 9 features, 8 features, and so on, right? That's backward stepwise selection that you were describing. Or, as I said, you do it the reverse, you do it the other way, the forward step selection, which is one feature, add a second one, add a third one, add a fourth one, and grow your model from there, right? But you have to be careful here. You have to be careful here because there are some permutations that you are missing, right? You wouldn't be able to look at all permutations because you're essentially, your model, I'm trying to not use the word bias here, but your model is highly affected by that first anchor feature that is found. Because you're locking in these features as you find them, right? So you're trying a significantly lower number of permutations as you go along. So you should be careful because instead of taking that wide field view that you're taking in the subset selection, you're narrowing it down every single time you pick a feature, right? Because the number of permutations drops, right? It's no longer 10 times 9 times 8. It's 1 times 1 times 8 because you're locking those first 2. When you get to trying that third feature, you're not going back and trying other combinations of those first 2 features, right? You're holding those as ground truths. And that can be beneficial, but it can also be dangerous. There is a a flip side to that coin, as we say. So keep that in mind, that this, the stepwise selection it's much faster. It's much more effective when you have like hundreds, if not thousands of features to check. But you are missing permutations. There are cases where you could miss permutations that are still relevant to your testing. All right. Patrick says, "Great job, Rahul." Yeah, I mean, like I said, Rahul, I don't know if you were trying to if you read ahead or you know about this already, but what you were describing was exactly backward stepwise. So I don't know if you did that on purpose or not, but yeah, good job on that. All right. Give me just a second here. I think I put these out of order because I think this is a good time for me to talk about something else. So while we're talking, while we're talking about being careful, and while we're talking about these subset selections, and I'm also getting some really good comments in the chat about the proportion of features, and we talked about making your features wider, starting with the widest selection base. I've put something up on the screen that is super, super important. I cannot tell you how important this is. If there was like a 10 commandments of data science, right? Like rules you absolutely do not break, this is one of them, and it's a very common rookie mistake, guys. You're gonna come across this in your first year of data. Well, hopefully you won't after listening to me, but this is something that a lot of first year data scientists run into. Always double check your work to make sure that you are not modeling on data that is not available at prediction time. I want you to, if you remember nothing about today, please remember this. Okay? So what do I mean by this? Remember that everything we're talking about, learning data science, all that, we're essentially just talking about the training side of a model. How does a model come together, right? But there's the predictions side too. What's referred to as the prediction side or the runtime side, right? Because you're going to use that model, right? You're going to deploy that model to be running on another system, and at that point you're not running training cycles. You're just saying, here's the inputs, what's the answer I get back, right? The runtime version of your model, right? It's a very common mistake where people will model on features in testing, in the training, in creating the model, that are not available when you go to actually run the model. All right? I'll give you an example of that. So an example of that, this probably wouldn't happen, but let's just say, as an example, you're working for a bank. We'll stay with these loan examples, okay? You're working for a bank that wants you to write an algorithm for a loan process, or a loan approval. And as part of that process, as part of the data that you're given things like their expenses, right? So you're giving things like their rent, how much their housing payment is, what their credit score is, and what their income is, like a monthly income, let's say. So you go and model on those three, right? I know how much you pay for your housing. I know what your credit score is, and I know what your income is. Okay? But in reality, the way the bank collects that information is that they only collect the housing information and the credit score. And then they only verify the income after the loan is approved or disproved. Or I guess only when it's approved, right, is when you would need it. So that creates a problem for you at prediction time. Because when the bank needs the answer from you, they're only going to have two of the 3 pieces of information that your model needs. They're only going to have the housing cost and the credit score. The income is checked later at, 2 weeks after the loan is funded. Right? You're not going to know that by looking at your training data. Right? When your stakeholder hands over that data, the data doesn't tell you that. Right? To you, it's just going to be a flat table of customer attributes, right? Or loan application attributes. So you're going to sit there and you're going to say, oh, well, these are my 50 features. I'm going to model on them. And subset selection told me that I should be using credit score, housing costs, and income. But they're not collected at the same time. You're not going to have those at runtime. Massive problem, right? Because now you're going to deploy a model and you're going to run into problems because they're going to tell you, well, here's the 2 inputs. And you're going to say, well, no, I need 3 inputs. Why are you only sending me 2? Well, we don't have that 3rd input. Now, I'm just giving you an example here, but there's a million ways this could happen, right? It's more to do with the timing and the collection of the data. Just because it's in a single flat file doesn't mean that it's collected at the same time, right? So this is something that I always ask of my, actually, I shouldn't even say my first years. I ask this of everybody. Before I sign off on somebody who approaches me with, to approve their model plan, I always ask them, did you make sure that we're going to have this data at runtime? And I'm experienced enough where I can look at the data and I can kind of like flag things and I can say, I want you to verify this, make sure we're going to get this. Because stakeholders will tell you that they have all the data, but they don't always do that, right? They don't always know their own processes, right? So be careful with that, okay? Be careful to make sure that you're always going to be modeling, and creating your models on features that are available to you at runtime. That's not always the case. It's up to you as the developer to verify those items and to make sure that your final model has all of the relevant inputs. And you might want to do that even before you do your subset selection, right? Because if you can cut down on those features that you're not going to have, then you've also cut down on your processing time, right? Because now you can say, I started off with 80 features, but I know these 10 are not available at runtime, so I want to throw them out because, I don't want to create a model on those because I won't have them. So I can immediately throw those out. So that helps you too from a processing perspective, right? Some of the same problems that some of you have already highlighted in the chat, right? So keep this in mind, guys. Like I said, if there was like a 10 commandments of data science, this would 100% be on there. All right. So I want to make sure that I'm putting a lot of emphasis on this because it's a really important part of data science, and especially when we're talking about feature selection. The authors don't mention this, right? Because these are the types of things that academics kind of miss, right? As far as like looking at the real world, right? Everybody kind of assumes that the data is nice and ready and collected at the same time and always available, right? And that's not really the case. All right, so you guys with me on that? Because I cannot stress this enough. Super, super important. Do not let this bite you in your career because it will be a huge mess if you ever let that happen to you, okay? You guys with me on that? Give you guys a little 30 seconds to think about that. Super important. Hey, I'm seeing new people join in on Instagram. Feel free to switch over to YouTube if you'd like, just to kind of give you a little bit of a better view at the all the code and stuff I'm showing up. Okay, so Lakshmi says valuable key, yes. Aishal says yes. Okay, cool. So it looks like this is resonating with you guys. Okay, good. I cannot tell you how important that is, guys. I do not want one of you guys to come back to me in the future and tell me it happened to you, because then I will feel like a failure. I feel like a failure when somebody I'm supervising does it because that's on me, right? But I'm always careful to sign off on that. Okay, so how do we know what the best model is, right? we have to come up with a pretty good measure because we're going to be running like a ton of tests, right? Right? I mean, as Patrick pointed out, the permutations add up really quickly, right? So we have to make sure that we have a good measure for what we're doing. And the hard part here is that we have to focus on measures for good test errors, not necessarily training errors, right? Because remember that you're going to get two types of metrics: how you did against your how you did against your training data versus how you did against your test data. So the authors here propose that RSS is actually not a good selection at all for the metric that you're going to compare against. So we can continue to use mean square error because that is a measure of how you did against your test model, or how your model did against your test data, And then they also introduce a couple of new features: AIC, BIC, and the adjusted R-squared. I invite you to read the book and look at some of the math that's involved in there. But the bottom line is that you only need to pick one, right? And in this case, it's really, kind of what you want to do. But I usually find that in most scenarios, the adjusted R-squared is going to give you a pretty good indication of how well you're doing. Because the R-squared is what compares your model against your training and your test data. But you're welcome to choose the AIC or the BIC. It's really more about standardizing on one of those and then always using that to compare your many results that you're going to have throughout these selection processes. You can also think about using cross-validation, right? And I mentioned this earlier, right? Where you can have a model and you can find your best model via the subset selection, and you can say, hey, I feel pretty good about this model. But wait a minute, let me run it through cross-validation too. Let me make sure that I'm using that the cross-validation results are also something that, they hold up via another testing method, right? Because you can basically say, okay, the feature selection is how I find my model, how I reduce my features. And then cross-validation is how I'm going to add that extra assurance that this model and these features are going to lead to results that I can live with, that the business can live with, right? That are going to be acceptable for the particular use case that I have in mind for this problem. So that's part of that iterative side of development. You shouldn't be thinking of, well, I'm just going to do subset selection. I'm just going to do this. I'm just going to do cross-validation. You can combine them, right? You can combine them to get like that extra assurance. Okay? As she says, high R-squared might also mean overfitting to the training data. Maybe. How big is your training data? How big is your model? Depending on those factors, it may or may not indicate that overfitting. But R-squared is very valuable in terms of using it as a measuring stick on how well your model is doing. So it might indicate that, or it might indicate a strong model. It just depends. Rahul says, you are giving really good practical real-world perspectives. Those never came into mind while reading those mathematically. Yeah, Rahul, and that's one of the things that you're hitting upon a couple of things, right? I mean, one, that's why I do this, because I have the real-world experience, and that's what I'm trying to give, right? I want to honor the authors, so I'm not here to copy their work. I want to build upon it, and that's what I do, right? I try to give you that real world perspective. And yeah, you can't take too much of a mathematical view towards data science. I did a piece of content on this yesterday. please don't become a math robot. Don't become a code robot. What you do in data science has real world impact, right? I can't stand the people who just take like this very strict, dogmatic, mathematical view towards data science. There's real people and real results at the end of all those numbers. So you have to take that in mind. So in the example, we're talking about making sure you have data that's available at prediction time. That's a real world impact. But guess what? If you make that mistake, that's going to severely affect your reputation too, right? You could have studied all the math in the world, but if you mess up at that last step and you deploy a model that can't be used because of basics like that, your reputation is going to take a massive hit, right? I mean, I'll stop short of saying that that's like a fireable offense for somebody who works on my team, but yeah, it's pretty serious. Like, what do you mean you didn't check like if we're going to get that data at prediction time? Like, that's bad. Now, again, with my style of leadership, it's also on me, right? I take total ownership. But, like, as an individual, for you guys, for growing data scientists, that's a massive hit. If you just are dogmatic on the math and I got to know these formulas, no, you can't do that. Data science has a real world impact. So Rahul, I'm glad you mentioned that, and I'm glad you're picking that up, because that means others are also picking that up. And yeah, I think it's an important part of all of this, because you can't be a math robot. Approaching data science with a math robot mentality is guaranteed for failure. Ashish says, what adjustment is done in R-squared to make it adjusted R-squared? So Ashish, I would encourage you to look it up in the book. The formula is presented by the authors. I believe that they adjusted by doing a proportion of, I can't remember what the factors are, but it's a proportionate amount that they further adjust to the R-squared. So it's in chapter 6. You're welcome to look it up. The PDF is free from statlearning.com. But it's presented in there. I think it goes beyond the scope of what I want to talk about today, okay? Akib asking 2 questions. Can we apply PCA on binary variables too? Or when we have both binary and continuous variables? So we're going to talk about PCA just a little bit. I think that PCA is better for another discussion when we get more to unsupervised learning. I understand that PCA is shared in this chapter, but I'm going to save that for another discussion, okay? And I make note of that on one of the upcoming screens, okay? Unknown Crusader says, may you make your book available to the Indian market? So my book should be available to the Indian market. At least the ebook version is. I believe you still can get the paperback version, but I have made the ebook version to be accessible to as many markets as possible. I spoke with a couple of people that DM me. I try to collect data from all of you guys as my customers. So I was told that the pricing that I chose for the Indian market would be a reasonable price. I think I'm still under 500 Indian rupees. So feel free to look it up on Amazon. The Kindle version is available for download there. You can get it instantly. It's under 500 rupees. At least that's what I've been told. I haven't independently verified that. I should, but you should find it on the Amazon resources within India. But thank you for the question. He's referring to my book, Your First Year in Data Science. I don't sell courses. I don't have a Patreon. If you want to support me, my book is the best way. I like writing books. They're kind of my legacy, and I really enjoyed writing this book. So if you'd like to support me, that's the best way to do it. Yeah, thank you, Yassine. That's exactly right. So I think that is the formula. So Yassine, thank you for that. Who asked that? I think it was Ashish. Yeah, Ashish. There's Yassine is providing the formula there for you, and that is the adjustment for that's how you get to the adjusted R-squared. Okay, so it sounds like you guys are with me on this. If you don't necessarily understand the iterative process and how cross-validation can be used, that will come to you as you gain more work experience or as you do more of your independent research with models, okay? Just remember that a model can always be verified, right? There's always other ways to add that assurance. In some cases, like maybe if you're into quant trading or if you see some of the finance videos, they refer to it as confluence, right? There's always ways to find confluence for your models where you can take a model that looks good, but then verify it and re-verify it via other methods. That process is known as confluence. So maybe I should use that word from now on. Okay, so let's keep going, guys. So as I said, if you remember nothing, please remember this, okay? Very, very important that you're modeling on data that's actually available to you. She says, I can't see any formula for Rahul. It's not by Rahul, it's by Yassine. I'll leave it up on the screen up there. I've highlighted it as part of my chat. But again, if you feel free to get the PDF, it's completely free. Statlearning.com, that's the author's website. I recommend you download it from there because that's the best source. And they have the formula in there, okay? But I believe what Yassine has put on the screen is the correct one from my recollection. Rahul says, yeah, your book is available in India. Paperback is 3,000 rupees. Kindle is 449 rupees. Okay. So, Unknown Crusader, I think you can see Rahul's previous comment. It should be right above yours. But Rahul is saying that the Kindle is available. But yeah, I mean, my understanding, that is the pricing I chose for it. It should be under 500 rupees. And the paperback, I think, is a little bit more because of the shipping and whatnot. But you know, guys, when it comes to the paperback, let me get my copy up here. When it comes to the paperback, I understand that it could be a little bit higher than what's accustomed in some markets. But I went through a bunch of different iterations for this book. I was testing different papers, different prints, and I made it a color book. So the interior is all color. So any charts that I'm providing are color charts. So it's a little bit more of an expensive selection on my part, but I think it makes for a better book. It's more quality paper and things along those lines. So that is part of the pricing of it. But as I said, the Kindle version should be accessible in the majority of markets around the world. Ashish says, okay, I will check in the book itself. Yeah, Ashish, go ahead and do that because the authors do provide a better explanation of the math than I could. Because again, I think the math kind of goes beyond the scope of what I want to cover with you guys, okay? All right. So I say that, and then I have a math formula up on the screen, right? Okay. But here, we come across our old friend, y equals mx plus b, right? So if you've joined us before, you should already recognize this formula because I have proposed that a lot of things in data science come back to this formula, y equals mx plus b, right? M is your coefficient, the weight, and x is your feature, right? Your independent variable. So what is the feature and how much weight do you want to assign to it? And then those two combined have an effect on your dependent variable, on your target variable, right? I mean, that is 99% of data science. What is the feature? How much weight are you giving to that feature? Right? So, ridge regression basically says, okay, well, you focused on what features to use, but couldn't you also focus on the coefficient value? You could adjust the coefficient value, right? So, in other words, ridge regression helps you look at both sides of the equation. We've looked at the x side of the equation, the independent variables, right? We've said, hey, we've taken this big data set and we think these are the 5 relevant variables. But that's just one side. What about the coefficient side? And that's what ridge regression helps us do, right? Okay, so everybody in the chat, I want an answer, okay? Don't be embarrassed. I want to increase participations. Don't be embarrassed with an answer. You can also just choose to agree with somebody else's answer if you'd like. But, let's get some participation. What happens if m, the coefficient value, is high? And what happens if it's low? What happens to your model overall or to your feature overall as your coefficient value approaches 0? What happens? Ashish says, actually, we have a second Ashish. Ashish Kumar says features will get reduced. Okay. Rahul Jain says that feature will have less weightage in the coefficient if the coefficient's value is near 0. Yeah. Yep. Anybody else? Ashish Kumar says, and the complexity of the model also reduces. Yeah. High M is small change in X greatly affects Y. Low M, any change in X minimally affects Y. Oh, Patrick, I love the way you put that. Look at that. Patrick put that in expert level. Sarvesh says we would be decreasing the contribution of the corresponding feature. Yep. Oh, Hamed. Nice. Hamed, I don't think I've seen you before. Welcome. Y becomes less dependent. I think you meant to say X. Y becomes less dependent on X, I think is what you meant to say. But yeah, okay. Okay, yeah. You guys are getting it. Okay. All right, so here. All right, here's when the coefficient, Yassine says when the coefficient is high, the model is biased, but the result varies so much for each training set. Okay. Eshamin says because of this model can be affected by individual data points. Yes. Yes. Okay, look, you guys are getting upon the greater the greater point here, right? That as M approaches 0, you're reducing the power of X, right? And that mostly happens because it's a multiplicative function, right? It's a multiplication operation. So as M approaches 0, X, the effect of X also approaches 0, right? All right. So that was the easy question, right? And I'll give you the warning ahead of time that I asked this in interviews. Okay, this is one of my interview questions. There is a name for that. There is a name for that process as M approaches 0, and X kind of shrinks. What is the name for that? There is a name for that, and if you want to think about it, you see it more as you get more and more into deep learning. What is the name for that process? Anybody want to take a guess at that? I'll give you guys a minute to think about that. Hey, Deadlord, good to see you. I'm doing well, thank you so much. We're running a good class. Glad to see you. And I still see people on Instagram. You're welcome to stay on Instagram, but you're also welcome to switch over to YouTube where you can see all the code and everything else, okay? So there's a name for that as M approaches 0. Lasso regression, regularization. Think about more about what happens to X. What happens to X? These aren't limit tends to 0. Yeah, Rahul, that's what happens, but there's a name for it. Yassine is giving us the closest answer. Yassine is saying shrinking coefficients. Leo says test error. No, Leo, you're kind of going the other way with it. Think about what happens to X, right? Eshalmin says denoising. It's denoising because you're taking away the number of features. But what if we just focus on one feature, right? One feature, and you're making the coefficient approach 0. There's a name for that. Think about the world of deep learning if you'd like. She says feature reduction. Yes, for the overall. But what about like just if you were to think about the M times X part? What if you were just to think about that? Give you another 10 seconds here, guys. Sarvesh says shrinkage. You and Yassine are getting close. All right, so Yassine and Sarvesh are very close in shrinkage, and the actual term is known as factor fading. Okay? That's the term that you want to remember. Like I said, I asked this in interviews. What is factor fading? And that's what you're doing when you're approaching zero with your coefficient. Or with your weight in general, right? As you're approaching zero, you're also taking your x value, your independent value to zero. And then that whole portion of your entire formula basically fades. That's why it's called factor fading. Because now it just becomes zero, right? Everything becomes zero, right? And why this is important, why people pay attention to this, is because of it becomes more clear when you think about things like neural networks, right? Neural networks are a collection of nodes. And each one of those nodes is conducting these same type of calculations. What is your feature? How much weight are you adding to it? Multiply those two together, right? And one number multiplied by a smaller number results in what? An even smaller number, right? So, or especially when we get down to the decimals, right? When your coefficients are decimals, right? All you're doing is taking that down to 0, 0, 0. But factor fading is what you want to remember. This is very common in all, it's common in all models, but it's particularly common in neural networks. Because you can start taking down all these nodes. You're doing so much multiplication that all these nodes are now approaching zero. And if all your nodes are zero, then do you have a valid layer in your neural network, right? Same thing here, right? What happens if everything in your y equals mx plus b is zero? Then you don't have a model, right? You can literally, like, the way I heard it explained was that you can multiply yourself out of existence, basically, right? I thought that was funny, and I still think it's funny because it's accurate, right? You can multiply yourself to death, basically. So this is really important to kind of keep an eye on this, right? Yeah, Ashish has vanishing gradients. Yeah, that's another name for it. Also, you can also heard of vanishing gradients. Factor fading, vanishing gradients are basically synonyms. But as we get as we do more deep learning, right? We'll probably do that beyond this book. But as you do more deep learning, that's something you have to be aware of. That the approach to zero does indeed help you mitigate those features, but you can also run out of features, right? You're completely negating that feature as you approach zero, right? So keep that in mind, guys, okay? Eshalmin says, in deep learning activation functions, yeah, it's part of it. It's part of it, Eshalmin. Eshalmin says, oh, I never knew it was named that. Yeah, factor fading is the, it's the appropriate name, right? You want to sound sophisticated in your interviews, right? So factor fading is what you want to talk about, okay? She says, I haven't heard such terms, or factor fading makes sense. Yeah, you're going to find it in some of the neural network books out there. If you're reading the good neural network book, right? They talk about factor fading. Very important when it comes to neural networks. Factor fading, never heard of it. Now you have. Patrick, I never heard that phrase. Amazing. That sounds fun. Okay, look, you guys are having a good time with this, and I am too. It's good for you guys knowing this. Okay, so here, I'll give you guys the extra credit question. Don't answer this now. I don't expect any of you to have this answer. Okay? But in the Discord this week, if you haven't joined, our Discord is very active. We're having some great conversations on there. We have 88 people that are in there. We're having a lot of really good stuff in there. So if you want to join our Discord, put your answer in the Discord, okay? Because this is another question I ask in interviews, okay? What is, or what makes an LSTM neural network different? Hint, hint, I just asked you about factor fading. Okay? So don't put the answer in the chat right now. Don't Google it. Don't cheat. Right? Well, I guess you have to Google if you can do your own research, right? But don't put it in the chat. Go ahead, join the Discord, put it in the Discord. That's the extra credit question for the week. How is an LSTM neural network different? Hint, hint, I just asked you about factor fading. All right, so go look that up. That's a good one. Rex, thank you so much. Rex is putting the Discord link in the chat. Good catch on that, Rex. So if you haven't joined the Discord, there's the link. But give me your answer in the Discord so that everybody can benefit from it. But if you're interested in this topic, factor fading and LSTM neural networks, tell me about that. Okay. All right. So next chart, because you guys have got this one. So we just agreed that we can modify our coefficient to get to 0. But how fast? How we kind of need like a volume meter on that, right? A throttle on that. So now the authors, and this chart is direct from the book, right? I always give credit to the authors. This chart is from the book. They're introducing a new hyperparameter called lambda. And lambda is the speed dial of how quickly we're taking our coefficients and stepping them down to 0. And you can see that here, right? Because you can see how at different levels of lambda, it's going to have a different effect on each one of these factors. So each one of these lines represents a factor: income, limit, which I'm assuming is like a credit limit, their credit rating, and then whether they're a student or not. So lambda at different levels has different effects on how quickly these values, the feature coefficients, approach 0, right? So lambda gives us a hyperparameter to figure out what is the appropriate level to reach 0 for each one of the coefficients. So that's going to be important for us because if you remember from last week, anytime we're talking about a tuning parameter, we're also talking about basically something we can test with, right? It becomes an item for us to test with. So that's why this is important because, okay, we just agreed that going to 0 is effective because it basically nullifies the coefficient, it nullifies the feature, excuse me, right? The closer you get to 0, the smaller the effect of the feature is. But how fast should we get to 0? Is it a slow step down or is it a fast step down? And that's going to vary for all of these, all the individual features, and that's what lambda helps with. Okay. Ashish says, is it different from the learning rate? You know, Ashish, that's a good question. I think that learning rate and lambda are similar in theory, or in purpose, I should say. The purpose of it is the same, where they're still trying to help you converge on the ideal model or on the better model. But they're probably not the same from a mathematical perspective in what they're trying to find. Right? A learning rate for a neural network has a very specific purpose, whereas lambda is really just kind of another tuning parameter for you to use. But it's not really converging on anything per se like a learning rate would. So in purpose, I think they have very similar definitions. But the underlying execution, I don't think it's accurate to say that lambda and learning rate are the same. So I hope that makes sense. All right, let's keep going here. So Lasso tries to address one of the problems of ridge regression. The challenge with ridge regression is that they just approach 0. They don't actually reach 0. right? So you're still going to have 10 features in your model. It's just that some of those are going to be very close to zero. So you're still exercising some computational power there. But Lasso actually helps you eliminate entire features. So Lasso will help you get down, reduce the effect of those features, but also will tell you when you're actually at zero and drop those features. Because at zero, your feature means nothing, right? 0 times anything equals 0, right? So it's important for the model interpretation side of it, because in ridge regression, you can never say that the model that the features have no impact. They may have minimal impact, but not zero impact, or eliminated from having impact. But you can say that with Lasso. Lasso, you can say the Lasso process completely eliminated the effect of this feature. Okay? So that's the difference between ridge regression and Lasso. Ridge regression will let you approach zero, but still keep the features, where Lasso will take you all the way to zero and allow you to eliminate the features from your model. Harsimar, nice to see you. I don't think I've seen you before. What language is this? I don't have any languages up right now as far as programming languages. But you're welcome to join us on YouTube if you want to see it in a widescreen format, maybe a little bit easier for you to read, okay? But thanks for joining us. All right, so are we clear on the difference between ridge regression and Lasso? Ridge regression will let your coefficients approach zero, but not actually drop any features, so you're still going to have like those bigger models. Whereas Lasso will let you go to zero and will let you actually eliminate features, because once you reach zero, then that feature is nullified, right? There is no effect. That independent variable does not have any effect, right? So we're clear on that? Give me some feedback in the chat there. I think this might be our last slide. Yeah, I think this will be our last slide before we actually go to code. What do you guys think? Are we clear on this? She says we can't use ridge regression as a feature selection process. You can. You can. It's just that you won't eliminate any of the features, right? You'll get some features that are very minimized on their effect, but ridge regression will never actually reach zero, where Lasso will. Okay. Ishalmin says, can you repeat it once more? Sure, Ishalmin. So I'll start from the beginning. So previously, we talked about what features from a data set would be valid, right? And we talked about the feature selection. Ridge regression and Lasso say, yeah, that's good, but you can also adjust the coefficients to determine which features are valid or not, right? You can play with the coefficients to determine whether that independent variable actually has an effect or not. So now the difference between ridge regression and Lasso is whether they actually reach zero or not and close out that feature and essentially drop that feature. Because any feature with a zero coefficient isn't going to have an effect on your model, right? So that's essentially what we're doing. The first half of this class, we talked about how to select those features. And the second half, the ridge regression and Lasso, is more about the coefficients. And adjusting coefficients has the same effect as picking your features, because they either will or they won't have an impact on your target variable, on your predictions, right? So I hope that makes sense, Ishamin. Rahul says, yeah, going great. Okay, Patrick, makes sense to me. Good. Leo says, is this process related to the error function? It is, in the sense that remember, your error function is always like what you're measuring against. I changed this to the model. Did my error function improve? That's always your measuring stick, right? Did my MSE improve? Did my adjusted R-square improve? Okay, it didn't. Okay, let me go rerun the lasso and see what coefficients I get then, right? Maybe adjust the lambda this time, right? You're going to use a different lambda, and you're going to say, okay, let me try this lambda value. Okay, what happened to my error function there? Right? The error function is always your measuring stick, and you're always trying to improve on that. So yeah, Leo, that's the correlation to it, right? That you're always trying to improve against the error function. Right? In MSE, you're trying to get it lower. Adjusted R-squared, you're trying to get it higher. But yeah, that's the relationship to them, okay? But lasso can help in feature relationship. Yeah, of course it can. Both ridge regression and lasso can help. Lasso could arguably be better because of the stuff that's on the screen now, right? For the model interpretation and the processing power. But they both can be used for feature selection, yeah. Michael says, please, can you come again about lambda? Good to see you, Michael. Can you come again about, yeah, okay. So with lasso and ridge regression, we agreed that adjusting the coefficient has an effect on the model, because that determines the weight, the power that you're giving to the feature, right? So lambda is a volume. How quickly, or by how many steps, or by what degrees are you going to adjust that coefficient? Are you going to do it slowly, or are you going to do it fast? Right? So that's what the lambda does. It serves as a volume dial for you to say, okay, well, what if I just slowly adjust the coefficient? What happens if I do it quickly? So that's how you should be thinking about, right? Because lambda, in theory, could be an infinite value, and the authors write about this in the book. You could, in theory, have any value of lambda that you want. So that's what you're testing. You're testing like how it shapes that curve, right? So if I go back here, let me go back a couple of slides. So these curves, the shape of these curves is essentially determined by the lambda, right? The lambda in this case is the independent variable against how these curves look. Are you going to do it quickly or fast? So that's why it's an effective tuning parameter, because it gives you a lot of things to test, right? Who's to say what the value of lambda should be? I mean, you can see here, this is a pretty wide scale, right? That they're using down here. And it's a massive scale, right? But who knows what that value should be? That's why it's a hyperparameter. But that's good though, right? Because hyperparameters lead to more testing, right? Hyperparameters is essentially what enables us to run tests as data scientists, right? So it's a good thing that it exists. So I hope that helps, Michael. Hamed says, based on the formula, the difference between lasso and ridge is the first one is using absolute beta and ridge is using beta squared. However, does the difference translate into a feature for lasso? It does. It does, because lasso will reach 0, whereas ridge regression will not reach 0. And the authors pretty much explain it in those terms. I'm paraphrasing what they say, but that's the difference that they cite between ridge regression and lasso. Okay? Yashal says, thank you. Good, Yashal. I hope that helped you. Yassine says, can we use lasso as a method to identify the relevant features, or would it be necessary to use stepwise selection or other methods when discussed? Great question, Yassine. If yes, is the only one to know which one to use as experimentation? Yeah, great question. These aren't exclusive, guys. These aren't exclusive. You can do all of them if you want. In some cases, you might want to do all of them. Remember that confluence we talked about? This could be a form of confluence. And you could say, I'm actually going to run 2 processes. I want to use forward stepwise selection, and then I also want to use lasso, and I want to see what features I end up with. I want to compare the two models. And if both processes come up with the same answer, then guess what? You just created a model you can have a lot of confidence in, right? So this is that iterative process I'm talking about, guys. Where you can say, well, okay, yeah, that looked good, but let me try this over here too. Okay, that looked good too. Let me try it against cross-validation now, right? There's nothing stopping you from doing that. So I love your question, Yassine, but definitely do not think about it as exclusive to each other. It's not a choice. These are just options. Remember, guys, this is all a big toolbox, right? Everything we talk about, everything you learn in data science, it's just a big toolbox. And you as the scientist are deciding which tools to use. And there's nothing stopping you from using more than one tool. Right? So yeah, definitely do not think of it like, oh, I got to choose one or the other, Yassine. It's not like that. You can choose whatever you'd like. All right? Leo says, okay, it makes more sense for me now. Thank you. Good, Leo. I'm glad. Michael says, okay, it's clear now. Thanks, Dennis. Hamed, thanks. Okay, cool. Cool. You guys are getting it. You know, any other questions, let me know. But yeah, it sounds like you guys are getting it. And yeah, I'm just really glad Yassine brought up that point because it's not exclusive, guys. You can use multiples of these. You can run these multiple times. And you know what? In some cases, you will run them multiple times because you'll be working on a project. You've met with the stakeholders. You've talked this and this. You've done your modeling. You've got your feature selection. You're on your way to picking a model, and then you get a phone call. And the phone call is the stakeholder telling you, "Oh, you know what? I just realized I sent you the wrong data for 2023. I mislabeled the file. That was old data. Here, let me resend you the 2023 data." Well, guess what? Now you got to start all over. Right? And that happens, guys. Or you find a new data set that can help your current data set, right? You find like an enrichment data set. Well, now you got to take all those new factors into account, right? You can't ignore them. So now you got to start that all over. And because the stakeholder gave you new data, you can't assume that it's going to be effective for the way you did for your current model. So you got to restart all over too, right? So you're always testing, always trying different iterations, always being open to new ideas, new data, because it's going to happen, right? So it's not exclusive. These are just different tools, and you're picking some, you're using, some twice, right? There's a lot of ways to do it. All right? And by the way, that's not just for this lesson. This is for everything. Everything you do, you can do it in multiple ways. All right, so let's keep going. We've already covered this slide. This slide here, again, is just explaining lambda, right? You can use it for both ridge regression and lasso. That's important. And it's a dial. How quickly do your parameters approach zero? That's all it is. It's like a speed dial, a volume dial. You can think of it like that. And then the last thing here is very important, is that with my read of the book, and you guys can correct me if I'm wrong, but this is the first time the authors mention grid searching and how you can use it in conjunction with cross-validation. Grid searching is very, very important to understand as a concept. And it's not very complex. Grid searching is just a collection of all your hyperparameters. We know that a hyperparameter can be used to tune our model, but now there can be, but a project can have multiple hyperparameters. And you want to try all of those hyperparameters during your training process. So just as before, this becomes permutations, right? If you have a hyperparameter that has 5 different values that you're testing, and then you have a second hyperparameter that has 7 different values that you're testing, well, now you just identify 35 different experiments, right? Because they're a permutation of each other. So that's all a grid search is. But I think it's notable that this is the first time the authors have mentioned it, because grid searching is a huge part of data science. When you hear about the models taking a long time to train, or that you train a model and then you kind of have some time off because you're just waiting, it's usually because of a grid search process, right? Because you want to try multiple values for each parameter, and you're going to have multiple parameters. Well, that just becomes, a bigger and bigger process with each addition, right? So Grid searching, super important. It's not exclusive to anything we've talked about. You're going to find it in a lot of data science. Some libraries will already have grid searching built into them. Others will not. So you're going to have to do it old school and like do it via loops, right? Because it's essentially a big collection of loops. So yeah, that's just one of those things that you're going to do in data science throughout your entire career. But I wanted to point it out because if you do want to read a little bit more about it, they don't talk a ton about it. But this is the first time that the authors mention grid searching, and it's just notable because of how much you'll be doing of it in real world data science. Okay. All right. Let me see what's next here. Okay. So this is our last slide. Yeah. So my last slide is about PCA, and some of you already asked about PCA, and there is indeed a discussion about PCA in this chapter, but I want to save PCA because from a practical perspective, everything we just discussed, from what I've seen in the projects that I've run and executed, you're going to get pretty far with subset selection and stepwise selection. You're going to do just fine with those. PCA is much more relevant when you're talking about unsupervised data. Okay. And that comes much later on in the book, and I want to save it for that because I think we've covered enough. I mean, we're almost at 2 hours now, right? But we're going to talk about PCA a lot more when we talk about unsupervised data because I think that's where you're much more likely to use it. There's so many good ways for supervised data to be handled that you really, on a practical basis, you really shouldn't have to rely on PCA. Okay? So that's it for the slides. Now we're going to get into the coding side. Any questions before we start looking at getting ChatGPT to help us? Patrick says, as we run all these experiments, the time spent will stack up. How do you estimate the time you'll need for all this to report to stakeholders? You don't, Patrick. So I try to avoid making promises to stakeholders on processing time because you really don't. That's just the plain answer. You don't know how long it's going to take. But you want it to take a long time, right? You want to give it what it's going to take because you don't want to take shortcuts and miss a possible good model, a possible permutation of a good model just because, you gave a bad deadline or something like that. Okay? But the answer is that you don't. You really don't know. All right. So I think we're ready to move on to some code, yeah? So as always, we have our framework. What is the result we're optimizing for, right? We're going to pick a benchmark. We're going to be level 2 data scientists prompting an LLM for assistance, right? Even at the entry level positions, you're going to need to use AI tools. So we're going to start preparing now. And we're going to be code editors, not code writers. We're never starting from a blank screen. We're always going to make sure that we start with code that ChatGPT gives us. And then we're going to make adjustments from there. We're also going to work in a professional environment, which means no notebooks, right? Notebooks is not how professional data science is carried out. We're going to find an appropriate data set that ChatGPT gives us. And we're also going to try using ridge regression for a model, right? So, wait, are we going to do ridge regression or subset selection? Yeah, you know what? I'll leave it to you guys to figure out how to do subset selection. But otherwise, we're going to use ridge regression in our example. If we have time, we'll do more. But we're going to use forward ridge regression to try to come up with a valid model. Okay? Yeah, let's do that. So, we're going to leave our deck and we're going to start going to our VS Code. I already have VS Code set up here. I don't want to update. I should have it big enough when I bring up the code that you'll be able to see it. And then we're going to use our ChatGPT. So just as before, we're going to say, we're going to tell ChatGPT what it is we want to do. Let me know if you need me to make anything bigger on the screen, please. So we're going to ask ChatGPT what frameworks it knows. So it's telling us it can use scikit-learn, stats models, Mix10, PyCaret. And it's giving us an example by scikit-learn. It's loading the Boston dataset, which is also one of the datasets that's used by the authors in Introduction to Statistical Learning. And it's telling us what the data and targets are. It's using a cross-validation approach. You can see how it's already declaring the cross-validation folds there. And it looks like it's giving us an adjusted R-square scored. So I think this is a reasonable piece of code. Let me bring that up. Let me bring that out to Visual Studio. Yeah, maybe you guys can see it a little bit better. I want you guys to tell me what you think about this one. So this is going to be called ridgereg.py is what we'll call it. What do you guys think? Does this look like a reasonable piece of code? Visual Studio is telling us that this might not be a valid library. It looks like it could be a missing imports error. That's interesting. What do you guys think? It's giving us a test size of 0.2, so that's an 80-20 split, a train test split. It's using forward stepwise. I bet that if we do forward equals false, it would do it backwards. So we might want to try that. Scoring. This is where we're selecting our metric that we want to measure against, right? Which is a good thing. But overall, I think this seems like a relatively reasonable piece of code. What do you guys think? Give me some feedback in the chat. Okay, so Faiza says that yes, it's a reasonable piece of code. Okay. Leo, I'm going to come back to your two questions. Okay, remind me at the end if I don't get to them. So I want to make one change here to this code. Is notice that it gives us a selected features, but it doesn't tell us what the initial features are, right? So I'm going to ask it to lay out the initial features. That way we can kind of see a difference between what was available versus what was selected. And then we also want to see the coefficients, right? We want to see how impactful each one of the features is, right? So let's go ahead and show that also. Also show the coefficients for each of the features in the final model. Okay, let's see what ChatGPT does with that. All right, it's going to show us. Okay, so you can see that it modified some items, right? It shows, it added this line here for the coefficients. And then it added this line to show us the initial features and the selected features, and then the coefficients of selected features, which seems great. I think that's going to be good. And then it gives us an adjusted R-square score. So I think this looks good. We're going to copy this. We're going to take it back to our Visual Studio. And then we have this, right? We still have to deal with this error. But ChatGPT can help us with that, right? And now we just need to get the pip install commands, right? Okay, so there it is. So the one that we have scikit-learn installed, obviously, and we can tell that by the errors that VS Code is giving us. What we don't have is this MLXtend library. And ChatGPT gives us the answer. Because again, we're editors, right? We're not writers. We're not researching anything. ChatGPT is doing it all for us. Pretty sure I already have pandas. So the only line I need here is pip install mlextend. Okay? So now I just need to go to my console. Right? So, and again, so we're not using notebooks. We're using our own IDE, and we're using a console. This console happens to be running locally. As you might do in development, but I could easily be connecting to my DigitalOcean droplets or a high performance computing lab like you would in a corporate environment. The bottom line is that we have to know how to manage our projects and our code from a console application. From a command line interface. Very, very valuable skill to have, guys, okay? So pip install. Oh, come on, Dennis, I can't type today, huh? Install mlx, I think it was xtend. So that looks like it's going to run just fine. And yeah, successfully installed everything. So I think we're good here. So I think that we are ready to actually run this code. So let's go ahead and do it. Let's see what we have in our directory. There's our file, ridgereg.py. So now we're going to run it. ridgereg.py. So it looks like we have a little bit of a problem here. Load Boston has been removed from scikit-learn since version 1.2. Okay, and it's giving us the rationale for why it was removed. In this special case, you can fetch the dataset from the original source. Or it's giving us an alternative here. Okay. That's very interesting. I'd never seen this before, guys. I recommend that all of you read this because it's basically telling you that the Boston dataset has been eliminated because the researchers made an error in how they collected the data. That's fascinating. So they themselves, scikit-learn, is discouraging the use of the dataset. That's really interesting. Wow. Okay, but the good news is that it's giving us a lot of alternatives. It's letting us still download it via pandas, or there's a California housing dataset. And it's giving us the code. So, you know what? This is one of those things where you have to roll with the punches, and you have to just kind of work with what you have, right? So I think this will be a good exercise for us to, again, code editors, not code writers. We can edit what it gave us here, right? So here, we know how it's loading the data set. So we can go ahead and swap this out. Oops. So we want to move this import up here. From sklearn, import fetch California housing. And then here, housing is called fetch California housing. I am tempted to just swap this out. If we were to change this to data, that should give us the same. It should allow us to use the rest of the code. Now, I'm assuming that the California housing set has something named data and something named target. I think that's a safe assumption. But I don't know, right? There's a good way to check that, right? A good way to check that would be to see what this data frame looks like. Because here, ChatGPT has converted everything from the Boston housing data set to the California, to a data frame. So the quick way to do that is to go ahead and view it, right? So print x_df.head. And we're going to just break the code here. Oh. I think that should be good. Why is it not? Nope, excuse me. Yeah, let's just go ahead and print it there. Let's see what this gives us. It's possible that it'll error out before this, but that's okay. Oh, did I not save it? I probably didn't save it. I have that. Oh, okay. It wants to get rid of this too. Got it. All right, good. Good. So that swap worked, right? Pretty easy to swap. Now we're using the California housing set, and we asked for the head to be printed out, right? So that's what it looks like for California housing. It's telling us what the initial features are, right? In this line here. And the selected features is just one short, right? It dropped, looks like it dropped population. And then it's giving us the coefficients for each one of those. And it's giving us the R squared. Sorry, I didn't mean to bring. What do you guys think about this? We have an R square scored. We have some coefficients. We have what the model should be. What do you guys think? Any thoughts on that? Hamed, so Hamed writes, can we take a peek at the coefficient of population? We can't, Hamed. The coefficient is 0, right? Stepwise regression has told us that that population shouldn't be part of the model, so there is no coefficient per se, right? Patrick says, looks good. Maybe some small coefficients for average. I'm going to push back on you, Patrick. Does the R-square scored agree with your assessment? Or does anybody agree with Patrick? What do you guys think? So I would have to say that I'm not impressed by this as our first model. The R-squared is kind of terrible, right? That's not a great R-squared score. Just in case you can't see it on the screen, it's 0.575. Okay, Michael says, can you explain the results at some... Yeah, no problem, Michael. I agree with Patrick. R2 doesn't mean things are good. It's not good metric and a lot of features are involved. We should look at it. But this is an adjusted R2, Yassine. It's not listed as that, but it is an adjusted R-square. And Patrick, yeah, Patrick, I like your revised answer, right? R-square isn't very high, so maybe a little can be said about the accuracy of the coefficient. Yeah, I mean, this isn't a great model, right? There's two things that tell me it's not a great model. One is the R-square score, right? And two, it's basically saying that we need just about everything in the model except for population. Right? So we really didn't reduce features a whole lot in this process, right? Like what did we really reduce? Like we really didn't, right? So that's the part that's kind of getting to me. Because it's basically, using everything in the data. Sometimes that's the case, but not too often, right? Rahul said, I think he meant a population would be considered. But it has been considered, though, Rahul. It has been considered through the process, through the stepwise selection, right? And it has been eliminated. And if it's been eliminated, by default, the coefficient is 0. So it has been considered. Or if we were to do this via lasso would include, well, via ridge regression, it would include it, but it would include it as a 0, right? Or approaching 0, right? Hamed says, what is a reasonable R-square score that we might expect? So Hamed, you want your R-square to be approaching 1, a value of 1.0. So 0.57, there's room for improvement, as we say, right? So 0.57 is really not anything to get excited about. It might make for a good baseline score, right? I mean, look, every initial test has a good value for baseline score. So we can at least say that, right? We have a good baseline score to work from. But at 0.575, you want to keep on exploring, right? You don't want to end your experimentation here, yeah? But that's how I'm interpreting these results. But the thing that we should also note is we should also be happy that we got to this fairly quickly, right? ChatGPT enabled us to write this code in a relatively quick manner. I mean, yes, we ran into some problems with the Boston set, but that's not ChatGPT's fault, right? ChatGPT just picked the bad set. But, we're using a different data set, but, we still got to this in a very quick manner. And like I said, the initial model still has value for a baseline, because now we know that everything we do now has to be better than 575. That won't be hard to achieve, but we have a good baseline to work from. Yassine says, can we look back at the code? Sure. The code is actually fairly straightforward, right? I'm going to get rid of this print statement just to kind of compact the code a little bit. But all I was doing was just checking our data frame, make sure the data frame looked good. But yeah, I mean, the code itself is fairly straightforward. We're loading the California housing set. We're declaring our X's and Y's. We put it into a data frame. We're splitting the data with an 80-20 split. And then we have our ridge regression there. And then we're declaring it to be a forward ridge regression. And then we're scoring with the R squared. And then we're also using a cross-validation approach too. And then down here in the fit function, as we've discussed before, the fit function is where most model or most libraries are kind of doing the work of fitting the model. And then we look at the features, we look at the selected features, and yeah. So I think the code is very reasonable for what ChatGPT gave us. Certainly saved us a lot of time, right? It wrote 51 lines of code in very little amount of time. So let's try Lasso. Yeah, I'm curious. Let's see what Lasso tells us. Maybe Lasso tells us the same thing, maybe it won't. So now we gotta modify the expectations for what we get from ChatGPT, right? So all right, let's see what ChatGPT gives us here. I think we wrote a reasonable prompt there. Okay, it's using California housing. It's using a lasso down here. And I want to compare something real quick. Yeah, okay. Yeah, I think this looks reasonable. Let me bring up a new file. Let's see what Visual Studio thinks. Visual Studio says we have everything we need. So, couple differences that jump out at me, right? Basically here, everything is the same, right? Here, we are declaring a use of lasso instead of ridge. If we look at our previous code, we used ridge. Now we're using lasso down here. So that's going to be our biggest difference. But otherwise, everything else down here is also the same. It's using a lasso fit, right? And yeah, I think that's it. All right, I think this is good to run. What do you guys think? Anything else jumping out at anybody? I think this is perfectly reasonable code for us to try. All right, let's try it. Well, I'm going to clear the screen just to kind of help us, keep everything easy to read. So Python, lasso. And this time we're not going to see the data frame. Patrick says run it. Yep, I agree, Patrick. Oh, wow. What do you guys see? We are at 2 hours and a half, approaching 2.5. You guys are crazy. I don't know why you guys stay here that long. You guys are Iron Men here. I've even run out of water over here, guys. All right, what do you guys see on the screen? Yep, Lakshmi is saying r squared is 0.28. Are we happy with that or are we unhappy with that? What do you guys think? Patrick says, oof, much worse r squared even if we reduce our features. Yeah. Yeah, Patrick, that's exactly the observation, right? Look how much our features dropped, right? We went from all these features to only 2. Ridge regression told us we needed everything but 1, right? And the r squared here is terrible. 0.28 is a terrible r squared score, right? Lakshmi says very less. Yeah, it is, Lakshmi. Yassine got rid of most features and one has very low coefficient. Yeah, that's exactly right, Yassine. Look at the house age coefficient. It's like basically 0, right? 0.0059. I mean, that's basically 0. And even median income is just 0.148, right? Which is not great. Like it's a valid feature, but not very powerful feature, right? Not a very strong indicator, and that's reflected in our r squared, yeah? Hamed says, that's interesting, unhappy for sure. Yeah, right? So guys, this is part of that testing, right? We have a baseline. We know what ridge regression gave us, 0.575, and now we're below that. So this is terrible, right? This is not a new baseline. Our current baseline remains. Or maybe we'll get above that. And now that becomes your new baseline, right? And so on, right? That's kind of how you develop that experimentation mindset. Lakshmi says, that means Ridge is doing better. That's absolutely right. That's absolutely right. But let me ask you guys this, though. Is there an argument to be made that ridge regression also has a fault because it's using too many coefficients? We only dropped, too many features. We only dropped 1 feature, right? Is that a problem? Maybe, maybe not, right? Yassine says, can we try to use the stepwise with linear regression? Yeah, you could. Yeah. That's a great take-home exercise, Yassine. Lakshmi says, so now what? And how are we going to improve that? Yeah, great question. These are all great take-home exercises, right? So just so we're clear on this, guys, because we're having 2 really good questions in the chat right now. Yassine says, can we try the stepwise with linear regression? So Yassine, I'm interpreting what you're saying. If I'm incorrect, let me know. But what Yassine is saying here is, okay, ridge regression told us that these are the 5 coefficients that are good, and it gave us, the 5 features that are good, and it gave us the coefficients. So create a model from that and go put that into a linear regression approach. That's a totally valid way to do it. I love the way you're thinking about this, Yassine. That's exactly how you build models on top of models, or iterations on top of iterations, rather. Right? That's exactly the mindset you have to have to be able to say, yeah, I got this, and it's telling me this is a model, but let me go try it over here. That's totally valid for you to do that. That's excellent, right? Lakshmi, so now what? How are we going to improve that? This is the work. This is the work of being a data scientist. We build upon this by trying other experiments. We did forward stepwise. What about backward stepwise? What about lambda? We haven't adjusted the lambda parameters yet, right? That's a hyperparameter tuner, right? So let's do that, right? Let's start coming up with those experiments. Let's start adjusting those hyperparameters. Did we do better? Did we do worse? What's our baseline? Oh, okay, that did better. Okay, that becomes our new baseline. How can we improve on that? Right? And another thing, Lakshmi, is we totally jumped ahead to ridge regression. We didn't even do subset selection. You could be doing subset selection, right? So this is the work, right? What you just said, the question you just asked, is the fundamental work of a data scientist. And this is where we come back, guys, to when I tell you data science requires creativity. This is a form of creativity. For you to be able to say, oh, okay, yeah, what if I combine this and adjusted this lambda and you know, this is the work, right? This is where the experimentation side comes of it. So Lakshmi says, yeah, true, lambda could be just, yeah, it can, and let's do it. I want to quickly address one. Ali Raxa says, sir, can I join your group? Yeah, of course, Ali, anybody's welcome. You're on Instagram. Feel free to jump over to YouTube, Data Science with Dennis. You can see a better view, but you're welcome to just follow along on Instagram if that's more convenient for you. But yeah, but welcome. You know, I try to make my content as inclusive as possible. So Lakshmi, yeah, let's try it. So I haven't done this type of regression with scikit-learn. I'm assuming that this alpha value is their equivalent of lambda. Let me see if there's it just says a parameter. There's no description. Sometimes there's a description. But yeah, so let's take Lakshmi's suggestion, and let's try a different value for lambda. We'll go half, and then we'll also double it, right? Just as an initial experiment, you know, kind of get a feel for the numbers. Just play around with it, right? You don't have to be scientific about it. Just get a feel for it. Kind of see where the data lies. Okay, so we adjusted that, and I think we're ready to run it. Okay. What do you guys think? 3 things are jumping out at me. 3 things are jumping out at me. What do you guys think? I see 3 things that are important on this screen. Yeah. What do you guys think? Mo Kata says, what is lambda? Lambda is the tuning parameter that's available for us in ridge regression. And lambda determines how quickly we approach 0 with our coefficients. So it's a volume dial we can play with, okay? Oh, Joseph. Joseph's asking an amazing question. Joseph, I'm going to come back to your question. You know what, Joseph? I'm going to close with your question. You're asking an amazing question. Okay, so Lakshmi says it's better. Okay, Lakshmi, why? Or tell me what's jumping out at you that makes you write that conclusion. Ah, Patrick. Sorry, Lakshmi. Patrick beat you to it. Yep, that's exactly right, Patrick. We're not better than our ridge baseline, but we are better than our lasso baseline, right? It's a great improvement on the lasso baseline. But yeah, look at this. Look at the average occupant. That definitely caught my eye. This line is lasso at work, right? Lasso correctly identified that average occupation should be taken down to 0, right? So I think that's really interesting. Yassine, no, population was not eliminated, but it's a very, very small number, right? Yeah, look, I mean, look at that. That's that's 9.9 to the negative 6. That's basically 0, right? So yeah, seen it wasn't eliminated. It was just it was factor faded, right? It vanished on us, right? It's a vanishing gradient, right? Um, yes, Yassine, it's present, but it's a high negative coefficient though, right? So it's a very small number. Even house age is also a very small number. But our R squared is actually, improving, right? It's not great, but it's improving over our first model. So this should make you curious, right? This is the curiosity, the creativity, okay? So now I'm thinking, what happens if we double it, right? Let's go the other way with lambda, right? Yassine says, I thought the coefficient was... Yeah, Yassine, maybe it's small on your screen or whatever, but it's a negative 6. So it's 9.9 to the negative 6. So it's a very, very small number, right? Virtually 0, right? But let's keep on playing with lambda, right? What happens if we go the other way with lambda? We were at 1. So let's try 2.0. Oh, look at that. Oh, wow. Wow. What do you guys think? Wow. This is terrible, right? I mean, I'm not even going to wait for you guys to answer. I mean, this is terrible. I mean, this is not good, right? But we've learned something here, right? Remember how we talked about hyperparameter tuning? And we talked about grid search? And we talked about how grid search, you kind of pick a series of values that you want to test, right? I think that we have received a lot of information to help us define our grid search. And remember, we talked about how grid search can be computationally intensive, right? So we want to make sure we kind of help ourselves, right? So here's the question for everybody in the chat. All right, everybody can participate. No one's going to call on you. Just give me a 1 or a 0. For our grid search, well, first of all, let's agree that a grid search is the next reasonable step, right? Because clearly there's an effect here, right? So should our grid search be between 0 and 1, or should our grid search be between 1 and 2? Right? So in code, you would want to say something like alpha test range equals... Oh, come on, Dennis. I can't type today, guys. Sorry. 1, 1.3, 1.6, 2.0. Alpha test range should be 0.1, 0.3, 0.6, and then 1.0. So which one of these alpha test ranges do you guys think should be our grid search? Because this is what a grid search looks like, guys, right? You write your value, you put a list in there, and then you're going to iterate through all the values in that list. Which one of these test ranges do you think makes more sense? Give everybody a chance. You can just agree with another person, but I'm seeing some answers come in. But what do you guys think should be our test range for our grid search? I see 3 answers so far, but there's more people in the chat. So just, don't be embarrassed. Just give your answer, or you can choose to agree with somebody. Okay, there's another answer. Anybody else? Last call for answers. Yep. Yeah. I mean, Patrick, Lakshmi, Michael, Joseph, Hamed. Yeah, you're all getting the right answer. We've learned a lot, right? When alpha was 2, I interpreted the results as indicating the small coefficient goal was more important than the accuracy goal. We'll come back to that, Patrick. We'll come back to that. But yeah, I mean, we learned a lot in this, real quick test, right? Our alpha test range should clearly be between 0 and 1. And like I said, this is exactly how it starts. You come up with a list of the values you want to test, and then you just loop through all those values. And again, you're always measuring against the same baseline. So in this case, it's the adjusted R squared. Did you do better or did you do worse? That's it, right? You're turning it into a binary decision, right? But this is the type of testing. So Lakshmi, coming back to your question, this is what you do from here on in. This is the science part of you being a data scientist. Okay, I have my jumping off point. I kind of have an idea of where the model is headed. Now it's up to me, my creativity, my experience with experiments and creating these things to try different things. Let me try these grid searches. Let me run it through cross validation. Let me seek out more data. Let me talk to the stakeholder, right? This is the work. This is the work. So Joseph, and this is a great way to close here, guys. Joseph is asking, in terms of documenting the experiment process, when we are trying out different experiments, how do data scientists in industry keep track of different tests they are running? Yeah, great question. So in some cases, the libraries themselves will have ways for you to do that tracking. Like it'll do the logging for you. But that's not common. The more sophisticated libraries will give you that functionality. Not common. So you will have to come up with your own logging. So remember how I'm mentioning these loops that you're going to run through for these values in the list? At the bottom of those loops, you would write out to your own log file and say, okay, I ran this, and this was the R squared result. The key to that is that you'll also have to track the coefficients and the values for those coefficients. Because you always can't come back and say, oh, well, let me rerun this and I'll get the same results, or let me recreate this model. In some cases, you might also want to save the model itself. So if we look at the code here, the final model is called lasso, right? So you might actually want to save the lasso object locally via Python. So you're gonna have to do like a pickle, like a pickle file for this. Again, some of the more sophisticated libraries will give you a way to save the model. Not everybody does that, so you're gonna have to rely on a pickle file to save it and kind of maintain the state of that object, right? That's what pickle files are good at, right? So in some cases, you're gonna have to do that, Joseph. In some cases, do a combination of those, where I will do a save of the object as a pickle file, but then I'm also saving the information to a log file. That way I don't have to load up the pickle file every time I want to see it. Or in other cases, like if you're working with a neural network, the files are so big that you can't afford to save every file. So you might just save your best performing model, like your current baseline model. You might just like rewrite that over whatever the previous baseline was. I've had to do that before. It just depends on the size of your model. But again, this is where the rubber hits the road in terms of like the daily work of a data scientist, right? Like this is the work, what I'm showing you guys, or what Joseph is asking. You got to keep track of those experiments, right? And then on top of that, Joseph, to kind of give you a complete answer, when you finish all of that, you want to kind of have a summary of that, because that summary is what you would eventually present to your stakeholders. They don't need to know like every single iteration you went through and every single, lambda you tried and all. They just need to hear like experiment 1 was lasso and we ran this number of iterations and this was the result. And then the next experiment we ran was a ridge regression. Like those are going to be your experiment 1, experiment 2, experiment 3 to the stakeholders. But there's going to be like literally like hundreds, if not thousands of iterations behind each one of those statements that you do. Right? So those are the types of things that you're going to kind of like almost kind of learn on the job, right? Like that logging I just described, like there's nobody talking about that stuff, right? I mean, but I'm giving you that real world view. But that's what you have to do. You have to maintain your own logs, maintain your own models, like the state of the model via Pickle, and that way you can load it up again in the future. Because remember, that then becomes what you use at your prediction time, right? Because we haven't even talked about prediction time, right? But that's why you save those Pickle files, because that becomes the model that you now send new data against and start getting results, like start using the model, right? But you'd never know that unless you're also logging the results and knowing which one is the better R squared. So it just becomes like this combination of numbers that you have to track, and you have to kind of just develop your own style to say, oh, okay, yeah, this is what I want to save, right? So I hope that helps you, Joseph. Otherwise, go ahead and ask in the Discord, because it's really kind of hard just to explain that in just, one little session here. So let me go back to my broad view. Lakshmi says you cleared a lot of doubts today, taking too much to process from the session. You're welcome, Lakshmi. I hope it does give you things to think about, because I think, it's a really important chapter. Michael says, thanks a lot for the class today. Yeah, you're welcome. Joseph, very helpful, makes sense. Good. It sounds like you guys got a lot of it. I certainly got a lot out of it. This is like a little bit of a harder chapter to teach, but I think I got most of the points across. If not, you can find me on the Discord, and we can kind of talk about things from there and have the community help the community, right? All right, guys. So thank you so much. Wow, we almost hit 3 hours, 2:45. That's one of our longer sessions. So credit to all of you guys for hanging in there with me. Really appreciate it. And again, if you want to support my work, please consider buying First Year in Data Science. I've already gotten some 5-star reviews, so I'm really happy about that. Sales are picking up. So if you want to read more, I'd appreciate your support in that way. But thank you so much. Let me highlight that again. Rex kindly putting up the Discord link. If you want to join us on Discord, please do that. Lots of really good people in there. We're having a great time, so join us there. But thank you so much, everybody. I stream every day. We'll have a class again next Sunday. Until then, please take care of yourselves, take care of your families, and I'll see you next time. Hey, everybody. Good morning. How are you? It's Sunday, which means that it's time for our Introduction into Statistical Learning class. I hope that you're doing well. I'm doing pretty good. I've gotten a nice start to my morning. So I'm looking forward to spending next bit of time with you. Honestly, it's probably going to be a couple of hours. We haven't gone anything less than like 2 hours and 15 minutes, I think is as short as we went. And we've gone almost to 3 hours. So I don't know how long we're going to go, but we're going to have some fun today. I think we got some pretty interesting materials to go over. And we'll just kind of see where the class ends up. I've really been enjoying the interaction that we've had. The people in the chat have been really great about being constant participants and giving their views and things like that. That's really good stuff. That way we can learn from each other. I learned a little bit from you, and that's good. And, I think it just adds to the overall feeling of growth here, right? Because we should really be all proud of ourselves, right? I mean, this is the 5th session, and we are on chapter 7. So we are past the halfway point, right? This and 3 more sessions and we're done. And then chapter 7 is this one and 3 more chapters, right? There's 7 we'll cover today, and then 8, 9, and 10. So we are making some great progress on this book. Really proud of all of you guys. I know that a few of you have been here every single class, and I know that's and some of those people have been here for the entire time, for each class, which is a lot, because like I said, we go at least 2 hours. So good for you guys. And if you can't do that, that's okay. You can watch the replays on YouTube. You can come later in the session. Maybe you want to come like in the 2nd hour, or maybe even in the 3rd hour. Sometimes we are, going long. So yeah, so really excited to see where we end up today. I'm already seeing people across all the chats, which is fantastic. I guess I haven't actually seen anybody on the Instagram chat, but let me make sure I have that up. But yeah, Instagram is being a little bit shy today. So what I've also done for Instagram, guys, is I have pinned a message in Instagram that will take you to the YouTube view, the widescreen view, because for Sunday's classes, I think the widescreen just works a little better. Maybe that's something that I'll adjust sometime in the future, but for the purposes of today, I would recommend that you switch over to YouTube to be able to see everything, because I do share a lot on the screen. I have slides that I prepare. We do code and things along those lines, okay? And actually, speaking of slides, I have a lot of slides for us to go through the day. Lots and lots of slides. So I kind of want to get started as soon as we can. But yeah, looking forward to it. I have a feeling we're going to be at least 2 hours, maybe a little longer. We'll see. We'll see. I have a lot of slides to go through. A lot of interesting concepts. But at the same time, I have a feeling that today is really kind of like a visual day, right? I think that some of the stuff that we're going to be talking about is very visual. So it's going to be interesting to see how the class develops and kind of how our conversation goes, because I think there are a lot of things that are going to kind of make you think in a different way, or maybe just more in a visual way than we have so far, right? So before we jump into the slides, I do want to get started as soon as we can, but I do want to acknowledge the chat. I'm seeing a few people in the chat already, a lot of our regulars, which is fantastic. So starting off, Rohan, good morning. You're reclaiming your place at the very top. So Rohan, glad to see that you're here. Hope that you're doing well out there in India. I know, Rohan, you've been one of the people who stays for the whole class, so good for you, my friend. That's awesome. Joseph, one of our great moderators, says, "Happy Sunday, everyone! Excited about today's class." Yeah, Joseph, thanks for that. Good to see you, and I'm excited too. Today is maybe where we start talking a little bit more about the creative side of data science. So let's see where we end up today. Sarvesh, nice to see you. Sarvesh, I know you've been attending the classes quite a bit. Hello all, Sarvesh here from Mumbai, India. Welcome, Sarvesh. Hope you're well. I know it's late in India, so thanks for staying up with us. Rex, our moderator on Twitch. You can see the little sword icon that indicates that Rex is one of our moderators. I don't know why it doesn't do that for YouTube, but good day, everyone. Rex from New York City. Hope you're doing well out there in New York City, Rex. I think it must be beautiful out there right now, right? I mean, I heard they have some really good weather. Michael's another one of our consistent Sunday participants. Happy Sunday, Dennis and everyone. Hope everyone is good. Hope everyone is doing just fine. I'm speaking for myself. I'm doing great. So thank you so much. I was working on some of my hobbies yesterday afternoon. You got to have some hobbies away from data science, away from computers, right? So I was working on some hobbies, having some fun yesterday afternoon. So I hope you're doing well too, Michael. Leo says, "Good morning, chat. Good morning, Dennis." Leo, how you doing? Leo's also a great participant, not just here on our chats, but also on Discord. So if you want to check us out on Discord, I've also included the links in the chats. Really good community that we're building there. We are like over 120 people now or something, which is mind-blowing to me. Where did y'all people come from? Rahul, how are you, my friend? Hello, Dennis and Patrick. Happy to be here again. How are you guys doing? Doing well, Rahul. Thanks for asking. Yeah, I know you've been consistently attending the Sunday classes, so I hope you're getting a lot out of this. Lakshmi, good to see you. Good morning, Dennis. Morning, everyone. Hope you're doing well, Lakshmi. I know you're back again from last week. I think you were here the entire class last week, so good for you. Hello, Dennis. Rahul says, "Hello, Dennis. Happy to be here again. How are you doing?" Yeah, I'm doing well. Thanks so much for asking. I'm doing well. Really excited about today's classes. I put together the materials 2 days ago, and I think it's going to be a good class. Manoj, good to see you again. I know you've been attending a lot of the streams this week. Good morning, Dennis and all from Bangalore, Hasaragata, India. Hasaragata. I hope I pronounced that right. Well, good. Welcome, Manoj. I hope you're able to enjoy today's class. And I love the feedback from all of you. So if there's something in the class that you didn't understand, or something I can improve on, or something else that I could be doing better, just let me know. But I think the class conversations have been a great two-way street. where we can kind of talk to each other and participate, and just kind of, have a good time talking back and forth while we're learning at the same time, right? Okay, so just as a final reminder for anybody that's still on Instagram, you can find the pinned comment that I wrote that will take you directly to the YouTube view. That's going to give you the wider screen view, a little bit more convenient for you to see. But otherwise, I'm not seeing any more intros in the chat, so I'm ready to get started. So let's do this. I think this is going to be fun. Let me bring up my monitors. All right. So this chapter is called Moving Beyond Linearity. Why do we need to talk about moving beyond linearity? So I want to go into the next slide and let's kind of set the tone for what exactly it is that we're focusing on, right? And so far, everything we've talked about, for the most part, right, has been linear regression, right? So we've basically have covered, two major topics, right? We've covered linear regression, which is a form of modeling, right? And then we've also covered the features, right? How do you select features? So those are like the two meta concepts that we've covered. Selecting the features is kind of independent of anything else you do, right? You're kind of always going to be needing to select features. But linear regression is kind of a unique model. And the problem is that it's linear, right? It's assuming that there's a linear relationship somewhere in your data or in some combination of your data. But the reality is that we do not live in a world where everything is linear, right? So in this chapter, Moving Beyond Linearity, we're basically talking about different approaches or different ways for us to work with data that is not linear, because we don't live in a linear world. And in turn, that opens up the possibilities to work with more data and more features from that data. Because maybe there were data sets previously that you didn't work with, right? Or maybe there were some features that you disregarded because there wasn't a relationship there, but now you can find one. So that's kind of what we're going to focus on today, okay? So I want to highlight some of the really good work that's been going on in our Discord. So this here is part of a study from our Discord that was done by Yassine. And I saw that Yassine just came in. Hello, sir, Yassine from Fez, Morocco. Welcome, Yassine. You're just in time. Just in time to see your own work on the screen. So this is a chart that Yassine had brought up on Discord that was looking at the California housing set that we worked on last week, in the same class. So audience participation time, guys. Let's start right away with a question. Can one of you tell me which one of these is the linear relationship? Yeah, so tell me the row and then the number in that row. Which one of these is the linear relationship? I'll give you guys a minute to think about that. Where is the linear relationship here? Tell me the row and then tell me the chart in that row. Top row, bottom row, and then number 1, 2, 3, 4. Yep, thank you, Rex. Rex is pointing out that the Discord link has been pinned. I did that earlier today. And that's on Twitch. What do you guys think? Where's the linear relationship? Okay, so Leo is proposing bottom row, 3 and 4. Top row, first graph from Rahul. Okay. Yassine says closest one to linear regression is the first row, first column. Okay. So we got a couple people pointing to this one here, first row, first column. Anybody else? If this is your first time joining or you're shy about participating, you can just agree with another person. You don't have to, give a long answer. Just if you just want to agree with somebody, you can also do that. Anybody else? So later on, we're going to come back to this chart. But I would argue that there is potentially no linear relationships here, right? It's possible that there is no linear model to be had here. Are there other models? Maybe. Yeah. But I would argue that there's no linear relationship here. And I'm using this to illustrate that this is one of the exercises you should be going through during your feature selection. You should be plotting out some of your data and saying, okay, well, what does it look like? And that's why I'm really saying that, today is going to be really, really visual, right? Where you kind of have to develop an eye for these things and maybe be creative in a little way, in a different way, right? So we're going to come back to this, but keep that in mind, right? That don't try to force a linear relationship if there really isn't something there, right? Because if we go to some of the further slides, something like this, right? That's clearly a linear relationship, right? Not just because the black line is there, but if you just look at the scatter plot, right, at the red points, right, there clearly is a linear relationship, right? It has a very defined range and a defined direction for that linear model, right? I think we can agree on that. I mean, we've seen this chart before in a couple of the previous classes, right? So again, the authors acknowledge, hey, we don't live in a linear world, right? So they're giving us a series of nonlinear approaches. So they present us with polynomial regression, step functions, and then splines. And then we're going to talk about like two subsets of splines. There's regression splines, and then there's smoothing splines. And then the authors close out with local regression and generalized additive models. So I'm probably going to make this point a couple times to you during this class. But one of the things I also want you guys to keep in mind is I am very careful about the vocabulary that I use, especially, and I'm encouraging you to do the same, because regression is a method. It's a type of model. Linear regression is another, it's like a subset of that modeling. Polynomial regression is another form of that model. Ridge regression is another form of that model, right? So I want you to think about this because, and I say this because I see a lot of people who kind of just say, oh, it's linear regression. Well, it's not. It's regression. It just happens to have a linear relationship. So I want you to think about it as the umbrella is regression. And then linear, polynomial, stepwise regression, that's describing the relationships in the data. Okay? And I'm also saying this because this is kind of like that mindset and the vocabulary that kind of puts a little extra polish on your approach to data science, in your modeling, in your resume, and even in your interviews, right? It's regression methods. We've been studying linear regression. We're going to go on to study polynomial regression or stepwise or a spline regression, right? And also you'll see that in some of your classes, right? You shouldn't really have a linear regression class, but you're probably going to have a regression methods class if you look at most curriculums out there. For probably not the undergrad, but certainly at the grad level, right? So I kind of want to use that to set the tone also, so you guys understand that the vocabulary is a little bit more important in this chapter, okay? But it's something you'll develop over time, but just keep that in mind as we go forward, because I'm very careful about that. Okay, so I use, maybe this is a little bit out of sequence. I should have had this chart first. But again, I'm using this to show you guys, right? This is clearly a linear relationship, right? What about this? What do you guys think about the chart on the left? It's not a line, right? But you're still using an X and Y. You're still using a formula, right? An algorithm to come up with this line, right? So that's an example of an X squared regression, right? I mean, that's essentially your first polynomial regression. And just so we're all clear on that, right? When we're referring to polynomials, we're referring to like a square or a cube or something of a particular X value, right? Of your independent variable. So this is kind of like your first, and kind of like your most basic model for polynomial regression, X squared. So instead of y equals mx plus b, as we've seen before, it's y equals mx squared plus b. That's all it is. That's all we're talking about in polynomial regression. So knowing that, what can you tell me about the graph here on the right? I'll give you guys a minute to think about that. Just give me your explanation. What is your take on the graph here on the right? Rahul says, aha, I knew it was a trick question. That's right, Rahul. You guys should know me by now. You guys know I like to, throw in a couple things to make you think. But what do you guys think about the right chart? What's the right chart? Hey, Patrick, good to see you. Patrick is also one of our moderators. So guys, if you see Patrick, Rex, or Joseph's, give them a shout out. If you see them here on the Discord, they really help me out with the moderation on YouTube and on Discord and on Twitch. So thanks to those guys. Give them a shout out when you see them. Sarvesh says should be x cubed. Yep. Anybody else? Anybody else agree with Patrick or Sarvesh, or they want to give a different answer? Maybe this is a trick question. You never know. Got to keep you guys awake. Anybody else? Okay. Manoj says, is it logistic regression? Okay. So Manoj is asking an interesting question there. Is it logistic regression? If anybody in the chat wants to contribute to that answer, let me know. Rex says, Patrick and Joseph, thank you both for your help in Insight Data Science. Yeah, thanks for the shout out there, Rex. I really appreciate all three of them and their modding capabilities. Leo says nonlinear regression. Yeah, you're right, Leo. It's not a line, right? It's not x equals y, right? Or excuse me, I said that backwards. Y equals x, right? Sarvesh says, or it could be x to the n with n being odd. Okay. Yassine says, agree with Patrick. Yep. Okay. So, good answers here. I love the chat. Let's tackle Manoj's question. Is it logistic regression? This is a nice little Manoj. I'm really glad you asked this question because we're kind of like doing a little bit of review, right? Ashish on Instagram says, "What's the question?" Ashish, I'm showing some diagrams up on the screen, and I'm asking what you think the right diagram is. Ashish, I see that you're on Instagram. Feel free to switch over to YouTube where you can see the diagrams a little bit better, or you can stay on Instagram. Appreciate your support. But just letting you know that on YouTube, it'll be easier to see the rest of the class. K Asabre says x cubed. Okay. All right, yeah. So let's leave that for a little bit. Let's ask a second question. Let's help Manoj out here, right? Is it logistic regression? If you know logistic regression, right, from our previous classes or maybe your own study, there's something in here that would prevent this from being logistic regression, right? There's kind of a giveaway here. Leo says, yeah, one of the things is to find a better relationship between the variables. Yeah, Leo, yeah. That basically sums up a lot of the items we're going to cover today, right? That's what I mean about the visual side, the creative side. So we're going to get a little bit more into that, Leo. Yassine says, isn't the logistic regression considered a linear method? Yeah, you could say that. But there's another giveaway here. See, Manoj is not fully incorrect, right? His instincts are good because he knows that there is a curve to the logistic regression model, at least to the final answer, right? Because remember, logistic regression, the final answer you get in logistic regression, it's I think it's considered like a log, right? It's a log of your regression value, right? Ah, okay, Ashish and Patrick are hitting on something very key. Rahul's got it too, yeah, right? Logistic regression, we know has a range, right? Logistic regression is range bound because it's basically a proportion, a probability, right? I shouldn't say proportion, it's a probability, right? So this can't be logistic regression because we're modeling negative values. So Manoj, I love the question because it gives us an opportunity to review, but it also gives us an opportunity to kind of draw that distinction between the graphs that we see. Because on a graph basis, it is tempting to say, yeah, this looks like logistic regression. I totally see, why you said that answer. I get it, right? But we also know that logistic regression is range bound, as Patrick and Rahul, figured it out, right? That this can't be it because it's 0 and 1. It's between 0 and 1 for the values, right? So Sarvesh says, agree with Patrick. She says sigmoid curve does that job. Yep, that's true. That is called the sigmoid curve. And Leo says the binary aspect of logistic regression. Yeah, right. The binary aspect is still referring to the 0 and 1 range. So Manoj, I love that question, but I hope you understand. I hope that clears it up for you. Manoj says yes, thank you. Okay, cool. All right. So yeah, so most of you landed on it correctly, right? This is x cubed. But I'm really just showing you this, to Leo's earlier point, that it's about understanding the different relationships that data can have. The different relationships between x and y. And when we say the different relationships between x and y, we're really saying the different relationships between your independent variables, what you're using to predict, and your target variable, what you want to predict, right? And that's kind of how the world works, right? There could be any number of features that have a variety of relationships to whatever it is that you're trying to predict. Because again, we just said the world is not linear. The world is not always y equals x, right? So that's kind of like, where we're going with this. And why today I just feel so much more visual, right? Because these patterns are the way I was taught. And the reason, and by the way, I should have started with that, sorry. But the reason I did this chart is because I don't think the authors did a good enough job of kind of walking you through these charts. But when I did my graduate studies, there was at my school, I went to Penn State, and at my school there's a dedicated regression methods course. You do nothing but regression methods for an entire semester. And this is one of the things, this is how I was taught, where they just show you the different graphs. Just, what does it look like when you're talking about x squared? What does it look like when you're talking about x cubed? Because then it's up to you to remember that. And the next time, you're looking at different plots, you can say, oh, wait a minute, I kind of recognize that relationship. I kind of recognize those plots, right? I mean, that's kind of the essence of polynomial regression. Fitting your data to like the different potential relationships. Okay? All right, let's see what the next slide holds for us. So here, I'm showing even more of the different graphs, right? These are additional x cubed graphs. But I'm using this to illustrate how you could also be adding additional modifications, right? So here it's x cubed minus x. Here it's just x cubed, and here it's x cubed plus x. So you can use additional factors to help you shape your line. Because remember, at the end of the day, you're just trying to pass your graph through the existing data, through your ground truths. That's kind of like that's kind of like what you're trying to model, right? How can I pass a shape through my data with the least amount of errors? Right? That's kind of what we've been doing. It's just that instead of straight lines, now we're dealing with different lines. Right? I mean, I think you guys can see that. If we were to go back to our previous chart, right? You could say that about this chart, right? What is the path I could take through my points, through my ground truths, and have the least amount of errors? That's what we've been doing, right? Because as we know, these black lines represent your errors. And from there, you can get all the metrics we've been working with, RSS, MSE, R squared, right? So when we look at a chart like this, where am I? So when we look at a chart like this, it's really no different. It's just that it's not a linear equation anymore, right? Life is not a straight line. The world is not straight lines. All right? So let's revisit this. So coming back to my earlier point about vocabulary, right? Previously, I asked you which one is their linear relationship, right? So now I want you to take a look at this chart again. And I'm asking you, where is the regression relationship? I'll give you guys a moment to think about that, because we just went over a couple of new charts, right? A couple of new patterns. What do you guys think? Okay, Leo says 3 and 4 again. I assume you mean the second row, right? The 3 and 4 in the second row, Leo? Okay, yeah. So Leo says second row, 3 and 4. Anybody else? Give you guys another 30 seconds here. Okay. So Patrick says agree with Leo and maybe 1-1. Okay, so Leo and Patrick, tell me the relationship that you see. Like, what is the pattern that you see there? Because remember, we're kind of like doing pattern matching at this point, right? I just showed you what the x cube, or excuse me, the x squared looks like, what x cube looks like. You can modify those with additional parameters, right? What do you guys see there? Yassine says, agree with Leo plus first row, first column. Okay, Yassine. So while Patrick and Leo think about 3 and 4 in the second row, Yassine, tell me what you see in 1-1 in first row, first column. What do you see there? Hey, DevEV, thanks for joining. I see you're on Instagram. Feel free to join us on YouTube if you want to see the widescreen view. It's a little bit easier to see the charts, okay? But thanks for joining us. But what do you think, Yassine? What's catching your eye about 1-1? And same question to Patrick and Leo. What are you applying there? What are you applying there to second row, 3 and 4? Let me know the pattern that you're catching, right? You gave me your answer. Now I'm asking for your rationale. Or anybody else who wants to participate, feel free to give an answer or feel free to agree with one of these guys. So Patrick says, I'm seeing parabolas, maybe an x to the fifth in the 3 and 4 on the bottom row. Okay. Okay, cool. I'm loving the x to the fifth contribution. Okay. Leo says the curvature, I'd say it shows a more complex relationship between the data. Okay. Manoj says no linearity. Now, Manoj, are you saying that across the board? And remember, we're not necessarily looking for linear relationships, right? We just went over some new charts that kind of should open up besides a straight line. I agree with you that there was no linearity when I first presented this to you. But I've shown you, give me just a second. But I've shown you at least 2 new patterns, right? So as Leo and Patrick pointed out, they see a parabola. They see an x squared, right? Or there's these where you can modify even further, right? So think about that one, Manoj. See if you want to revise your answer. Okay, so random seed 42, welcome. I don't think I've seen you. 1-1 lock. What the heck is that? Cannot be auto saved. That's weird. Let me save anyway. Oh, that's weird. That's weird. I don't never gotten that message before, but the file is still working. Weird. We'll just go on. So random C42 says 1, 1 looks like the positive side of x squared. Okay, yeah. Anybody agree with that? Patrick says, I agree with random C42. Yep. Sarvesh says, in the plots 1, 1, 1, 2, 2, 3, 2, 4, there's too much spread. I think any regression model would give a poor fit. Oh, okay. Okay, so Sarvesh is basically saying you're all wrong. You're all wrong. There's nothing there. Right? What do you guys think? But I hope you guys are starting to see that this is kind of like the beauty of data science, right? Sarvesh is saying, no, there's nothing here. Patrick and Leo are saying, no, I see a parabola. I see a parabola here. Right? Who was it? 42 said, I see a parabola here, just half of it. Right? So this is part of those discussions, part of that creativity in data science, right? Like, we're basically doing pattern matching here. So the way I match it, the way I see it, may not be the way you see it, right? I mean, who saw that there's a parabola here, or a potential parabola here? I'm being honest, I didn't. But, yeah, I kind of see it now that Patrick and Leo pointed it out. Right? So I hope you guys are starting to see that, this conversation and this back and forth is kind of like part of being a data scientist, how you're going to talk things out, how you're going to think about solutions and kind of work through the different possibilities. This is part of the testing, part of the experimentation, and so on. Okay? So building on that, I'm going to give you my eye. My eye tells me that I really only see one potential for relationship. And that's 1, 1. I'm seeing an x cubed here, right? Because I'm seeing a relationship of the scatter plots that gets steep very quickly, right? That's a very steep relationship between x and y, between my independent and my target variable, between my predictor and my target variable. So that's where I thought, because if I look at that and then I look at, let's say something like this here, the x cubed plus x, I kind of see that relationship, right? Now, let's focus on the bottom one. 2, 4, right? Yeah, I kind of see a parabola here. Parabola here. But the challenge with the parabola, and even with my answer of the x cubed here, and by the way, whoever said that there's a parabola here is probably not wrong. I mean, I can see a parabola here too, right? But the challenge with the parabola and the modeling in this one is that if we mentally draw a parabola here, what about over here? What about over here? Those basically become errors, right? Those become errors in your model. Same thing here, right? Even if we were to draw an x cubed, you still have quite a few errors to the side, on either side on that, right? So what that tells me is that there's a potential for a model here, but it's probably not going to be a very accurate one. We can visually see that even in the best path, you're going to have plenty of dots, plenty of ground truths that are going to add to your error function, right? To your error metrics. So yeah, I see the parabola here, but probably not a very predictive one. Because you have this noise over on the sides, for the different ranges or extremes of the latitudes that are going to give you a lot of errors. Because every dot over here is going to be really, really far from that parabola, right? And that just adds to your error metrics. But these are the things that you should be going through when you're kind of, figuring out, one, is there a viable model here? And two, what does that model potentially look like? So those are the things that you kind of need to start thinking about. Here's a third thing to consider. And this one, I'm going to give you caution before I tell you this one, because this is kind of where you're potentially introducing bias into your models. The third item that you could consider, if you wanted to, is to think of is to add the domain knowledge, right? And we know that this is a housing set, and we know that the target is about the price, or the price or the value of the home, right? So if we're stuck between this one here, 1-1, which has gotten a lot of attention from a lot of people in the chat, versus 2-4, if we wanted to, we could also say, well, wait a minute, this is median income. That's my X, that's my predictor. Does median income have an effect on price on the value of a home, the price of a home? Yeah. Higher income people can afford higher priced homes. This one here, we know it's the longitude. The longitude is being measured against the target. It's being used to predict the target. Is it possible that longitude has an effect on housing price? Maybe, maybe not. But again, that's kind of like my bias, right? You're kind of starting to introduce your bias a little bit there, right? So you kind of want to be careful on that too. But there is like this balance, like this teeter-totter you have to find between, like, does the independent value that I'm singling out even make sense? Median income, yeah, that makes a lot of sense. Longitude, maybe not. Could I transform that to both include latitude and longitude? Maybe some combination of those will help, right? Like maybe, I don't know, maybe like categorical by geographic location inside a city. Maybe you're on a better track there, right? But is longitude alone likely to be a really good predictor of pricing? You're going to get some pushback, right? Your stakeholders are going to tell you, wait a minute, that's kind of a crazy relationship. So think about that also, right? So I hope that helps you guys. Let's see what the chat says. Leo says, I think the next step would be testing and applying polynomial features to see who's closer. Yeah. Yeah, Leo, this is part of the testing, right? Remember, to a large degree here, what we're still doing is a little bit of feature selection and seeing what those potential relationships are, right? Maybe they're there, maybe they're not. Who knows? Let's find out. So yeah, to some degree, you're kind of narrowing it down and saying, okay, well, now I got a couple experiments to run. So yeah, Leo, you're on the right track with that thinking. Okay? Rahul says, it would be interesting to see the graph at 2-2, average occupancy versus target, with the 4 outliers removed. There's a possibility for the regression model. For 2-2. Yes. Excuse me. That would be interesting. But on a single predictor, though? Or excuse me, on a single value for X? Or it could be that this scale could have been done better, right? The outliers are throwing off the scale. So Rahul, we'd have to take a second look at that. I mean, I like your overall thought pattern. But what this is telling me, though, is that this one outlier in particular is throwing off the scale. Because then look at how many values are between 0 and 200. So my gut tells me that if you remove that outlier or all the outliers, you're going to end up with something like the one right above it. It could still be a noisy data set. The relationship just exists because it's so compact, right, according to the scale. So this is another thing you guys got to consider, right? Do I have valid plots to work from? Maybe I don't, right? So that's something that you guys kind of need to think about also. Do I have do I have a good plot to work from? So here we're being thrown off by the scale. I bet that if we just went 0 to 200, you'd probably end up with something like this because there's just so many points between those two values. But we'd have to find out, right? When I say that, I'm just presenting a hypothesis. We'd have to vet it out, right? Again, this is all part of the data science process, part of the experimentation you have to do. So I appreciate Rahul's view on this, but that's what my gut's telling me, that it's going to be a noisy data set. And really, a lot of these are noisy, right? I mean, certainly 1, 2 is a very noisy data set. And 3 and 4, down here, they look noisy, but, I can appreciate why Leo and Patrick can see a parabola here. I get it. So I don't think we're walking away just yet with any clear answers, but that's okay. That's part of the process, right? Science doesn't always have clear-cut answers. Algorithms don't always give you clear-cut answers. They give you probability-based answers. So it's okay for us to say, yeah, you know what? We've made some observations. We need to do some experiments, and we iterate off of the results of those experiments. That's totally valid. Okay. All right. So I hope you guys are still with me. Give me a 1 in the chat, or a 0 if this is making sense or not. Give me a 1 if you're on board with me, because we're about to close out polynomial. All right, so I got some formulas up on the screen. So give me a 1 or a 0 if you're on board with me so far, or if I've lost you, right? And then also on the screen, give me the invalid formula for regression. All right, Michael says he's still with us. It's making sense. Thank you, Michael. Give me a 1 if you're on board. This is all making sense. Give me a 0 if you're maybe a little lost. Either one is okay. All right, it looks like people are on board with this. Good, good. All right, so now considering the formulas on the screen, give me the one that's an invalid regression method. Okay, my nose is still with us. Good. Rahul says, I think all the equations shown are valid. Is he right? Does anybody agree with Rahul? Hey, Muddy, welcome. Muddy, I see you're on Instagram. Feel free to switch over to YouTube if you want the widescreen view, okay? Patrick agrees with Rahul. So, Leo, you think it's the first one? Is that right? Leo says there is no linear regression. Okay, so Leo, I'm sorry, just to clarify, I meant just valid overall, not necessarily to the charts we just saw. So I think you might be saying that there is no linear regression in the previous charts, but forget the previous charts. Here I'm just talking in general. What's the invalid equation that's up on the screen? Two and three is a special case of four. Okay. All right, anybody else? There are 10 seconds here. Leo says, I don't know if 4 is valid. Okay, anybody agree with Leo? Anybody have that same doubt as Leo? Four is a bit weird because of the subscripts. Yeah, but the subscripts like that are common when you're doing, multiple features, right? Mac isn't always the greatest for writing out formulas like this. Okay, so it's possible that the subscripts are throwing you guys off, but I'm really just using it to indicate different features, right? And different weights. Um, so the answer here is that these are all perfectly valid regression approaches, right? And really honing in on number 4, what I'm trying to illustrate there is that you can have a combination of all of these, right? You can have some features that are going to be squared, others are going to be cubed, others don't have to be modified at all, right? You can have any number of combinations. So these are all perfectly valid approaches to regression models. All of these will give you some sort of answer. It's just, it's really more illustrating the creativity that's gonna be required for you to take that. Because we know that we can do regression with single values, like our classic y equals mx plus b. But we can also take that one value and square it or cube it, or we can also put it in a chain with other features, right? And have a multi-feature model. That's totally valid too, right? You guys with me on that? All of these are perfectly valid. Are you guys good? Yeah, so that's the last on polynomial regression. Now we're going to talk about step regression or step functions. So with step functions, the best way to explain that is to do it with a chart. And this chart here demonstrates step functions. Both of these charts do. And step functions basically allow you to have different operations against your predictor variable based on the value of a predictor variable. So you can literally see how there are steps here. So here we have a step up, here we have a step down, and it's all based on the range, or excuse me, on the value of your predictor, of your x-axis. So here it's showing age versus your salary. So here they're saying that there's a rise at a particular age and there's a significant fall at a particular age. So therefore this fits a stepwise model. Right? That's basically kind of like what we're illustrating here. So when you think of those stepwise, you should be thinking of a regression approach where you're still putting a line through your data, right? You're still finding a path through your data. But now that line has different levels to it based on the value of your predictor. So if we go here, you know, if you got, I'm pulling this straight from the book, obviously 7.4 if you want to look at it. The authors illustrate it with these formulas. And wherever you see a C, the authors refer to that as a cut point. So you can think about it as a cut point, as a step, you know, a cutoff, whatever is easier for you. But you can see here that they're saying, these are the values that I want you to use when X is less than this, or when X is between this, or X is, you know, between this on a higher value, right? So that affects what that path through your real truth looks like, right? Because remember, that's all we're doing, right? We're trying to find the path through our ground truths that have the least amount of errors. That's really all that regression is, right? So sometimes it's a stepped path, and those steps are referred to as the cut points. Okay. Michael says, please come again. Michael, give me some more information. There's something there that's throwing you off. Let me know. Okay. Kabir, welcome. Hope you're well. Kabir, you're on Instagram. Feel free to switch over to YouTube. There should be a pinned comment on Instagram. Okay. So Michael, let me know if there's a particular point that's kind of getting you stuck. But I want all of you guys to think about this bottom question here. Does this remind you of anything in code? You know, I know many of you have have programming experience, right? Most of you know Python. Does this remind you of anything in code? What do you guys think? Okay, so Michael says, the definition you gave for step functions. Okay. For my second question about remind anything in code, Rahul says, optimize equations with boundary functions. Yeah, Rahul, you're thinking a little bit too much on that one. Think about it a couple levels down. Okay, so Michael says he's having trouble understanding the definition for step functions. Okay, so let me go back because he's probably not the only one. So Michael, let's focus on this graph here. Okay? And this graph is plotting your age versus your salary. Right? So the data says that once you're past like 30 years old, there was a significant increase in your income. And once you're past 65 years old, maybe when you're in retirement, there's a decrease in your income. So it's really hard to model that, right? It's really hard to model that with a straight line, certainly, right? With a linear regression, right? Because we already said linear is y equals x. I'm not seeing a whole lot of a polynomial relationship, right? We already know that y equals x squared is a parabola. These ground truth points, these gray points, don't look like a parabola, right? There's also no cubed here, right? Because a cubed is more of a steep line, and that wouldn't fit a lot of the points. So not everything is polynomial, right? Not everything is linear, not everything is polynomial. So sometimes you need to do a second path, and it's called a step path. Because you're going to have these cutoff points that the author refers to, where you need to treat the weights, the coefficients for your x values differently at different steps. Or excuse me, for different values of x, for different values of your predictor. So in other words, the coefficient is not static throughout, right? Y equals mx plus b assumes that that coefficient, is always static. It never changes. Stepwise says, no, we can change it, and we'll change it based on the value of x. So that m value is going to have different coefficient levels based on your value of x, driven by your value of x. Okay, Michael, let me know if that clears it up for you. Okay, so Patrick says, if then else statements. Yassine says, switch case. Yeah, that's it. That's exactly right? If you look at this next page, doesn't this look exactly like something you would use to write your if statements or if else statements, right? When x is lower than this, and then when x is higher than this, but still lower than this, and when x is right? That's kind of what you're doing. That's kind of what you're doing in a statistical way, right? You're kind of doing that in a statistical way with this formula, with this algorithm. That's basically what the algorithm does. The algorithm helps you find where those cutoff points are, which you can think about as a separate if-else, right? Or as Yassine says, a separate switch case, right? This will be a separate case, right? Your cutoff points are essentially your case statements. But you're not doing that explicitly. You're letting the algorithm do that, right? The algorithm determines what they are, and then the algorithm runs it, right? So I'm not telling you that we're going to write if-else statements. That's not the point here. The point is that, again, you guys know I advocate not having to know the math, right? But what you should know is what's happening under the hood, and that's what's happening. Those cutoff points are being determined, and then your coefficient values are being determined as x, right? Because the if in this series is what is the value of x. If x is this, if x is lower than this, if x is higher than this, right? But if you guys can see that relationship between this and an if-else or a switch case statement, then you're on the right track to understanding what step functions do. So good. I'm glad you guys can see that, because that should be popping out at you. And that's as complex as we need to get for step functions, because that's really just what you need to understand. That x, the coefficient of x, can be a dynamic value based on x, just as you would with a series of if-else statements. Okay? And now we're going to talk about the third method that the authors present for nonlinear data. And those are splines. So again, I'm pulling this straight from the book, but you should be seeing the notion of splines should come at you pretty quickly, right? Because they're kind of helping you with the different lines that they're drawing. they're telling you that you can also choose to have different points in your data, in that path through your ground truths, where you kind of make these turns, these splines, right? So here in this first one, you can see that not only is this line have a couple of splines, but there is a significant spline at the 50 value for x, where the pattern completely changes. Or down here, this is an exaggerated example of a spline where up to 50 there's a line, and then after 50 there's also another line. So you can have like these inflection points along your path that lead to a better model. Because again, all we're doing is reducing errors, right? You're reducing the distance between your ground truths and your model that you want to use as a predictor. So this is telling you that after 50, you are better off using these lines because they will lead to fewer errors than the line you were than the pattern you were using prior to the 50 value, but when x is less than 50. Sorry guys, I apologize. That came out of nowhere. I think I'm getting allergies or something. So when you're thinking about a spline, you should be thinking about these lines that have these inflection points at various times, because there's something significant. Excuse me, everybody. There's something significant that's happening at those splines that will reduce your errors if you take a different path at that point. That's basically what you're doing. Sorry, guys. That's basically what you're doing in a spline approach. Okay? So the authors, excuse me, and this is a secondary explanation of splines. Here you can see that there's more than one significant value, right? So here they're saying at the 25 value for x, at the 40 value for x, and at the 60 value for x, you need to add splines because everything below that or everything prior to that was not as effective. Okay? So, pulling from the authors, each change in that spline, it's called a knot. But then the question is, how do you know where to place the knots? Right? You kind of have to determine that. Or how does the algorithm, the formula know that? Right? So, again, just to reiterate, with splines, you're saying that you could have these different inflection points known as knots, right? I call them inflection points, but I should say knots. And those knots are where the pattern changes. Where you're going to say, well, no, when x reaches this value, I need you to do this instead. As is illustrated here, right? So here we can say that this model has three different knots. There's a knot at the 25 value for x, there's a knot at the 40 value for x, and there's a knot at the 60 value for x. And all of that is determined by the pattern, the path through the ground truths that minimize your errors. May not be like an error-free path, but it's the path that minimizes your errors. Remember, we're always minimizing our errors, right? We're always wanting to make those metrics as small as possible. So, degrees of freedom is an effective way to find the number of knots that you need. So here, we'll just focus on this chart here over on the left side, the red chart. So here we're saying that the mean squared error changes according to the number of knots that you have. So this is what the error is at 1 knot, right? Which is not great. In other words, that's just one single path through the line, through the data points, right? And that's not saying it's a linear relationship. It could still be a parabola or something else. But it's just saying that if I do a parabola and nothing else, there are no knots, there are no changes to that path. That's your error. That's your mean squared error, your MSE, which we've looked at before. But what if we allow 2 knots? Well, now we're getting an improvement because now that's saying that the data is broken up far enough where you can have a second pattern that fits the overall data better. Well, what about 3 knots? Well, now this is telling you, okay, yeah, you get even better. Well, what about 4 knots? Not a whole lot of an improvement. Well, what about 5 knots, 6 knots, 7 knots? You kind of keep on going, right? You kind of keep on going to figure out what exactly the pattern of that line looks like. Some of it might be straight. There might be points where you have a linear relationship, and others might be more curved, right? Like if we go back to that chart, right? Look at everything below 25. That's a linear relationship, right? Look at that red line. That's completely linear. But it's not after 25, right? After 25, it takes more of a curve. And then after 40 and 60, that's pretty flat, right? And then at 60, you kind of have a downward curve. So looking at the degrees of freedom helps you understand how many knots you should have, how many of those points happen for all of your data. Okay? Let me take a quick look here. Okay. So again, if we know that the degrees of freedom helps us figure out the number of knots that we can have, is there a danger here? Do you guys see any problems with this approach? I mean, it's good for us to want to go through our pattern, our data, and find the best possible pattern, right? But is there a danger here? Are there any risks that we run here? Give you guys some time to think about that. Rahul says, how to know that we are not overfitting when using more knots? Okay, anybody else or anybody agree with Rahul or anything else? Any other thoughts? What do you guys think? Leo says, went for a call. Amrapali, good to see you. We are trying to overfit. Okay. Anybody else? Last call for answers? Okay, so Amrampali and Rahul basically have hit it on the head, right? That there is definitely a danger of overfitting here. Because remember, this is all testing data, right? This is all, all your training and testing data. But in the future, when you're making predictions, it's possible that you overfit the model to that data. And you definitely run that risk with the higher number of knots that you have. Because in theory, you could have 1,000,000 knots, right? And every single point would be like would have a change, right? Every single value of x would have its own cutoff points and its own values, right? Like you could literally draw like you'd end up with like a really funny zigzag line, right? But you could do that. You could have a knot at every value of x and then have this model that, lowers your error rate. But it might not do so well in future iterations, right? The overfitting is definitely a danger there, right? So that's something that you kind of need to consider in the future, where you kind of have to take the lowest number of knots that still give you a relatively good result. So here you can see that at the value of 3, everything else after that is kind of like, not a significant change, right? So you kind of want to use 3 because anything else above this is not a significant change, but you're increasing the risk of overfitting. Because the more knots, the more zigzaggy, the more perfect that line becomes. So that is definitely one of the dangers here. Let me go to the next slide because I do point that out. So so this is why smoothing splines exist. Right? This is where in the book the authors make the transition to smoothing splines. Smoothing splines, excuse me. If you just continue to use splines and knots, then you run the risk of overfitting the model. You can just use as many knots as you want, right? Just go to the previous chart and then just pick the maximum at like 8 and say, well, I'm just going to have 8 knots, right? But the smoothing splines help you control that because they're going to find you the best path to minimize the error metric, and it has a lambda hyperparameter that you can use to test with. Because the lambda kind of helps you temper those knots and helps smooth out the line in between those knots. And by smoothing out the line, you're potentially improving your error metrics. And again, it's always good to have hyperparameters, right? Because we're always looking, as I said earlier, the levers to pull, right? You always want to have levers to pull because as long as you have levers to pull, you have experiments to run, right? So this here is an example of a smooth spline with the previous data that we were looking at before, your age and your wage, right? So we went from this, which was using 3 knots, to a smooth spline that looks like this. And this is after tuning, after your hyperparameters and all that. So you can do as much work as you want with splines. There's nothing wrong with that. But the smoothing splines are almost like a check for yourself to make sure that you're not overfitting the model. Okay, super important to remember that. All right. Rahul says, also, can you please clarify why we're using MSC? I mean, we could easily repeat the same AI CBSE and may show different best number of knots. Yeah, that's totally fine. You could totally do that. They're probably not going to be as divergent as you think they are, right? They'll probably be closer than you think they are. But yeah, if you want to use AIC or BIC, you can certainly do that. Or whatever other metric you want. The authors are just choosing to use MSC. I mean, these are not my charts. I'm pulling these from the books, right? The authors choose to focus on MSE. I'm on board with that. I understand the rationale for it. I use it quite a bit too. But sure, you can use other metrics. Okay. So I feel like I've thrown a lot at you guys in the last 20 minutes here. And that's okay. It's totally okay for you to be a little bit lost now, because I think that encourages you to kind of take a step back and be able to go and think about these things, right? Do your work on your own. Do research on your own. Go read the book on your own. That's very healthy for you to do, right? But I'm just helping you understand that there's multiple paths through your data. And that's ultimately what you're trying to do, right? What is the path through my data that helps me minimize my errors? And notice that I'm saying path. I'm choosing that specifically. I'm not saying line, because not everything's a linear relationship, right? We established that at the beginning, right? So keep that in mind, okay? Rahul says, I meant what is more practical in a job world, MSc or something else. I don't think there's a better best for this. It's to some degree, you just want to make sure you're using a valid approach, and you also want to be consistent with what you're using, right? Don't use MSc early in your testing and then switch to AIC later on, right? As long as you're consistent with what you're choosing, that's really all that matters. Don't overthink it, Rahul. Just choose something and use it as your baseline. At the end of the day, it's just a number, right? It's just a number that you're using, that you're comparing against. Did I do better or did I do worse? And whether that number is MSc or AIC or whatever, who cares, right? Did I do better or did I do worse? As long as you're consistent with what you're choosing across experiments, then it's just a number. It's just a value to compare against, okay? So the authors close the chapter by talking about local regression and generalized additive models, or GAMs. So here is where I'm going to divert from the authors, because my real world experience has taught me that if you can't get to an answer with these methods, to a reasonable model with these methods, then you probably have another kind of problem on your hands. It's likely that it's not a regression model, right? You kind of have to, because remember, regression models is still just one family of models. There's others, right? There's plenty others to choose from, and we'll talk more about this in the coming weeks, right? But that's why I've kind of put local regression and generalized additive models out of scope. Because if you've done all of these, right? You've done linear, you've done polynomial, you've done your step, you've done your splines. Like, what other signs do you need that you need to move on, right? Like in the workplace at that point, your boss is going to be telling you, okay, stop regression, let's do something else, right? Like you don't need to keep on beating on that same problem. If you're just seeing, very small or no changes to your baseline model, right? So that's why I'm going to kind of put those to the side. You're welcome to read them, on your own time. But, I've never really used these because, again, by the time that you get to this, you've already tried, 4 different regression approaches? And if you haven't improved, then hey, it's time for you as a researcher to use your own reasoning and say, okay, well, maybe regression is not valid here. That's totally okay to reach that conclusion after you've documented and run those experiments, right? So again, you're welcome to read that. Obviously they still present some good info in there, but my real world perspective is that they kind of fall out of the scope for the session that I want to run today. All right. Okay, so I believe that after this, we are ready for going into our coding, right? So as the same as before, what are we optimizing for? And again, Rahul, coming to your previous question, right? That's one of the reasons why I always put that at the very top of the framework example, right? Because I want to be consistent in what we're comparing. So what are we optimizing for? What error metric are we choosing, basically, right? Sorry, guys. I must be getting allergies or something. Some dust must be in the air. Ugh. Second part is, what does the code look like for all of this, right? We're going to be code editors, not code writers, right? Because we're preparing for the future here, right? AI is part of our future. So we're going to actively choose to use ChatGPT or other AI tools to help us write the code. Okay? And we're going to be working with a couple of examples, right, in our lab. Professional level development environment, appropriate data set, and then we're going to use polynomial regression. If we have time, we'll go to ridge regression. Because another thing I want to do is I want to do a lot of plotting. And personally, I'll be honest with you guys, plotting is not one of my strengths. I know Matplotlib just a little bit, just enough to be dangerous, but not a lot. I'm happy to call myself terrible at it. I've never been a big plots guy. I'm more about, outputting and looking at, different portions of my data, portions of my data frame. I'm really big on outputting to the console and kind of reading it from there. I'm more of a reading guy than I am a visual guy. So we're going to do some plotting, right? And I might make some mistakes, and I'm just not really good at it, right? But let's try it, right? Obviously, we've had a very visual chapter, okay? All right, so like I said, I feel like I've thrown a lot at you guys in the last 20 minutes. Does anybody have any questions or any doubts they want to clear up before we move on to the coding portion? It's possible that we might just do polynomial just because, I feel like it's been a little bit of a heavy session. But let me know what you guys think. Are you guys okay? Are you guys on board? Any questions? Give me some feedback here. I'll give you guys a minute or so to think about that. All right, Patrick says that he's on board. Don't be embarrassed. It's totally okay to say you're lost in a couple things. If I can clarify some things, I will try, or otherwise we can take it to the Discord after the class. But anybody else agreeing with Patrick? You guys on board? Did I lose you guys? Are you guys asleep? I'll concede this isn't exciting stuff, but this is part of the data science work, right? Muat, for right now, we're still going through the class. Feel free to ask me that question later, but let me just focus on wrapping up the class here, okay? But welcome. Rahul says, I'm on board as well. In fact, I am finding it interesting, have so many questions. Yeah, I think it's an interesting chapter too, right? Because again, it's just pattern matching. Just helping us kind of see where different data points lie, right? Amram Pali says, all good, okay. Anybody agree with Amram Pali? You know, last week, people took some of that work, like Yassine, and then he posted on Discord and said, hey, I was thinking about Sunday's class and here's what I came up with. You guys are also welcome to do that, right? You guys are also welcome to say, okay, I might not participate in the chat today, but I might post something in the Discord later on this week or whatnot. That's totally okay. All right, so I'm going to keep an eye on the chat in case anybody else wants to raise their hand and say, that they're good or they're not. But let's go ahead and start looking at some of the coding side of this. So as before, okay, my note says I'm on board as well. Okay, cool. So as before, we're going to be using Visual Studio Code. I created a file for some